Good morning, good afternoon, good evening, and good night. A greeting adapted from the movie The Truman Show, starring Jim Carrey. And it works here since to each of you there is some relevance in that greeting. And hello, Kuala Lumpur, Sapporo, San Francisco, Wilkes-Barre, Thule, Dublin, Bruges, Cairo, and Mumbai. I'm George Proler, Chair of the Computer Society Distinguished Visitor Program, and it is my honor and privilege to welcome you to this, our second annual IEEE CS EXA DVP event, or as we call it, the 24-hour event. Second annual has a nice sound to it. At the beginning of last year, hosting such an event was just a thought. To extend an earlier project to cover an entire day, 24 hours of presentations, reaching and including our diverse membership. And quite frankly, we weren't sure if we could put it together. But Professor Hassam Fahmy, my predecessor, and Professor Islam Halim, chair of the Awareness and Customer Advocacy Committee, and his team rose to the challenge. And we did it. And it was successful. The first annual. And now, well, Professor Islam and his team have outdone themselves. Look at the agenda for the next 24 hours. Artificial intelligence, AI security and privacy, and research ethics in the area of AI. Quantum computing and the quantum world, smart and high performance computing, and the list goes on. And we are already working on the planning for the third annual event for next year, taking another step and upping the challenge for Professor Islam and his team, as we are looking to make this a hybrid event with on-ground activities concurrent and shared with the online participants and attendees. This event spans each of IEEE's 10 regions and the world's time zones, hence my adapted greeting, since each of you and the DVs, the presenters, the moderators, you all hail from different and diverse regions. And for some of you, it's 10 a.m., 2 p.m., 8 p.m., and 2 a.m., and all the hours in between. So it is morning, afternoon, evening, and night. Truly an effort of inclusion of our diverse membership base. Today is International Volunteers Day, which is fitting, since it has taken, and before this day is through, it will take the efforts of more than 50 Computer Society volunteers coming together from the Geographic Activities Committee, Students and Young Professional Activities Committee, and the Distinguished Visitor Program to bring this event to you. Over the next 24 hours, you will have the opportunity to attend more than 20 technical presentations on topics I've already mentioned, along with informational talks about the Computer Society and its regions, activities, and programs. Each presentation will be introduced by an event moderator who are members of various student chapters, and through participation in this event are gaining experience and opportunity. And then there is the audience. That's you. Many of you are members and affiliates of the Computer Society who volunteer your efforts to make local programs a reality. And all are here allowing us to bring this event to you. So thank you for your time. And now, before I wear out my welcome, I'd like to pass the baton to Professor Irinori Washizaki, the President-elect of the Computer Society. Thank you.
Hello, everyone. I hope you are having a nice day. It's my pleasure to start our part today from the IEEE Computer Society Distinguished Visitor Program, the EXA DVP event. The main theme of the event is to include all the IEEE Computer Society members around the globe to share their ideas and insights and to give some technical discussions, in addition to include the other OUs for the Computer Society, the SYB, and the regional coordinators. So it's my pleasure to be with you today. And as the chair of the Awareness Committee of the Distinguished Visitor Program, I'm delighted to introduce my colleague, Region 8, Dr. Katrina. Hello, doctor. How are you?
Hello, thank you very much for your introduction. And I'm very honored and happy to be part of this wonderful event.
So,
Especially, I'm very happy
for
that
those
it's...
who are not aware, Dr. Katrina is my colleague in the JAC committee. In addition to that, she has a great effort during this year with supporting all the computer society activity around the globe. Also, Dr. Katrina was for maybe 1986 in Macedonia. She started her studies at the Faculty of Electrical Engineering and Information Technology and Methods University in Skopje, Macedonia in 2004. She graduated at the same faculty in June 2008 with an average grade 10. She finished her master studies in May 2010. She received her PhD degree at the Faculty of Computer Science and Engineering and Methodist University in Skopje in January 2018. As the best students in the generation, she was awarded with an engineering ring by the Engineering Institution of Macedonia and with gold coin by the Cyril and Macedonia University. She obtained her initial working experience at the Faculty for Computer Science, European University in Skopje in 2000. She worked at the Faculty of Electrical Engineering and Information Technologies from October 2008 to September 2011. From October 2011 to July 2014, she worked as a junior assistant at the Faculty of Computer Science and Engineering. She worked as an assistant at the same faculty from August 2014 to April 2018. She was promoted to assistant professor at the same faculty in May 2018. In addition to that, Dr. Katrina is the area coordinator for Region 8, in addition to leading her chapter in Macedonia, the Computer Society chapter, of course. So it's my pleasure to introduce you, and the floor is yours.
Thank you very much. I will share the screen now. In the meantime, I wanted just to express my gratitude for inviting me to this event and to be part in general of this event. And I'm very happy that especially that this event is happening for the second time after the first very successful event. So I hope that the tradition will continue and will organize even more such events.
Thank you.
I hope that you can see the screen. Can you see the full screen presentation?
Yes,
Okay.
yes.
Great, great. Okay, so during this presentation, I will talk about the computer society activities in Region 8, aiming to emphasize part of the activities that were organized by this part of the IEEE family. So, as most of us know, when we talk about Region 8, in fact, when we say Region 8, we talk about the professionals and enthusiasts from this part of the map, in fact, namely the orange one. That covers the region of Europe, also Middle East and Africa. So it's a great part of the globe and very big part. So we can say that we are very happy to be a big subfamily from the whole IEEE family. So in fact, it is focused on namely this part is focused on the largest global community, the computer scientists and engineers in this part that hopefully communicate and collaborate also with other parts. Generally speaking, IEEE Computer Society is the trusted organization delighted to engaging the engineers, scientists, academia, and industry professionals from across the world. Just to give a full context of this presentation. And the ultimate goal is to drive the advancements in computer society and technology. In fact, when we talk about IEEE Computer Society in general, there are more than 3,700 community members. Also 157 countries with computer society members are part of this community, and the total number of chapters is 936. So let's focus now on only on Region 8 Computer Society members. So this is the part we are talking about. And we can say that there are different numbers of computer society members through different sections, as can we see from here, and leading in a total number of 11,490 computer society members in this region. So just to emphasize the sections that have the highest number of computer society members, here are the top 10 sections on the basis of computer society, of the number of computer society members. So Tunisia section is on the top, then United Kingdom and Ireland, Germany, Jordan, Italy section, then Turkey, Switzerland, Benelux, Spain, and France section. Of course, we are continuously working on increasing these numbers. So I hope that we'll succeed with. We'll have success. We'll have even more. Even greater success on that part. What I would like next to mention is in fact the whole team that is behind this part of the family. We are very happy to have our Region 8 coordinator, Islam Tarwait, who is very, very motivating and very inspiring when we have all those discussions through our regular meetings, and in the meantime, with all the conversations and discussions via the channels that we use for regular communication. I can say that we are really pleased to have such a great person to motivate and somehow lead us with all these things that we are all doing. As part of the whole board of the IEEE Computer Society Region 8, I can say that I would like just to mention and to clarify some things regarding the structural organization that we have in this region. In fact, there are six areas. Basically, this structure is based on somehow on geographical, mostly on geographical separation. So, as coordinators of these areas, I can mention for area 1 myself. Then for area 2, Elhad Banhelfa. Then for area 3, the coordinator is Sefedin Kadru. Then for area 4, the coordinator is Kostas Karpouzis. For area 5, the coordinator is Moyat Alojali, and for area 6, Ahmed Hassan. Also, we have very, very helpful vice chairs. In fact, we are continuously working together, and we have all the discussions during our regular meetings, very fruitful discussions also with our vice chairs. So I would mention here Zorica Bogdanovic as vice chair of area 1, then Margarita Trigo for area 2, then Francesco Flamini for area 3, Arehan Aydogan for area 4, the vice chair Larissa Abi Nal for area 5, and of course Alex Vatila for area as vice chair for area 6. Also, I would like to mention our young professionals coordinator, Osema Fituri, and also the coordinators of portfolio 1 and portfolio 2. So portfolio 1 is about climate and sustainability. And Sneha is our coordinator there, and for portfolio 3 for diversity, equality, and inclusion, Roa Tuhuri is our coordinator. Of course, students are a very significant part of this family. So regarding the student activities committee, our coordinator is Asah Alakami. All these people are continuously working to make some better things regarding IEEE computer society, with the ultimate goal for advancing the mission of IEEE computer society, to increase the number of the members, to increase the activity and spread the idea behind IEEE, to also lead all the initiatives aimed at fostering innovation and supporting computing professionals throughout, firstly, Europe, Africa and Middle East, and of course throughout the whole world. In the rest of presentation, I would like to mention just a few events, so to be able to make a big picture of what kind of events are organized as part of Region 8 Computer Society. But I can say that if I want to tell you and present you all the events that are continuously organized, half an hour would be not, of course, not enough to tell all those things, and all those fruitful discussions that we usually have, all the ideas that are spread. So I can say that I will just mention a few of them, and I hope that we'll continue to organize even more events and to bring IEEE to even more young professionals and engineers in general. So one of the events that was organized, in fact, returned in April 27th this year, was the TechX event organized by IEEE Young Professionals Lebanon and IEEE Computer Society Lebanon chapter. The event, in fact, was filled with insightful talks on software engineering, artificial intelligence, mentoring, and even more. And the ultimate goal was to support fresh graduates and industry transition and facilitate interaction with industry professionals. Now, to go further, I will mention the Sophia Tech team, and a big thank to the whole team for their sharing their expertise and for organizing an event that was really helpful for all present, for all attendees and all present in such a event. Next, I will mention another very big and very helpful and insightful event. In fact, it was organized as two insightful sessions that were on cutting edge topics in the world of technology and artificial intelligence. So it was organized by the end of at the end of May this year, and the first session was the topic of the first session was digital twins for trustworthy autonomy. It was the presentation and the whole talk was conducted by Francesco Flamini, and also the second session the second session was guided by Kostas Karbuzis, and it was about research ethics in the age of AI. So this was a really helpful, insightful event, and we'll hope that such an event will also happen in the future again. Next event that I want to emphasize is SYP event that was happening in Grenoble. It was organized by the IEEE Computer Society France section. It was an outstanding SYP event, an amazing experience to connect all the brilliant minds to share knowledge, feel the pulse of thriving computer society community. Also, one very wonderful event organizing by Computer Society as part of Computer Society in Region 8 was the second IEEE Computer Society Distinguished Visitor Program Region 8 webinar. And the guest was Professor Katarzyna Wak. She's the leader of the Quality of Life Technologies lab at the University of Geneva. Professor Wak is an expert in digital health with over 150 publications and very fruitful discussions regarding artificial intelligence and how artificial intelligence can enhance our quality of life was part of this webinar, in fact, webinar series. The event was hosted by the IEEE France section and co-hosted by IEEE Greece section, Nigeria section, Jordan section, and also Tunisia section. I would like to emphasize that such joint events are very welcomed and very helpful. Most of the time during our discussions, during our meetings, we came to the same conclusion that such an event should happen, and is very advisable to be organized to bring as more people as it is possible, and to spread cutting-edge technologies and IEEE ideas. So I hope again that such an event will be organized in the future again. Another event that is very interesting is the Let's Talk Computer Society event organized by a student branch with several sessions. One is Computer Society Mentorship session, Game Development workshop, Data Science workshop, Open Learning Day with several topics into it, and quantum computing workshop. So this event was organized in October with the aim to explore, learn, and connect with fellow tech enthusiasts. Another very big and great event was organized by the and supported by IEEE. It was supported by IEEE Computer Society to for Egypt's future innovators. And it was also organized in October. So IEEE should be very proud that IEEE Computer Set, in fact, should be very proud that supported such a very, very significant event, and the idea behind the whole event, in fact, a series of events was to support all the Egypt's brightest young minds, fostering innovation, collaboration, and also leadership. So from university students to tech enthusiasts, they have all worked alongside key initiatives to create opportunities and drive impactful changes. As part of these events, the Sustainable Multidisciplinary Advanced Research Trends Conference was organized and supported. Women in Engineering International Leadership Summit was also part of this event. SAC Egypt officers meeting, Space Apps Cairo, and also all that together with the IEEE Day celebration. Such an amazing event. You can also see, according to the pictures, that was full with enthusiasts, lots of smiles on their faces, and lots of brilliant minds that can bring to the humanity lots of new ideas and advancements. Another very, very insightful event was the Ultimate Virtual Experience Computer Society All Region 8 Online Summit. Coming as a very also, I can say very good organization is behind this event, and they organized not just another online event, but event that is very very insightful, and we can distinguish the event as an immersive experience that is very good to have in the whole organization. In fact, this online summit was taking things to the next level with cutting-edge technology and an interactive platform that is designed to bring innovation, collaboration, and excitement straight to the screen. So all the attendees were able to dive into immersive 3D spaces, network, explore, and interact like never before. So again, I will emphasize this event as one of the very, very significant events. All the events that I mentioned, I can say again that were not the only organization and the only activity that was organized by all the great people that are comprising the board of Region 8 IEEE Computer Society. I believe that all these people will continue to work together, will continue to discuss as we were previously discussing with the aim to bring IEEE Computer Society to as many people as possible, to come to ideas of how to encourage and motivate firstly chapter chairs, vice chairs, all the volunteers that are part of each chapter in these areas to work together and to spread to the members and to all the people the whole idea behind IEEE. I believe that and also we all believe that with our strong enthusiasm and the ideas we have will make a good impact to all other volunteers of IEEE and will make an impact to all the people and to bring them together, to spread the ideas, to share the knowledge, to come to new ideas in order for better humanity. I believe that will work even more stronger, even with more enthusiasm and motivation. And I believe that in the future and the years that come, will manage to make stronger steps and stronger and bring stronger ideas and their implementation for better humanity. So thank you for your attention.
Thank you so much for the great presentation. I truly appreciate your support. As you mentioned, there are a lot of to say, but the time is limited, so I have just shared the links of the social media pages, LinkedIn and Facebook, in order to allow our attendee to follow us and keep updated. So thank you for your great effort. I think you can now moderate the next session for Dr. Costa. So it's my pleasure to leave.
Yes, of course. I can introduce our next present. I will stop sharing right now. Okay, so Professor Kostas Karpouzis is an assistant professor at the Department of Communication, Media and Culture. In his research, he's looking for ways to make computer systems more aware of and responsive to the way people interact with each other. He's also investigating how gamification and digital games can be used in classroom and informal settings to assist conventional teaching and help teach social issues and STEM subjects to children and adults. Since 1998, he has participated in more than 20 research projects funded by Greek and European bodies. Most notably, the Human Network of Excellence, leading research efforts in emotion modeling and recognition, the IFP6 IP calls project, where he served as area leader in effective applications, the IFP7 Tell Siren project, where he was technical manager, which was voted best learning game in Europe for 2013 by the Games and Learning Alliance Network of Excellence. The Horizon 2020 IRED project, which produced Navigo, the winner of the GLEA Serious Games competition for 2018 and the Horizon 2020 EcoWeb project, which builds engaging and personalized mobile applications to promote emotional well-being and prevent mental health problems in adolescents and young adults. Professor Karapouzis, we are very happy to have you here again. So the floor is yours.
Good morning, everyone. Thank you so much, Katarina, for the introduction and Islam for organizing this. I will now share my screen. So this presentation has to do, as the title says, with the impact of artificial intelligence onto research, both when it comes to the content of research and the way that we conduct and publish it. And it comes, most of the content comes from my experience within different RECs or institutional review boards. REC stands for Research Ethics Committees. Now, depending on which part of the world that you're working in, this may not be as relevant as for people working within the European Union, because within the European Union, we have to actually submit our research protocol before we even start working on a project and get the permission and the acceptance of the protocol from our institutional review board. As Katarina said, some of my work comes from the framework of European Union funded projects. And again, the European Union needs to be certain that we follow the very strict research integrity rules that they have set. So they're also checking every research protocol is contained even in the proposal period, not only in the deployment of research. But in any case, this also applies to most major publishers. So if you plan to publish your work and you're dealing with people and their data, and even more if you're conducting experiments with people, then you need to make sure that you convince the publisher that you have followed some ethics guidelines which are uniform regardless of where you're working in. So most of the things that we're looking for when we're trying to evaluate a research protocol have to do with the actual deployment of the research that we're conducting. Some of the research objectives, even in the context of the computer society that we're discussing, the computer society scope or objectives, they can be used to manipulate or even provide fake news to people, especially when you're dealing with profile technologies. You need to make sure that the profiling mechanism cannot be used or should not be used to guide people to false beliefs or even spread fake news and so on. On the other hand, most of the research protocols have to do with conducting an experiment, getting the results, evaluating the results, and publishing them. Unfortunately, this is the way that we work in research, in science. Young researchers, young students, they want to finish their PhDs. Professors need to publish in order to be promoted to a higher rank or attract grants and so on. But hardly ever do we try to evaluate the long-term impact of our work. So a processing or a profiling algorithm that we deploy now may very well be used in the future with more data and richer data and have the unintended harm consequences that I talked about earlier. And of course, and this applies also to the GDPR regulation, we have to make sure that we discuss data privacy because in most cases, and this ties back to the Artificial Intelligence Act that was voted a few months ago within the realm of the European Union, sometimes we overlook the fact that even when our data is anonymized, and sometimes then we can collect enough information to build a profile and identify the user that this data belongs to. So as I usually say in my courses, when I try to teach social sciences students that they should only collect the data that they're actually going to use in the research. This is called the data minimization principle. I actually discussed the fact, and I tried to convince them that if I have enough data about them, even though this data is anonymized, then I can identify their personal information. On the other hand, there are major issues regarding the evaluation of those protocols. As I said, in most countries in the European Union, and when you apply for EU funding, even when you're outside the European Union, but you want to collaborate with institutions within the EU, you have to go through the research ethics committees, and they have to approve your protocol. And of course, the first step towards that approval is for them to understand it. And of course, this actually requires them to be at least proficient with what it is that you're doing. So in most cases, when it comes to very recent evolutions or very recent algorithms in the realm of AI, most of the people participating in the institutional review boards do not have the technical knowledge to fully assess the possible risk related to your algorithm. And of course, this also applies to other disciplines such as the biosciences or medicine, but I'm not going to discuss this in much detail because I think that most of us here are computer scientists, so our main focus, our main parts of the scope of our research had to do with artificial intelligence and how we collect and utilize this data. Another major issue, especially with basic research, with fundamental research, has to do with the fact that sometimes we are not fully aware when we start evaluating an algorithm about possible consequences. So some of us may consider ourselves experts, and we may very well be experts in AI, but when we are trying to evaluate new and novel algorithms, we are not always sure about how they might be used. And this ties back to the dual use and possible harm principles that I mentioned earlier. And unfortunately, this also applies to the researchers. So sometimes, especially again, when we're discussing profiling algorithms, sometimes we're not sure whether they are fair, whether they are biased or not. And again, unfortunately, we have to first deploy them and see their results and see the problems and then identify go back to the design of the algorithm or even the training of the algorithm to try to resolve these issues. And when you have large institutions, for instance, in Greece, the major universities, their departments span from medicine to social sciences to engineering. So a typical institutional review board consists of professors from all those faculties, and you may have 4 or 5 professors trying to evaluate an AI protocol, and maybe none of them is knowledgeable about artificial intelligence. So they try to either ask other colleagues to assist, or they rely on their limited knowledge. And this, of course, has issues with either delaying your research when you want to get an approval, as I said, to get a research grant or to publish your research, or it may lead to unidentified harmful consequences. And of course, we shouldn't forget that even though the European Union is taking those steps in order to mitigate the issues with artificial intelligence algorithms, most of the research that is available now and the algorithms and the code bases that we can download comes from outside the EU. It comes from the United States, it comes from China, it comes from Southeast Asia or Japan and so on. So of course, these countries are not obliged to regulate the way that they do research. They're not obliged to monitor the research objectives and the research processes in the same way that we do in the European Union. So again, this poses an extra issue, an extra threat to the possible impact of artificial intelligence on our research. Some of the issues that we have to evaluate when it comes to research protocols are the same issues that are relevant to all AI research. I'm sure that you may have read about the issues of bias and fairness, even if your work is not directly in AI. At some point, you would have read either an article or you may have experimented with an algorithm when you try to classify some of your data or even predict the performance of a network infrastructure, for instance, and so on. So the idea here is that sometimes, most of the times actually, we use existing data in order to train our artificial intelligence systems. And our hope is that based on this data, our systems will be trained to either recognize and classify instances or examples that they haven't been a part of the training set, or they are going to predict the performance or the behavior of a system without knowing very much about its current state based on its history and the data that we have used to train it. So the issue here is that in this process, we're actually perpetuating the existing biases found in our world. So if our data set is not representative enough, then those misrepresentations or lack of representation or inclusivity is going to be actually reflected on the results of our artificial intelligence system. And this was actually identified very early, even before we started using generative AI or ChatGPT or these relatively new technologies. For instance, Amazon, the biggest retailer in the Western world, they tried to use an artificial intelligence system in order to screen the incoming resumes, the bios of the people that applied for their jobs, because they typically receive those resumes in the order of 1,000 every day. They wanted to somehow automate this process and try to separate the people that were going to be offered the job. And among those that were going to be offered the job, they wanted to actually suggest an initial salary for those people. And this doesn't always have to do with the time spent in order to manually process all these resumes. It also has to do with the responsibility. So in many cases, especially in the United States, people can actually sue a company because they weren't offered a job because of discrimination issues. So if they think that their resume was not properly judged, then they may follow that route and so on. So Amazon wanted to actually find an algorithm and say that, okay, we're using it for initial screening. And afterwards, when they tried to actually assess the performance of this system after it was put to use, they found out that for the same resume, this system was likely to suggest 15 up to 20% higher salaries for male prospective employees. So if a man and a woman, they both submitted the same resume, one of them would be offered, I don't know, $1,000 per month, and the other one, the male, would be offered 1,200 and so on, without any other difference in their backgrounds, in their experience, in what it is that they wanted to do, and so on. And this was also applied to the hospitals in order to screen people, what we call the triage, to actually separate the people that needed emergent help and actually try to predict possible cost of their hospitalization and so on. So again, the issue here is that we first need to deploy the AI system and then try to evaluate it. But the positive news have to do with the recent advent of algorithms that help researchers evaluate their protocols even before they are put to use. But in order for the protocols to be easy to evaluate, we have to make sure that we actually understand how it is that our AI systems work. And this has to do with issues related to explainability and interpretability. And I'm very happy to report that IEEE is very active in this area, and we're actually trying to find a consensus, find a way to agree on what it is that we're going to report for each AI system in terms of interpretability and transparency, and how we're going to measure it. If you actually look for the relevant working group and the task force, you'll see that there's a lot of discussion going on over the past year and a half. So this is a major part because the more complex an AI algorithm is, the less transparent it is. That's why I'm mentioning the black box metaphor. It's like you get a magical machine that does all the work for you. You give it your samples, you give it your research results, you give it your questionnaire answers and so on, and it classifies them with very high success ratios, but you can't really understand what it is about those data that made your black box classify your data into the classes that you set out to use in the beginning. So this is a very important part, and it has to do with the design of your experiment. So besides looking for a very high success ratio, a very high percentage rate, which looks nice on a paper or in a grant proposal and so on, we should also opt for the interpretability or explainability parts. And this is actually something that institutional review boards can actually evaluate. Unfortunately, as I said, the more complex an AI algorithm is, the more difficult it is to understand what's going on. And this is usually the case with what we call deep learning, which is used in many cases when we want to evaluate medical imaging data. So you may have read in the news that, for instance, we now have algorithms, computer vision algorithms, which perform better than the best radiologists when they want to identify cancer cells and so on. But in some cases, we don't know how they work. And because we actually don't know how they work, we need to make sure that the training data that we use are actually representative and inclusive. And we can do that even before deploying our AI system without waiting for the accident to happen, so to speak. So we need to make sure that all classes are equally represented, or they are represented in such a manner that they replicate an actual part of the population, for instance. And we can try different testing methodologies in order to see whether our system has the same performance across different populations. For instance, if you visit downtown London, you may observe that there are surveillance cameras, especially in areas where many people, walk around during the Christmas time and so on, like Leicester Square and so on. The idea here is that the UK police, the Scotland Yard, wants to identify persons of interest and track where it is that they're going to, and maybe if there's someone who's hiding in plain sight, they want to apprehend them and so on. But unfortunately, most of the facial recognition algorithms have been trained with faces belonging to Western people, because if I'm working in the UK, if I'm working in Athens, Greece, if I'm working in New York, I'm going to train my system with my students. I'm going to train my system with volunteers that I find. And in most cases, these are Western people. So my system may work almost perfectly for those faces, but it will not work equally correctly with people coming from Africa, people coming from Southeast Asia or North America, and so on. And or South America, I'm sorry. And imagine walking around in Leicester Square and having some people from the Scotland Yard approaching you just because you look like someone who is a person of interest, and you have to prove yourself and you prove your identity. So this is very important when it comes to collecting databases, especially visual databases, but also medical databases, because we saw that issue unfolding during the COVID pandemic, where most of the vaccines and most of the therapeutical schemes were actually used with, they were tested with volunteers coming from the Western world. And this is why we saw that, for instance, the performance of the vaccines in Africa was not the same as it was in the Western world and so on. Again, even though most of the issues are surfacing after we deploy an AI system, we need to make sure that we take all the steps required before we even start training, when we are in the process of collecting data, put together a training set. And again, I'm going to stress explainability and transparency, because we need to make sure that we understand which features of the data are useful and are important for our model in order to come up with a classification or a prediction. In the beginning of my presentation, I briefly talked about de-anonymization. So the idea here is that given enough data, some people who want to steal your identity may very easily do so. So when you went to your university, when you went to your office this morning, you probably had your phone in your pocket. And if it's a smartphone, of course, it has a location sensor, and that location sensor collects information. And this information, your location within the city that you live in, will be transmitted to either the Google servers or the Apple servers when you log on to some network. And for instance, in my case, I'm an alumni of the Technical University of Athens. So in most cases, when I go to my office, the first thing that I do is try to log on to the server of the Technical University and read my mail from that account. I also visit my university on specific days, which are in most cases the days when I have classes. So if someone has access to the anonymized logs of the web server or the network server of our university, and they see that on, for instance, on a Monday, someone at 9 o'clock logs on to the server of the Technical University and so on, and they know that I'm the only alumni of the Technical University working at Pantheon, then they can very easily deduce the fact that that particular communication belongs to me. And then they can either log it, they can, of course, know that I'm in the office. Then maybe, depending on the websites that I visit, they may have access to information about my computer, such as the network card address and so on. And this is a very easy to understand example and not so harmful. Again, building on what I said earlier, I'm going to say that most of our personal data is out there in the wild. We don't have access, we don't have the knowledge to as to where this data is stored and when it can be used. Because sometimes this data is encrypted, and maybe these days we don't have the processing power to decrypt that data. But maybe in 5 or 10 years, when we have more access to quantum computing, for instance, then someone may be able to decrypt this information and actually use it. So the fact that now our data is safe does not mean that our data is future-proof. This may not be very relevant to AI systems, but it ties back to the data minimization principle that I mentioned earlier. So we need to make sure that we collect only the data that is relevant to what it is that we want to do, and not just for the sake of it, complete questionnaires with 20, 30, 50 questions just because we can. One of the examples that I usually use in my courses is, for instance, you want to use a new application that allows you to order food. These are available in almost all countries these days. And one of the first questions that you have to answer when you fill in your sign-up form has to do with your gender. I'm not going to discuss the issues between, binary selection or additional choices and so on. I'm just going to argue that your gender is not very relevant to the food that you're going to order. And just because there's a tradition of, collecting the gender and the age of someone when we want them to sign up, that doesn't necessarily mean that we should build on this tradition and continue asking from people for data that is not relevant to the service that we're going to provide. The last issue that has to do with privacy has to do with consent. So in some cases, especially when we're conducting research on or with children, we need to make sure that we get the consent of their parents, or their guardians, and so on. And this also applies to, in some cases, to adults who are not able to give us their consent. An issue that is usually hidden in research protocols has to do with the future use of our data. So in some cases, we have to review protocols that mention that I want to, for instance, build a profiling mechanism for my students and give them relevant content from the e-learning architecture of our university and so on, which sounds like it's very easy to do, very straightforward, and no harm will be done. But we need to make sure that this profiling mechanism is not used to actually separate between students when we want, for instance, to classify them between high-performing and low-performing students. Because even if we build a perfect algorithm and it performs quite well, we haven't received any consent from the students that we're going to use their data and their logging and usage preferences patterns in order to classify their performance. We have asked for a specific thing in our consent form, and this had to do with content selection and not with classifying their performance and putting them in different classes, or maybe dealing with them in a different manner and so on. So we need to make sure that our research is reflected, our research objectives are reflected on the consent form that we have used in order to attract our students and our subjects and so on. So for the final part of the presentation has to do with the AI Act and other activities that were recently proposed, both in the context of the European Union and beyond. For instance, when ChatGPT was first released almost 2 years ago, there were some highly acclaimed researchers that claimed that we should agree to stop AI research for 6 months until we know, and we have discussed, and we have agreed on a framework governing AI research and AI deployment. Some of the parts of the chapters that have to do with the data protection regulation that has been in place for more than 5 years these days in the European Union. I explained the data minimization principle, which has to do with collecting only the data which is necessary for our protocol. Another important part has to do with explaining, as I said, in the consent forms, the different rights that our subjects have. In most cases, when the data that we collect is anonymous and we use an online form in order to collect it, of course, this actually minimizes the rights of our participants, because we can't go back to our database and identify which part of the data collected there belonged, for instance, to me, and then delete it, erase it, or somehow remove it from the database because it was anonymous. So we need to make sure that if we actually want our subjects to be able to remove their data from our data set, we need to make sure that we don't anonymize it, but we pseudonymize it. So we have some sort of external tables collecting the actual information coming from the users to their identification data. And this table should be actually very well protected so that it doesn't leak outside. And of course, it's not part of our processing protocol. The actual data is part of the data that we're actually going to use. Coming to the more recent legislation, actually voted by the European Union, the Commission, and the Parliament. So it's the AI Act, which actually tries to categorize AI applications. One major issue here has to do with the self-reporting. So this categorization has to do with me, who, as a developer, self-reporting the risk level of my application. And in most cases, the AI applications that we use now on our cell phones or on our computers are either mid-risk or low risk. But in some cases, especially when it comes to sensitive data, such as medical data or information about my cultural and economic background, this actually would move my application to a high risk classification, which, as I say here, imposes stricter requirements on these. And facial recognition, of course, is a very high risk system, and most of the social media applications actually deploy facial recognition algorithms, because when I upload an image onto Instagram or Facebook or whatever, then the application identifies my social media connections found in that image. For instance, if I take a photo during a party or during a concert, or I don't know, we went to the beach and we wanted to take a selfie to memorize, our happy times, then the Facebook application is going to look for the faces contained in that image. It's going to recognize them, and if they belong to some of my social media contacts, is going to suggest me tagging them. So this is, of course, is facial recognition, okay? Because it's going to assign a name label on each of the faces. But no one ever thinks about, social media applications as high risk apps and so on. And this actually started the discussion. And again, Facebook / Meta / WhatsApp / Instagram, they constitute a major part, because not only they are collecting our personal information, but by means of their content selection and filtering algorithm, they can actually guide what's happening in our countries. So, for instance, I read in the news a couple of days ago that TikTok is actually investigated over its influence in an election process that took place in a country in the European Union. So we have to remember that, for instance, a typical social media user is following more than 1,000 accounts. Of course, you cannot possibly view 1,000 posts, because in most cases, actually, most of these accounts, they post more than one updates per day. So there has to be actually a prioritization or content selection algorithm. And this algorithm actually decides what it is that you're going to consume. So we need to make sure that companies which actually benefit from our data and benefit from our usage patterns, such as um, Meta or Twitter / X or TikTok or whatever, they are actually accountable for the guidance that they offer, for the filtering algorithms that they have when it comes to our content, and also the moderation algorithms or procedures that they use when it comes to fake content and spreading fake content, uh, and so on. Again, we have to remember that most of the research and most of the commercial procedures, they happen outside the realm of the European Union. So we can't actually enforce US-based or China-based companies to abide by the EU AI Act. For instance, I also read in the news that Apple is going to integrate what they call Apple Intelligence, AI in their version, in their newest iPhone iPhone models. And they plan to have two different versions of these phones. One with, the full suite of AI tools for the rest of the world, and one that doesn't have all these nice things and nice features that is going to abide by the AI Act. So we run the risk actually of losing out in Europe because of these regulatory um, decisions and approaches. And of course, we need to make sure that any AI Act is updated every year or every 6 months, taking into account the new algorithms and the new issues that may have arisen. This is very important, especially when it comes to using AI in the education system. I briefly mentioned ChatGPT and the other generative AI algorithms earlier. And this, of course, reflects the new trend in our schools and in our universities. So both students and professors or teachers are now experimenting with generative AI tools, and we need to make sure that both the content created by those tools abides to the AI Act, and also um, that education continues to remain relevant, because research has shown that people relying on ChatGPT, for instance, to teach them basic mathematics, they don't have the same longitudinal effects in terms of learning. So they forget how to do simple additions or simple multiplications if they rely on ChatGPT. Because this is the same as using a calculator. If you use a calculator in order to add the 2 and 3 together, you're not going to actually learn the mechanism behind this process. But we need to remember that ChatGPT or other Gen AI algorithms and services, they can be used in order to not only to provide access to knowledge, but also to actually regulate which kinds of knowledge are available to people. We need to remember that all those generative AI systems were trained with texts found on the internet. I'm not going to discuss intellectual property infringements because this is still an open legal case in most of the Western world. But the very fact that we took 500 gigabytes of English texts produced by people in the Western world, this ties back to the part about the lack of inclusivity and the existence of bias that I talked about earlier. So if you ask ChatGPT about its opinion, you can use quotes in whatever word I used in that sentence. About its opinion, for instance, on different wars happening these days, it's going to reflect actually the Western way of thinking because it was trained to reflect that that part of the world. It was trained to represent the Western way of thinking. And again, we're replicating this bias in artificially generated data and so on. So we need to make sure that we understand how we are using generated text or images or videos or whatever. And we need to make sure that, again, all cultures are equally represented in the training set of these systems. This was painfully obvious in the first iterations or the first models released by OpenAI, ChatGPT 3.5 and so on. And I'm very happy to report that they have taken note of this problem and they're trying to correct it. But it's not a one-off process. It's, as I mentioned earlier, it actually calls for global cooperation and for continuous improvement and checking of our models and our of the performance for different populations. Finally, one burning issue when it comes to academia has to do with using generative AI to create text, either in the form of research papers or in the form of books that we're going to publish and have our students read and so on. So there are some legal issues that have to do with authorship. In the beginning, when ChatGPT was first released, people remembered a case in the American court, in the US court, that said that no machine can be actually considered an author because it's not a human. But then we have to discuss whether, for instance, if I use ChatGPT to write a paper and then I change, I don't know, 5% of the words, if that actually constitutes enough change in the text to actually warrant me a position as an author. Different universities and different publishing houses, they have their own approaches when it comes to ChatGPT. Some of them want you to acknowledge its use and how it was used. Some of them don't actually allow at all the use of AI-enabled systems, which brings back the question whether, for instance, the autocorrect or the corrector version in Microsoft Word, which identifies grammatical errors or other errors in our writing, it's again an AI system. And of course, no one would even imagine using Word without its corrector or its spelling feature and so on. So we need to discuss what actually constitutes unfair use. On the other hand, people are actually also using AI when it comes to peer review, even in when it comes to grading papers or when it comes to discussing PhD thesis or diploma thesis or master thesis and so on, not only in the context of publishing for journals and so on. And this actually has the issues, most of the issues that I talked about earlier. So it replicates existing biases. It leads every one of us who wants to publish into, gaming or changing the way that we write in order to abide by the rules posed by ChatGPT or other similar technologies or platforms. And of course, we need to remember that none of these platforms yet is very reliable when it comes to reasoning. So my text may be perfect, which of course will not be the case since I'm not a native speaker, but let's say for the sake of argument that my text is perfect. It's not recognized or classified as AI generated, but most of the part of my paper argues for the fact that the Earth is flat. So of course, this is an extreme example, and it's going to be intercepted by an AI system such as ChatGPT, but this may be, used as a rationale for something that's not so obvious as the example that I used. So if I'm very convincing that the Earth is flat, then the AI system that I used for peer review is going to say that, okay, this person has arguments, maybe, existing research is wrong. All of the arguments are there, they're supported by references and so on. So it may be very well accepted by a journal. So we need to make sure that we can actually use ChatGPT in order to produce some text or to help us with some parts of the research process. I think the easiest thing to actually be helped with by ChatGPT or other platforms is when we want to collect existing literature in a field. So when you do the literature review part for your paper, you can use services such as Illicit or Site.ai or Perplexity. There are dozens of them actually these days in order to help you with the process. But at the end of the day, you need to make sure that you're responsible for the final version of the text. You're responsible for actually reading those papers and extracting meaningful and valuable information for them in order to add to your paper. And depending on the regulations of the publisher or your university, you give credit where credit is due. Because at the end of the day, and this is the final part about accountability, if there's someone who needs to be, contacted about the validity of some claims, if there's someone who will receive the email about major revisions or minor revisions or some corrections that need to be made, it's at the end of the day, it's going to be the researcher. It's not going to be not Perplexity, not Illicit, not any other of those platforms. Finally, I would like to invite you to read two of my recent papers that try to connect the different issues that we discussed within the context of this presentation with ancient Greek philosophy. So the main takeaway of these papers is that even though more than 2,500 years have passed, for instance, from the age of Plato, we're still discussing the same issues of equity or equitability or um, uh, things that have to do with fairness. This was the major part of my presentation. We're discussing attribution. Ancient Greek people used to, talk about the different goods that they had at their disposal. Maybe they were valuable, maybe they were actually people that they wanted to trade as slaves and so on. We're discussing about information. So we were discussing about who owns the information and how they use it for the general benefit and so on. So it's, I think, a different view into a problem that we think is contemporary, but actually has to do with our nature. So thank you so much for being here, and thank you again for the invitation.
Thank you very much, Professor Costas, for this wonderful presentation and very insightful presentation in such an emerging part, namely the artificial intelligence. Now I would like to ask the audience for questions. So any questions?
Hello.
Hello?
Yes.
We can hear you.
May I ask about how to detect the artificial intelligence research based or research based on artificial intelligence work? How to figure out this?
You mean whether a paper has been written by AI?
Yes. By I mean of plagiarism and not uh, origin or a good quality paper.
Mhm. Okay. My response has to do with what it is that I am doing. Okay. At first, when I give out the questions to be answered, I'm actually looking for specific things, the things that I used in my presentations, in my text, and so on. Of course, students can now upload PDFs onto ChatGPT and ask for the answers. So the second step has to do with limiting the amount of words, the amount of text that they can use in their responses. So typically, a service such as ChatGPT starts, with an introduction that, this is a very important issue and a very important question. I'm going to answer it, blah, blah, blah. It gives you the answer, and then it has some closing remarks. So this typically produces more than 500 or 600 words. So if you ask your students to be more concise and answer your question within 200 words, then ChatGPT is not going to be useful. And if all else fails, I ask for, an oral examination. So I invite students to my office, or I ask them to stay in the class after teaching hours and try to discuss with them and come up with, different questions that help me identify whether they actually read the course books, the textbooks, or they use ChatGPT. So this is not a process that, if you have, for instance, 200 students, you cannot use this process. Maybe you can use it for 10 people, 15 people, 20 people, depending on your schedule and so on. So this is not a foolproof 100% process, but it's the best thing that we have. Please don't rely on AI detectors, because in most cases, they're not going to be fair to non-English native speakers, such as myself. It's a difficult issue. I think that in order to wrap it up, I think that we need to make sure that we're not asking our students to just retrieve information, to ask, easy questions that get lazy answers. We need to have them think, and maybe also integrate platforms such as ChatGPT into our teaching process and our research process, and have them use ChatGPT actually in order to come up with a result. And if they're so proficient, because with ChatGPT, you need to make sure that you give it enough information. If you're lazy and just ask a question with 5 or 10 words, you're going to get a very low quality answer. So if you provide more information, you provide the context, you provide PDFs and so on, maybe this is the way that studying will be done in the future. So we need to make sure that we don't penalize our students. So I see a question about the risks of AI to the Arab world.
Yeah.
As I said earlier, I think that the most important risk has to do with the Western way of reasoning, the Western way of thinking that has been integrated into, I'm going to say, just ChatGPT, but I'm referring to all platforms using generative AI, such as Gemini, Grok, or whatever. Okay. So the fact that we are using texts provided and written by people in the United States, people in Western Europe, people in Northern Europe, and so on, in order to train this system, this may be reflected to the text produced by ChatGPT, which may not be, reflecting the ways and ideals of the Arab world or Southeast Asia and so on. I think, this is a risk that we need to acknowledge, and that is something that needs to be, integrated into future iterations. Maybe if you give ChatGPT some information about where you're coming from and which ideals you believe in and what is, your opinion about the things that you ask about, maybe it can be, adapted, its response can be adapted to better suit the ideals of the part of the world that you live in. But at first, we need to acknowledge this issue.
Thank you very much. Any other questions? Okay, then. Yes.
I wanted to ask just one question, if I can.
Yes, sure.
So we are talking actually about one of well-known applications of AI, ChatGPT. Actually, we know that ChatGPT and also other large language models doesn't have anything about intelligence. They're just about statistics. They just, predict the next word from all this large cloud of the words, and doing this very well. But what do you think? What is the ways of adding to the AI real intelligence in the future? What is the right way? Which components we can actually allocate more efforts in order to come up with something more close to real consciousness, to ability of the system to demonstrate some perception, etc. What do you think? What is the research community should focus on in order to achieve this in the future? Thank you.
So thank you for your question. One of the steps that those systems use in order to minimize their risks, and I'm going to elaborate on this, has to do with the part of that's called alignment. So for instance, let's say that ChatGPT has collected, as I said, 570 gigabytes that had to do with the first version. Subsequent versions used way more text about this. So say, for instance, that I'm going to ask ChatGPT how to create a bomb, right? So there needs to be a step, and this is the alignment step that actually limits the potentially harmful interactions. I think that this is the most important part that companies such as OpenAI, Google, Meta, and so on, they are working these days. And this part is actually the part that does reasoning with the data that they have in order to train their systems, and also the prompts, the small parts of the text or larger parts of the text that we use in order to ask for information, for generated information from the model. So these parts may be able to produce what we think of as intelligence, starting from small and very simple mathematical equations, 2 + 2 = 4, moving on to more difficult problems. For instance, the paper that I'm actually working on has to do with deploying a large language model as a participant in the International Biology Olympiad. So at first, this system performs quite well. It performs good enough to get a medal, which is very scary. But if you provide it with more information about the actual, the different phenomena and the way that it should analyze its question, how the wording should be taken into consideration about, for instance, phenomena that always happen or phenomena that sometimes happen and so on. This is called chain of thought, for instance. So you can actually provide guidance to the model. And this doesn't happen in the statistics part, and it happens, actually it's taken into account in the alignment part that's after the statistics. So I expect most of the progress to happen in this part, so that LLMs actually become useful for engineers and computer scientists and so on.
Thank you. Thank you very much.
Thank you very much. And we have one additional question that is related to the previous one in the chat. Are there special rules in the Arab world regarding AI and the ways to deal with it, like the European Union, for example?
I'm not aware of initiatives related to regulation. We need to remember that for European Union, it was easier to vote on an AI Act because it can actually enforce this regulation onto the participating countries. And as was the case with GDPR, it kind of enforced GDPR onto the United States and the UK, despite the UK not being a member of the EU for some time now. So the idea here with the GDPR was that if UK companies wanted to be able to operate in the UK, the UK government should actually vote for a law that's similar to GDPR. They called it something else, but they are compatible with what happens in the European Union. I don't expect this to happen with AI, to be honest, especially under the new administration in the United States. So this is why I think that the EU is actually shooting itself in the foot with the AI Act. So it's not easy to actually vote for and enforce these kinds of regulations unless you are a member of some sort of a union. But if you have the means to, strong arm some countries, and in most cases this happens with the European Union. I mentioned the example of the UK and UK companies. Another means of actually influencing countries outside the EU has to do with the EU funding mechanism. So if you want to participate in an Erasmus project or a Horizon Europe project or an FP10, which is the next framework which will start next year, in one of those projects, then you need to make sure that your research protocol actually abides by the rules of the European Union. So if you want to get money from the European Union, then you need to make sure that you abide by its rules. That's the only way that the EU can actually influence research. That's not much, but maybe this is a start.
Thank you very much. With this, I would like to close this presentation. I would like to thank you for your remarkable talk and to thank you and the attendees for this great discussion. Now, I would like to introduce our next moderator, Resala Alodrai, who is assistant professor at the University of Bahrain and IEEE Bahrain Computer Society chapter chair. She has PhD in computer science from the Warwick University, UK, and she is also an IEEE Region 8 EPICS ambassador. Resala, the floor is yours to introduce our next speaker.
Hello, everybody. How are you? How are you doing? Thank you for inviting me as a moderator for this valuable workshop. Let's introduce Isabel. Isabel Wagener is an associate professor in cybersecurity at the University of Basel, Switzerland. Her research interests are privacy and privacy-enhancing technologies, particularly metrics to quantify the effectiveness of privacy protection mechanisms, privacy protections for smart technologies, and measurement studies to create transparency for web and IoT systems. Her 2022 book, Auditing Corporate Surveillance Systems, Research Methods for Greater Transparency, is available from Cambridge University Press. Welcome, Isabel, and the mic is yours.
Thank you very much, Rosada, for this nice introduction.
You're
So
welcome.
I'll try to share my slides. Let me know if it works. Can you see my slides now?
Yes.
Okay, wonderful. Thank you. So I'd like to talk about smart toys today and try to answer the question whether they are your interactive friends or whether they are actually surveillance devices. So this is joint work with two of my PhD students, Valentina Pavlev and Nima Akbari, and our master's student, Julika Feldbusch. And it's a combination of a few studies we've done in the last year. So smart toys have been around for almost a decade, and it's also almost a decade now that there was the first big scandal about smart toys. If you remember, in 2015, there were two dolls, Hello Barbie, that you see on this slide, and there was also My Friend Kayla, and they were basically dolls that children could talk to, and they could carry out a conversation. And of course, it turned out they had security vulnerabilities, they had privacy issues, and in the case of My Friend Kayla, there was actually a mandate from a German federal agency that any parents who bought this doll have to destroy it because it's a concealed surveillance device. So there was a lot of media coverage, also some academic work in this. The effect was in 2017, Hello Barbie was removed from the market, My Friend Kayla around the same time. And then after that, we've seen very little academic work looking at what does the current generation of smart toys do, but there were new smart toys. So we set out to find out, have smart toys now improved? Can they be recommended to parents, or are they still potential surveillance devices? So the first thing that we did was we were interested in how big the market for smart toys is nowadays. So we started out by looking at two of the largest online toy stores, which both happen to be Amazon. We looked at the American Amazon and the German one, and essentially scraped toys from the main toy category on Amazon, as well as the electronic, remote-controlled, and educational toy categories. And then we ended up with the product detail pages of about 23,000 toys for the German store, about 19,000 for the American store. Now, not all of these toys are smart toys, of course. We just scraped everything that we could get. So we had to figure out which of these toys are actually smart, and it turns out that's not so easy. Basically, we repurposed some indicators from the IoT environment that tell us whether a specific device could count as smart. One of these is, does it have electronics? Does it have power? Does it have any kind of sensors? Does it connect to the internet? And maybe does it have a companion app? The companion app is interesting because it can make it so that even if you have a toy that is like without electronics, without power, without anything, if it's used in conjunction with a companion app, that companion app can substitute for all these indicators. So in addition to classifying all these toys according to these smartness indicators, we also did topic modeling to find out what kinds of smart toys there are on the market. And then for the smartness indicators, we trained some machine learning models. We tried like traditional ones, random forests. We tried BERT models. The one that performed best in the end was a convolutional neural network. So then if we plot the two markets, Amazon Germany on the left, Amazon US on the right, on the x-axis, you see all the topics that came out of our topic modeling. One thing you immediately notice is that the sets of topics are different for the two markets. And that we did intentionally to see how the distribution of the different kinds of toys is. So, for example, in the American market, you see that there are specific categories for drones as well as vehicles. And in the German market, and they are both relatively high bars, so there are many toys in this category. In the German market, they are all inside the remote control toys category. And you see that the bar is much, much smaller. So there is some substantial difference which types of toys are offered in the two markets. Now, the other interesting thing in this figure is the colors in the bars indicate how smart the toys are in each topic category. So the gray ones are actually not toys. They were present on the Amazon toys categories, but there were things like USB cables and stuff that is actually not a toy. So these are the gray sections. Then the blue ones are traditional non-smart toys. And then as we get to the green and the red parts, those are toys that have between 2 and 5 of these smartness indicators from the previous slide. So toys that have the dark red, that are in the dark red section, have all 5 of these smartness indicators. So power, electronics, connectivity, sensors, and a companion app. And you can see that in the German market, the biggest portion of these very smart toys is in the remote controlled toys category. What you can also see in the American market is that a large portion of the drones and the vehicles actually have 3 smartness indicators. And these are traditional remote control toys. So they have some sensors, they have electronics and power, but they don't connect to the internet. So these are not smart toys that are really interesting from a privacy point of view to study, because they cannot transmit any of the data that they might collect to anywhere. So we are really only interested in those toys that have like 4 or 5 smartness indicators. So we can also slightly switch around the figure from the previous slide and look at which combinations of smartness indicators are actually the most common. So here in the very left bar, you can see that dumb toys are actually the most common in both markets. So these would be things like puzzles or traditional games or balls, whatever you can imagine. Then the next common category in both markets is that for these traditionally remote control toys that I just mentioned, that have electronics and sensors and power, but no connectivity. Now, the really key finding that we were interested in is, as I mentioned, the size of the market for smart toys. So if we look at the leftmost part in this figure, those toys that have all 5 smartness indicators, you can see that German market has about 90 of these toys and the American market about 50. So they are available on the markets to buy. And of course, now the question is, how privacy preserving, how secure are they nowadays? So to look at that, we actually purchased a few smart toys. You see the pictures on this slide. There might be some that you have already seen. So we made sure in our sample to buy a diverse set. So different types of toys, different variants in whether they have connectivity on the toy or through a companion app. So for example, in the first row, the first figure is EduReno. It's like an educational toy. The next one is a children's smartphone. The next one is a camera that can instantly print pictures. The next one is an autonomous robot. Then we also had 2 smart speakers. We had a Tamagotchi, which nowadays they come with Wi-Fi as well. And then also the Pictionary and Twister, they are cases that connect only through the companion app. So the toy component is basically just a plastic part and it doesn't have electronics. So we bought these 12 toys and then defined a list of criteria that we wanted to evaluate. And then set up a measurement methodology where we would integrate each toy, that's the box on the bottom left, into our measurement setup, so that we could capture all network traffic that comes from the toy and from its companion app. So for that, we had a phone that ran Frida and had a man in the middle certificate on it. We had a Raspberry Pi that could serve as the wireless gateway, also running the man-in-the-middle proxy so that we could see plain text traffic where possible. We also had a traditional laptop to run static analysis of the companion apps. And then, of course, the Raspberry Pi connected through to the internet so that the toys could actually function. So through this setup, we were able to record all traffic from the toys and record and decrypt all traffic from the companion apps. From the toys, decrypting traffic would have required modifying the firmware, so we didn't do that. So then I mentioned we had a list of criteria, and on the left-hand side in this giant table, you see an overview of the key criteria. So we had some criteria for security, some for privacy, and some for transparency. A few key takeaways from this figure. One is it's a really mixed bag. You don't see a clear picture in most cases. Right? So there is the first row that I highlighted are software and hardware support periods. So this is the only row where all the toys had a negative rating because none of the toys defined for how long they would be supporting the toy. All the other rows, you see the toys really vary whether they fulfill the criteria or not. The other row that is sort of mostly consistent among the toys is the second one that I highlighted, and that is whether the UI indicates that updates are available. And there, the toys are mostly doing well. So those are the blue circles, because they piggyback on like update mechanisms in the common app stores. So for all the other criteria, there is no consistent picture among all toys. And the other thing that you can observe is that if you look at the columns for the toys, there's also no consistent picture. So there is no toy that consistently does everything in a terrible way, or that consistently does everything in a great way. So without going much into detail in this point, we'll get back to some of the more detailed results in a little bit. So let's move on and look at some of the detailed criteria, starting with one of the security criteria, that is, how well is that network traffic encrypted? And for that, we looked at the TLS 1.3 standard, which has a list of cipher suites that they recommend, that they consider secure, that they consider weak. And of course, there's also the unencrypted possibility. And then here on the x-axis, you see the different toys. Some toys have 2 entries. For example, the 2 rightmost ones, one of them is, well, the actual toy, and the other is the companion app. Then also towards the left, the moorboard is the same story. It has an app and the toy itself. So surprisingly, there was one toy that we found that sends no network traffic, and that's the children's camera on the left. So that is really positive from a privacy point of view. All the other toys send some amount of traffic, some more than others. Concerningly, one toy sends a lot of traffic that is actually not encrypted. And that's also this moorbot. It's basically a surveillance robot that has a camera and microphones, and potentially all this data is being transmitted without encryption. Then the other takeaway you can see from this figure is actually that most toys use either recommended or secure cipher suites. So the security aspect of using TLS for network communication is, on the whole, solved relatively well. There is one more exception here, and that's the Tonybox device, where you can see a pink bar. So this is a very popular smart speaker for children. Started out in the German-speaking market, is now also internationalizing. They, for some reason, use a weak cipher suite for their device. The app is different. It does use secure cipher suites. Okay, then after security, the next interesting set of criteria is all the data types that the toys transmit to the internet. So for this, in the first row here, we rated whether the data processing that each toy does is the minimum necessary that is needed to realize the toy's functionality. And some toys here are really good. They minimize the data collection and the data transmission to only really provide the toy's functionality, whereas other toys are more of a mixed bag in that they collect some data where we couldn't imagine how this would be needed to provide the toy's functionality. So some concerning things here are, for example, in the first column, the Edurino toy collects some personal data from the children, including the children's gender, which is never used in the gameplay. So you have to enter this information when you configure the toy, but then after that, it never occurs during gameplay. Then other concerning things, for example, the Osmo toy, sort of in the middle, that toy asks for the precise date of birth of the child that is using it, probably to get some kind of estimate of which games are age appropriate, but it doesn't ask for the age bracket, it asks for the specific date of birth, which is really unnecessary. So then in the second group, we also see that many toys transmit unique identifiers. So in the case where it's a companion app, they transmit the ad ID from the device. And many also transmit a unique identifier for this specific device that constitutes the toy. The third part, game analytics data, is also concerning in some cases, because this is really very detailed data about how the child interacts with the toy. So one example here is this Tonybox. They transmit data to the Tonybox servers every time that the child performs any interaction with the toy. So if the child presses play or pause or rewinds or or plays a new story, all this information is sent to the toy maker servers. And with that, so from their privacy policy, of course, they claim that they need this data to improve their products. However, if you think about the type of data the type of metadata that they receive together with this analytics data, they could create really detailed profiles of the children. So for example, the times of day when their toy is used, the IP address can be easily geolocated, so they have the relatively precise location of where the child is using the toy. And of course, the game data itself, which stories does the child like, how many stories are sort of in the repertoire. So could be used to make really detailed profiles of children, which is not a great feature from a privacy point of view. So if we move on, for some of these toys, we had to create an account to just be able to use the toy. So for these toys, so these were 7 of the 12, after using the toys for a little while, we sent subject data access requests to the vendors. So a mechanism from the GDPR that gives us the right to learn what data specifically the vendor has stored about us. So responding to these requests is a requirement, and vendors have only a limited time period in which they have to reply. So within that time period, we only got replies from 3 of the 7 vendors, which is really concerning because it indicates that more than half of the vendors are actually not complying with their legal obligations. In addition to that, those 3 vendors that sent us a response, the data that they sent us was often incomplete because remember, we had our measurement set up. We know the traffic that went from our toys to the vendor. So we could compare what data we get back from them and what data we actually sent. So for example, the middle toy, the Tonybox, the data that they returned to us was mostly like personal data, email addresses and such. But the game analytics data that they collected, they did not return to us. And in addition, when setting up that toy, the toy performs a scan of the Wi-Fi environment and transmits all of the Wi-Fi SSIDs that it finds to the toy vendor. That we also they didn't include in the subject data access reply. So also on this criterion, there is very mixed results. Then, of course, we had to look at the privacy policies for these toys, even though realistically, when buying these toys, the online shops do not provide links to the privacy policies. Nevertheless, once you have received a toy and you start using it, at some point in the process, you agree to whatever is in the privacy policy. So we checked in general how complete are these privacy policies, how transparent is each toy about what they do. And here, in some cases, we even had struggles to find a privacy policy. That was the case for the Moorbot. In some cases, privacy policies were only available at very specific times. So for example, the tip toy, it's like a pen that you can use for like more interactive reading of stories from books. The privacy policy in that case is available only when you configure the Wi-Fi for the charging station for the toy. And you don't see it at any other moment. In particular, it's not on the vendor's website. And once that setup phase is done, the privacy policy is gone. You can't get it back. So, but most of the toys, you can see there are blue circles in the availability row at least. So we could find privacy policies. And then some toys were very explicit and very detailed about which data is collected, how it is used, with whom it is shared. So the Twister, for example, had a really nice privacy policy. Also, the policy from the Tonybox was very detailed. So all the behaviors that we measured were actually described in detail in the privacy policy. Some toys were a lot worse, where it was just a very vague and generic privacy policy and we couldn't see a lot of detail. So essentially a similar story to privacy policies for websites that we know. Okay, now after this study of 12 toys, we actually acquired toy number 13. And that toy is special because it's a brand new from a startup in the US. Essentially the first toy that integrates ChatGPT and packages it for children. So this toy is aimed at children aged 2 to 12 and basically is a voice interface for ChatGPT. So you get a plushie. In this case, we got this little rocket. You turn it on and then you can converse with ChatGPT. So interestingly, even though this toy is aimed at children aged 2 to 12, ChatGPT terms and conditions say users have to be 13 or older. So there is some disconnect, and the toy addresses that most likely by means of a system prompt that restricts the topics that the toy will answer. So of course, we integrated this toy into our measurement setup and interacted with it for a little bit. We also unscrewed it. So these are the insides. Basically, it's all very standard, right? They use a standard ESP32 processor like on a small custom circuit board, but there is nothing really majorly innovative inside the box. So the really interesting thing happened when we interacted with the toy. So here you see an example, about 7 minutes. What you see is the amount of traffic going out from the toy, that's the orange spikes, and coming into the toy, no, the other way around. Blue is going out from the toy, orange is coming into the toy. And you see that the traffic outgoing from the toy, it's like a rather constant, roughly 35 kilobytes per second stream. So essentially leading to the conclusion that this toy transmits a constant audio stream. Like 35 kilobytes per second is like a 256-bit encoded audio stream, just from looking at the data size. So we couldn't see plain text traffic for this because, again, we would have had to modify the firmware. So this was all properly TLS encrypted. But nevertheless, it's a strong indicator that this toy sends audio data. Like constantly, everything that is said, all the background noises from the kids' room to the startup servers. The other interesting thing is that we see the orange spikes coming back. They also correspond in data size to audio for the responses that the toy played for us. So the toy itself, like this embedded processor that you saw, essentially records audio, sends it to the internet, receives audio from the internet and plays it back. It has like no logic within the toy itself. So it does not have a wake word. You just switch it on, it transmits a constant audio stream. So this is really concerning because if we go back to this plushie, there is no indicator on this plushie that the toy is actually on, right? The box is inside. There is no indicator light or anything visible from the outside. So essentially, you could have visitors, you could have sensitive conversations in the next room. The toy might pick those up and send them to the vendor servers. So our findings for this toy did have some positives, right? The transport encryption was good. They didn't directly send any traffic to third parties. And also the privacy policy is relatively good in that it explains that the toy transmits audio data to the servers. And it promises that this will only be used for the purpose of making this conversation happen and will be deleted right after the conversation. But of course, on the negative side, there is no wake word. The audio stream transmitted by the toy is continuous. We've had like audio assistants, voice assistants for many years. They all use wake words. So it's really puzzling why they chose not to implement this. And then, as I said, no indicator, right? You can't tell if it's listening or not. It also doesn't differentiate between speakers, so anyone can talk to it. And it doesn't differentiate between foreground and background conversations. So even if there is something in the foreground at very high audio levels and something very quiet in the background, it does react to the background speech as well. And then also the toy asks for the kid for personal information during onboarding, like name and favorite toys, stuff like that. The privacy policy says all of this is optional, but that is not made obvious to the child during the onboarding. So to sum it all up, we studied 13 toys in total, and we essentially found that the situation since Hello Barbie has actually improved. So they are less intrusive as those toys 10 years ago that caused big scandals. However, we also found there are still concerning developments. For example, toys send analytics data that has unique identifiers, so it can be linked back to a specific toy. We also found problems with many privacy policies that are really vague. We found many vendors not replying to our subject data access request. And then in toy number 13, we found that this toy actually transmits audio stream continuously, which is really not great. The really important finding is, rather obviously, given that these toys collect so much data and communicate it over the internet, means that parents now essentially have an obligation of studying privacy policies for toys, and ideally doing that before they purchase the toys. And of course, we know all the issues surrounding privacy policies. They are too long, they use legal language, they are really hard to understand. And also they are not easily findable in all cases, especially in like a purchasing situation. There is no obvious link to a privacy policy. So from this, we are planning a whole lot of future work. Some of this will be privacy technologies for toys. So partially to help developers who may have really good intentions, right? They just want to have engaging toys. So we want to provide technologies that toy vendors can more easily integrate into their toys and make them more privacy preserving. But also on the other side, we want to look at technologies that could help users sort of privatize the toys that they already own without ideally losing functionality. And critically, we also want to look at labeling for toys. So let's say we could have a browser extension that would, when you shop for a toy online, it would detect what the toy is and would display a visual summary of the privacy practices for that toy to help parents make a purchasing decision. So that's the outline of our future work. And with this, I'm done with all of my content. I would be happy to have a nice discussion and answer all of your questions.
Thank you, Isabel, for a nice presentation. Thank you very much. Does anybody have any question? Nobody has a question? I have questions for you, Isabel.
Yeah.
Has the smart toy market shown significant improvement in addressing privacy and security concerns compared to the scandals from a decade ago?
So the 12 toys that we studied, it was significantly better than a decade ago. So for example, the toys, most of them used transport encryption and most of them used really strong transport encryption. And that was not the case a decade ago. So especially on the security side, there have been significant improvements. What we still see as problematic is the collecting of analytics data about children, for example. That is still being done.
Okay, thank you. Another question, are there specific regulations or standards that manufacturers of smart toys commonly comply with to ensure privacy and security?
That's a really good question. And it's the answer is a mixed bag, sort of. So there are standard like toy safety regulations. I think the EU one is relatively old. It covers things like safety of materials and not giving children plastic bags that they can use to suffocate, that kind of stuff. It does not cover digital aspects of toys yet. I think the EU is in the process of working on an update to that regulation that might also include digital components of toys, but that's not available yet. On the other hand, toys have to comply with the GDPR, of course. But as you've seen, they don't all comply perfectly. So especially with the subject data access requests, we've seen gaps, but also the mechanisms that toy vendors choose to use, especially for consent. So the standard privacy policy mechanism is really not the most intuitive and is really not very helpful, like especially if you think in the situation that you're a parent and you have small children and you're extremely busy and stressed anyway, and then you need to study a privacy policy. That's just not happening. So yes, there are some regulations. They are maybe not specific enough for targeting the setting of toys that have digital components.
Mm-hmm. What the practical steps can parents take to protect their children privacy while using these smart toys?
I think at the moment, the best practical step is to be very careful which toys to buy. So for example, this plushy rocket, I wouldn't buy under any circumstances because there's just no way to know, and also essentially enables the child to independently talk with an AI chatbot, which from a child protection point of view is quite concerning. There are toys that are sort of better than others on privacy aspects. So for parents, the best thing to do at the moment is actually to read privacy policies and try to find out what this toy does before making the purchasing decision. And this is really not a satisfactory recommendation to give. So I think there is a really urgent work needed in this area.
Okay. Any question from the audience? Thank you, Isabel, for the valuable presentation. We really got
Thank you
benefit from that. Yeah, a new topic, really. Thank you very much.
Yeah, thank you all.
Thank you, Dr. Isabel. Thank you, Dr. Risala. It's our pleasure to have you today with us and looking forward for further collaboration. Thank you so much.
But thank you. Thank you for inviting me, Dr. Islam.
So now I think we have maybe about 12 minutes before the next session. So I can utilize them to share with you the recorded talk from Giorgio Purlaer and others during the opening session, maybe 11 hours ago. So can use the time now.
Good morning, good afternoon, good evening, and good night. A greeting adapted from the movie The Truman Show, starring Jim Carrey. And it works here since to each of you there is some relevance in that greeting. And hello, Kuala Lumpur, Sapporo, San Francisco, Wilkes-Barre, Thule, Dublin, Bruges, Cairo, and Mumbai. I'm George Proler, Chair of the Computer Society Distinguished Visitor Program, and it is my honor and privilege to welcome you to this, our second annual IEEE CS EXA DVP event, or as we call it, the 24-hour event. Second annual has a nice sound to it. At the beginning of last year, hosting such an event was just a thought. To extend an earlier project to cover an entire day, 24 hours of presentations, reaching and including our diverse membership. And quite frankly, we weren't sure if we could put it together. But Professor Hassam Fahmy, my predecessor, and Professor Islam Halim, chair of the Awareness and Customer Advocacy Committee, and his team rose to the challenge. And we did it. And it was successful. The first annual. And now, well, Professor Islam and his team have outdone themselves. Look at the agenda for the next 24 hours. Artificial intelligence, AI security and privacy, and research ethics in the area of AI. Quantum computing and the quantum world, smart and high performance computing, and the list goes on. And we are already working on the planning for the third annual event for next year, taking another step and upping the challenge for Professor Islam and his team. as we are looking to make this a hybrid event with on-ground activities concurrent and shared with the online participants and attendees. This event spans each of IEEE's 10 regions and the world's time zones, hence my adapted greeting, since each of you and the DVs, the presenters, the moderators, you all hail from different and diverse regions, and for some of you, it's 10 a.m., 2 p.m., 8 p.m., and 2 a.m., and all the hours in between. So it is morning, afternoon, evening, and night. Truly an effort of inclusion of our diverse membership base. Today is International Volunteers Day, which is fitting, since it has taken, and before this day is through, it will take the efforts of more than 50 Computer Society volunteers coming together from the Geographic Activities Committee, Students and Young Professional Activities Committee, and the Distinguished Visitor Program to bring this event to you. Over the next 24 hours, you will have the opportunity to attend more than 20 technical presentations on topics I've already mentioned, along with informational talks about the Computer Society and its regions, activities, and programs. Each presentation will be introduced by an event moderator who are members of various student chapters, and through participation in this event are gaining experience and opportunity. And then there is the audience. That's you. Many of you are members and affiliates of the Computer Society who volunteer your efforts to make local programs a reality. And all are here allowing us to bring this event to you. So thank you for your time. And now, before I wear out my welcome, I'd like to pass the baton to Professor Ironori Washizaki, the President-elect of the Computer Society. Thank you.
So as I mentioned, we are waiting just maybe a few minutes to start the next session and utilize those minutes to run the recorded video from some of our speakers at the opening session today.
Good evening or good afternoon, depends on where on earth everybody is. Hello, Professor Islam. Hello, everyone. Professor Anna.
I am Professor Hussam Fahmi, Professor of Computer Engineering, Faculty of Engineering and Shams University, Cairo.
Hello, Dr. Michael. Can you hear me?
Yes.
Yes, glad to see you and Professor Ann. We are just waiting a few minutes to start the session, so I thought it could be a good idea to rerun some videos from the opening session.
Yes. I was also going to ask Professor Ann if she would you like to play the video now, or should we wait until the session starts?
We can wait until the session starts.
Okay, sure.
Because I have it as part of the middle of the video, and I don't know if you want, maybe at the point where we ask the video, I ask you to play it, or do you want me to try to play it?
As you like. If you wanted to share your screen with the presentation, you can play it, and I can help you. I'm here upon your need.
Okay. Yeah, I'm just, making sure that I was just logging in to make sure everything was okay. I did actually log in last night before we're going to bed, because it was 2 a.m. in the morning when you started, right? So I didn't want to stay up all night, then I wouldn't be giving a very good talk today.
Yes, we're actually looking forward for the talk. It's a very interesting topic, so we're very interested to know your field of research.
Thank you. Thank you.
Thank you, Professor.
If you'd like to share your screen and try to run your video,
Sure.
it's sure.
Yeah.
Let me try something. On this multi-screen, I need to get my screens up together here. Let's see. Why am I not having? Struggling a little bit. How do I share it? Yeah, that's good. We're testing it because I'm realizing my setup is okay now. Maybe. Someone else is sharing, it says.
I think our Professor Sam is sharing the video currently. So
I cannot come in before.
okay.
I think it's starting, yeah.
Yes, we can see the slides now.
Does it look right to you?
Yeah, it does.
I'm always curious what it looks like on the other end. You know what I'm saying? When you have this screen share stuff.
It looks just fine. We can see the slides. Do you
Okay,
also
good.
want to test the video if it's working? I believe the video, we will be playing the video
So
from
let me go to the video and let's see if we can get it.
To see if it works right.
Yeah. Okay, now because it's in this mode, I can't see so easily. Yeah.
Okay.
Let's see. Oh, maybe there it is. Oh, I hit it too fast. Okay, let me try again. See if I can do it the other way here. Well, I guess you got a quick review of my whole talk. Listen. Trying to get my cursor onto the other screen. It's not. That was harder than I thought because it was so slow, you know what I'm saying?
It's good we started it early.
Yeah. The feedback was so slow. But as you see, I have enough material at least. Yeah, it's always good to test this always. I always do that when I give talks. There it is.
Okay.
And maybe that's a mess when it shows like this. Might be nicer.
Yeah, I suggest let's see the video in full screen mode. Then we will see it in a yeah.
Yeah, it's difficult, isn't it?
It's 90% of the species that are yet to be.
You see, it's a little bit difficult when I play it over this Zoom thing, right?
It's coming along. Let's see how it works.
Yeah, I stopped it. So I'm stopped it so I can talk to you. But you can see it took a little while for me to switch inside of Zoom, but maybe that's okay, is what I'm asking. I stopped it. I can
it is the other way around that I can play it, but in this case then I would have to share my screen, which will stop your screen share. So this would also take some time.
Yeah, that's true. So maybe I should just do it my way.
Yeah.
Does it work now?
Yes.
90% of
Can you hear the sound okay?
First of all, it's dark.
Yeah, we do.
And deep, and the light doesn't help so much.
Okay, maybe I just run it then.
Penetrates, meters.
And I'll be here
Okay.
to help also if we need any contingency plan.
Yeah, okay. I just wanted to check it a little bit because it's so. Okay. So now I'm gonna escape out of that.
Okay. So I believe it's time now, so we can officially start the session.
Okay.
Let's go back to the slides, and let me introduce you first formally.
Well, let me
So
wait. Let me get
sure,
back
sure,
to the
take
very
your time.
first slide.
Just tell a bit of words to everyone. So hello everyone, good evening, good afternoon, good night, depending where on earth you're joining us. I'm very happy to be joining this event today. I'm Dr. Maggie Masheri. I'm an artificial intelligence, associate professor of artificial intelligence, member of the Computer Society, and I'm very happy to be the host today for our next talk. Please welcome with me Professor Anne Elstra. She is the professor and the director of the Heterogeneous and Parallel Computing Lab, the HPC Lab, at the Department of Computer Science, Norwegian University of Science and Technology, NTNU. Today, the talk is going to be about the topic of smart high-performance computing for AI and geophysical forecasting. And we have the slides. Everything looks fine. Professor Anne.
Yeah, thank you. Sorry for those messy slides. I guess you got a quick hint of my talk here as we were trying to set up. It is a great honor to be invited to give one of these lectures for the EXA DVP program. It's a great program for people to, touch on research, throughout the world. I'm very happy today to be able to present some of my ideas. I also actually start some history because I think there's some history that not everybody knows about. Computing history that's related, and also how HPC and AI are now, of course, of great interest to many, and some of the things that me and my group and people here at NTNU are working on that you might find interesting. I am associated both with the NTNU, which is in Europe known as the Norwegian Technical University, or Norwegian University of Science and Technology. It was formerly known as Norwegian Institute of Technology, but we merged with local colleges. So we're now a much bigger university in 3 different cities. I've also have a guest appointment at University of Texas at Austin. I just spent my sabbatical year there last year until the summer, and every summer and whenever I can, I stop by Austin like I did a week before supercomputing now just in November. This talk and my work would not be possible without the many, many graduate students I've had the honor of working with through the years. In fact, I've now advised over 100 master's students and several postdocs and PhDs, and I'm very grateful and indebted to them. They teach me, I would say, a lot more than I learn a lot more from them than I will ever learn on my own, that's for sure. And sometimes I think I'll learn more from them than I can teach them. I also would like to thank my collaborators and visitors. You'll see here on the lower left, there's Fredrik Kjølstad, who took my parallel computing class some years ago, back when he had finished his bachelor and was working for ARM here in Trondheim. I'll talk more about ARM later. He then took my parallel computing class. It was actually a little bit challenging getting people who were not registered as students into the courses back then. Got excited about it, decided to want to do a master's degree in the United States. I got him in touch with Urbana-Champaign. He went there for his master's. And then he went to he did his PhD at MIT and is now an assistant professor at Stanford. So that tells you how by doing some inspiring lectures, you can, I'm not saying that's the only reason he did it, but it's a great opportunity for students to find out about topics that are relevant throughout the world. Here's my 2 mentors, which is, or 2 of my mentors, Keshav Pingali, who is my host at University of Texas this past sabbatical. He was also my minor advisor while I was at Cornell University. The other one is Gianfranco Bellardi, who was also a minor advisor of mine. In fact, he was my minor advisor before he left for Italy, and then Keshav took over since I've been working with his group, teaching them some numerical analysis while I learned more compiler technologies from Keshav's group. Here's the logo from a laboratory that my daughter designed. I think it's a nice logo, not only because hopefully you can see it's a Viking ship, but it also shows you how people through history have known this idea of parallelism and synchronization. We wouldn't be able to row those big Viking ships if we couldn't synchronize the rowing, right? And I think that's a nice illustration of SI MD, how we have to do the same instruction together. Now, the other concept we hear in parallel computing is MIMD. We have multiple instructions and multiple data. And that's sort of like when there's a sports team, like a basketball team, where everybody has different roles, but you try to solve this same problem, right? But you still have to have some synchronizations. You still need to know where the ball is. And I think and in the same, pick any ball sport like that, like soccer, we have people have different, American football, people have different roles and trying to save the same goal. And of course, then we have SPMD, which is single program multiple data, which is a lot of we see today, for instance, in MPI programs, when you try to do big compute on big systems. I'll now start musing a little bit about the AI history and history of computing. So if you look at the parallels between HPC and AI in sort of the dark ages, you'll see that in the 50s, we were very happy if we could access 1 million bits of magnetic drum. That was basically a big, Navy computer in the 80s. And on the AI side, we're just starting to talk about the concept. In fact, one of the people who introduced the concept was the science fiction writer Isaac Asimov, who some of you may have read many cool stories from. You can also see a timeline of this at the Computer History org that's provided by IEEE. Now, Fortran got introduced by John Backus and others in the 50s and was sort of the first programming language, and we often used punch cards, as a way of programming the computer, where you ran the deck, you encoded the statements of Fortran into these punch cards that then were read by a card reader. That was also the summer in 56 where John MacArthur and others met at Dartmouth and coined the term artificial intelligence. Now, all of AI has not been a grand success. And I think you learn as much from your mistakes as you learn about your successes. And I like to pull out this example from one of my master students just to show that we don't always succeed. In that he worked on this project where we tried to look at compiler flags from CUDA programs to figure out if AI could help us, or machine learning in particular, could help us select the right compiler flags, since there's so many of them. I mean, if you look at GCCs, there's several hundred. We downloaded all of CUDA's SDK and tried to, encode it correctly and everything. And I even had him working with Dr. Gavin Taylor from the U.S. Naval Academy, who's an expert on reinforcement learning, but it wasn't as successful as we hoped. I think one of the problems was that the training set was too similar. You need some diversion in the training set. You need the right data. And it shows you the quality of the data is very important when you want to get AI to work correctly. But it's nevertheless a very good training. And I think this is a master project that was still successful in that the student learned a lot about AI and machine learning and also HPC. Now, parallel computing is actually older than digital computers. We had what's known as human computers. So if you look back in the 1700s, we were tabulating the skies and the seas, like we like to say. So for instance, in 1758, Alex Claudet-Clairaut and Joseph Jérôme Langlande and René Lapeau all sit together for 5 months and approximate the orbit of Halley's Comet. So they actually did that, by hand, but computers, they were like parallel computers trying to get this done. In 65, Neville Maskelyne began calculating the nautical almanacs for 1767, and he also employed 5 others. Before computers work in pair, alternating noons and midnights, and one comparison corrects. And similar, in 1793, Gepard de Broglie initiated a 6-year effort to produce 19 volumes of trigonometric tables. And he used 96 untrained workers. So obviously still computing in parallel. Now, what we discovered in this era of human computers are some of the concepts we see today, right? So overclocking. So when in 1966 showed that a 67 almanac will be late, he wanted to accelerate his computation by paying the computers, or the humans, if you wish, 70 pounds extra to finish on time. So this is, where we speed up the, clocks in order to, overclock our computers to get a faster result. Similarly, we also have to be concerned about programmability and library functions. Gaspard had to prepare idiot-proof instructions and tables for his army of inexpensive non-mathematicians to make sure they got the right answer. And so the same thing, we have many experts working on libraries to make sure that they are correct, and that they, so when the users use them, that they can trust that the results are actually sane. We also have fault tolerance. You will see one of the reasons the first computer, well, known as one of the first computers, the difference engine done by Gabbage and company, it weighed 4 tons and had 25,000 moving parts. Now, when you have that many moving parts, there's an inevitability that they will fail. In fact, they will break down quite often. And that's why the analytic engine was never built. It would have been the size of a steam locomotive and broken down all the time. So you have to build fault tolerance into your system if you want to get it to work. That was true then, and it's even more true today as we scale up to even bigger and hopefully better computers. Now, there's still, in the dawn of computing itself, for the 1800s, the mechanical devices, of course, revolutionized society leading up to the Industrial Revolution. Steam power for transport, for mills and mining. Entertainment industry develops programmable pianos, and even little, little small things you can just rotate with, has little things that hit the little strings and make a little sound. The two big grand, bigger pianos, right? And the textile industry actually developed programmable looms. And this last example, I think, is very important for us to see the parallels of today's society. Because contrary to popular belief, this computing industry, the way I see it at least, did not start in Silicon Valley. I say it was started with Jacquard, Babbage, and Lovis. And now Wallerith in the US, of course, was important, and also a Norwegian known as Bull. And like I say, in the 1804 to 1805 in France, Jacquard revolutionized the weaving because he actually invented punch cards for looms. So here you see his punch cards that he used to program these looms to make very intricate weaves. In fact, here's the silk weave of Jacquard himself. And to achieve this weave that was done in 1829, so that's quite a few years ago, that's soon 200 years ago, he made it using 24,000 punch cards. Now that's a heck of a program. Now, granted, this is more like a program full of print statements, in today's programmable language, but nevertheless, it is a program, right? To many parallels to today's computer. The other parallel to today's computer, that this had a major impact on the weaving industry. In fact, it replaced thousands of skilled weavers. And it was actually causing its own revolution, known, for instance, the Lundites over in England, where they were smashing the power looms in 1812, because they were basically highly paid people who know how to do intricate weaves that then were laid off. And this is sort of some of the scariness a lot of people feel today with AI coming, that maybe they will take their jobs. Doesn't mean that the world will not go on, and we can discuss how and why we want to use what we use and how to do it. But like I say, this is nothing new as far as history is concerned. And I think that's useful and, to think about when we go talk about AI and what it can do. Now, as a Norwegian, I like to talk, at least mention in my talk, Fredrik Rosingebull. In the 1890s, Norway's used Hollerith, the American inventor of a tabulator and sorting machine, for census data. And that was like known as sort of the first digital computer, where we know used, and it was motivated by, calculating census data, both in the US, in Norway, and elsewhere. In 1917, Storebrand, a Norwegian insurance company, sent its engineer Fredrik Rosingebull to Sweden to study this machine. And during his visit, he kind of looked at it and said, man, yeah, it's cool, but I think I could do it better. So in 1919, he actually patented an automatic registration machine for statistics and similar purposes, and then started to build it. And he sold about 14 of these machines because he didn't have the power sales force of the internet. The internet was not invented in 1922. But he did manage to find 14 people in the insurance business that also liked it and bought it. And in 1924, the Norwegian Statistics and Central Bureau, or the Norwegian Calculation Bureau, actually replaced their Hollerith machine, which is the Norwegian government, with the Bull model. And that was Hollerith's first real competitor. It was also the year that Hollerith's company turned into International Business Machine, also known as IBM. Unfortunately, Bull himself dies of cancer the following year, and the company is taken over by his brother, and then he got moved to Switzerland and later to France. He did get a lot of accolades for his design at the 1930s Paris Fair, and in 1931, the Egli Bull Company was established in France. This was renamed Compagnie de Machines Bull in 33, and now we're sort of in 36 to 45. There was a lot of war efforts that I'll talk about that has, of course, also spewed a lot of, investment in computers and similar. Now, the CMB was taken over 66% by General Electric, and the rest became Bull SA. This is because the French government didn't want all the computing to go to US. They want some for themselves, for the military research. And the G Computing Division turned into Honeywell Inc. or Honeywell Bull. And here's some reflections on what governments spend money on and how. Now, during World War I, there was map grids and ballistics and navigational tool that he used teams of color-educated women to do. Then it was the Gertrude Blanche continued afterwards, heading the Mathematical Tables Project. You may have seen the film about the women of Bletchley Park with Alan Turing among them. And of course, there's separate movies also about Alan Turing himself. And then in Germany, you had Konrad Zuse, who invents the first electromechanical computer and completes the Z3, the first fully functional programming controlled computer in 1941. This was used in Germany's aircraft industry, but destroyed after the war, and a lot of people don't like to think about him because of his connections to Gnosticism. Now, Stanley Phillips Frankel designed a pipeline of mechanical IBM calculators to calculate the energy release of an atomic bomb. This was all, and remember, John von Neumann himself was also part of the Manhattan Project. So there was a lot of efforts and money pulled into computing, with the dawn of war. And you see that even today. Back in 2002, when you saw the Earth simulator arise in Japan, this was after a period where the parallel computing industry has sort of been declining. Then the Japan put out a huge supercomputer that was much faster and much more accurate for weather forecasts than they had in the US. And of course, Americans did not enjoy that they were outdone with the weather forecast, because that obviously has also military implications. And since then, I think it's been clear that the US has been back aboard, and you also seen countries like China come on board and be very concerned about having enough compute power. As far as Bull, you can still find his name on the big ATOS machines, which bought a controlling stake of a Bull SA in 2014. In fact, if you go to the Jülich Supercomputing Center, you'll see a bunch of these Bull Sequina racks that, again, you see the word Bull, which I think is pretty cool that we have that Norwegian name already still in the supercomputing field. Now, of course, we also do things in Norway. I mean, it's a long time since the 20s. And as far as, a major impact from Norway that's recent, I would say is the Phalanx microsystem that was a spin-off from students here in Trondheim and Norway that ARM bought and turned into their GPU branch. Now, ARM itself is an IP company, develops intellectual property, not actually build chips, but they are becoming more and more influential in the computing industry today. And you'll see their chips, ARMs themselves, like an M1, M2, M3 processors for Apple, and some of the Fuguki machines over in Japan. And anyway, they're getting more and more track. And of course, whenever you see an embedded device or a tablet or a small, the small chips that are inside your watches, not be these chips. And also have ARM now in Trondheim has grown to be over 200 employees. So yeah, I have several former students working there. To get this sort of a little bit of a perspective of how this has grown, when I took my PhD back in 1994, I was so happy to work on a major computer at the time, which had 128 nodes. It was known as the Kendall Square Research Machine. And the reason I was so happy because it had a total of 1 gigabyte. And that allowed me to do a million particles, simulate a million particles in a huge physics simulations looking at electromechanical vibrations. Now, 1 gigabyte, I mean, my old watch has a half a gigabyte today. So this, it's kind of funny how things have changed. And also when I was a leader of the infrastructure program here at NTNU and we bought our new supercomputer back in 2006, we were so happy to have Sarah and teraflops. Now in 2020 already, you got 97 gigaflops from this little tiny chip that it's inside your watches and tablets, right? And it also has lots and lots of cores. And of course, the Tesla cards, even back before then, could do 7 gigaflops. And to see how much power there is in these tiny little GPUs from ARM, they have a thread count these days on the Mali G720 up to 2048. So that's 2,000, a parallelism of 2,000, right? Yet we teach our students mostly programming on 1 core. And so that is my sort of pet peeve among that we have to teach them either to use libraries or teach them at least or do some parallel computing, at least think parallel. And you'll see them, as many other companies, are of course focusing on machine learning and AI these days and build, of course, that's one of the reasons they succeed. I would say both ARM and companies like NVIDIA and also Microchip is they build not only IP and computers and chips, but also ecosystems around their designs. And that's why one of the reasons that they are grand success. And they have, of course, also ARM, the SME and scalable matrix extensions. They include outer products between vectors, matrix tile storage, and streaming SVD modes. And you can see they have even SVE and SV2 that does bitwise permutes and other interesting functions that are very targeting machine learning and also a lot of other applications. I'll now step on and talk a little bit more about geophysical forecasting, which is sort of, I guess, was the title of my talk, where I would emphasize a little bit about distributed acoustic sensing, known as DAS, so and FWI. And then at the end, I hope to talk a little bit more about HPC, outer tuning, and machine learning. So my lab is now part of the Center for Geophysical Forecasting. Now, why would I be part of that center? I'm an HPC person. Well, that's because, let's face it, Norway is not going to be the center of supercomputing, but we do have very, very talented geophysicists and people related to geoscience. Norway has been a major oil producer since the 70s and has, as thus, that's where a lot of money and effort has gone. So we have very top-notch, I would say internationally renowned scientists in this area. And if it's one thing that really excites me, other than working with students, it's very exciting to work with really bright people. And that is what I get for being part of the center. And also it's fun to be able to help them achieve their goals and stay world class. We're located in the old electrical engineering building at Gløshaugen. This is a nice old building built in 1910, and we have high ceilings. And we finally opened our center in December 2020. We have lots of industrial partners, which is the center is all about, because it's called Center for Excellence in Innovation, and that means also a lot of industrial contact. We have, of course, several of the main actors within oil and gas in Norway, but also governmental agencies like Norwegian Water Research and Energy Directorate and Norwegian Public Roads Administration, as well as SICT, which is the infrastructure for internet in Norway. We also have Jamstek in Japan, so it's not just limited to Norway. We have 24 PhD and postdocs supported by the project, but there's also a lot of PhDs, postdocs that are working related to the project. And the goal of the project is that we want to have better forecasting and monitoring of the Earth itself with the with the climate change, it's very important to be able to predict accurate earthquakes, landslides, subterranean resource mapping, and also hydrogen production, of course, but not to mention underground storage of gas, especially CO2. And of course, other emerging needs that are becoming clear as the global ecosystem enters a period of dramatic change. And innovation here is creating new business opportunities for new companies and new jobs. Now, to show you the class of the people I'm working with, here's a publication from 2019, where Ståle and others here at the center did deep electric imaging of the ultra-slow spreading moon ridge. Now, what is this moon ridge? Well, it's the ridge out in the North Sea between Greenland and Spitsbergen, or Svalbard. And you can see the Gackel Ridge and then the Clipper Ridge, but also here's the moon ridge that actually has some movement. So they did a lot of seismic studies and got a nice article about understanding these moving of these, I would say, tectonic plates. Our center is organized with a management team, a board. I'm one of the work package leaders related to HP tools and techniques, which is not surprising. So it's structured as a nice big project, if you wish. And with then the package leaders spanning both from university, but also Christoph de Brenne is from, Das is actually from industry, and also from the institutes like Volker Øye. Now I'd like to show you this video that gives you a little glimpse of what we are working at the center. And plus it's nice to not be just listening to me all the time. And this is going to take me a little bit because I need to get out and in again, but hopefully it'll work okay. Let's see.
Yeah, no problem, Dr. Anne, we're here.
70% of the Earth's surface is covered by ocean. And yet so much of that is unexplored. One estimates that 90% of the species that are yet to be discovered. Why do we know so little about the ocean? First of all, it's dark and deep, and light doesn't help so much. Light only penetrates tens of meters. What you can use is something called hydrophones. They work as a microphone in the ocean. You don't get so much data from these. They're usually quite sparse. One species in the ocean that we know too little about are whales. With climate change and increasing ship traffic, we would really like to understand whales better. We can turn the ocean transparent and monitor whales by using distributed acoustic sensing. We have a network of fiber optic cables covering the world. Distributed acoustic sensing works by turning these cables into very long lines of virtual hydrophones. To record this data, one injects light pulses into a fiber cable. Some light is scattered back from impurities in the fiber and can be received by a DAS interrogator. Acoustic sources, such as whales, radiate oscillating pressure fields that stretch and compress the fiber. Variations in backscattered light tell us about the acoustic pressure fields at different points along the cable. This means that we can listen to the ocean at many separate points, creating tens of thousands of virtual hydrophones. This data is available immediately ashore at the end of the cable, so we can listen to the ocean in real time. Here you see two fibers going out from Svalbard, and this shows the stretch in the fiber.
So you can now see the two first whales talking.
Then the middle one is vocalizing. That was one to the east.
Yeah, so right now we have three vocalizing at the same time.
Distributed acoustic sensing can revolutionize the way we understand and listen to the ocean. But we can go further than that. We can understand mechanisms of earthquakes, risks of landslides, avalanches, floods. For the ocean, we already have more than 1 million kilometers of fiber optic cables. What if we can use this as a global monitoring system?
Very interesting, Professor Anne. I'm looking forward to the next part of the talk where you explain this.
Okay, thank you. So as you can see, there's lots of things that can be used in this technology developed for the oil industry. So they actually developed this technology because they're worried about the trawlers ruining their cables, as you know, that went out to the oil platforms. And that's sort of the background for this. And it was done by Alcatel, now bought out by Nokia. It's a little local company here in started as a little local company here in Trondheim. But you know, this distributed acoustic sensing is now used in many different ways in different fields, but it, as you can tell, provides tons and tons of data. And that's one of the reasons we need both HPC and AI. And to be able to do landslide and earthquake monitoring, CO2 storage, or ecophase monitoring, we need to you know, use these kinds of techniques. One of these papers that was first papers we did on this was source level vocalizing depth estimation of 2 blue whales. That was done in the Indian Ocean from a single sensor observation. But, you know, you can also take it further. And like I say, Beaufort et al. Did in Frontiers of Marine Science in July 22, a nice article that really also describes this DAS and what we can do. And there's been several publications after that as well. In addition to having this exciting technology like DAS to work with, we also have several very cool labs set up. Our lab no longer has the DDX2, it died on us, unfortunately, but we still have several GPU machines that, in addition to the ones, of course, that are available to us locally and nationally at our computing center and at our international computing center, for instance, the Loom machine in Finland. We also have a CO2 lab that's really cool. I'll mention it a little bit more later, and several other nice labs that are kind of verifying some of the geological science stuff we're doing. Here's a picture from the CO2 lab where we're kind of simulating, you know, the layers of the earth and how you store them, and lots of sensors and sort of being built that will match the Sleipner model, which is the open data sets from Equinor, it used to be called Statoil, that have an open geoscience data set that we can work on, and anybody else can work with. It's freely open to the public. Finally, I want to talk a little bit more about HPC, auto-tuning, and machine learning. So HPC is a lot of things, everything from small fast processor, multiprocessors that you find on edge computing to, you know, these new GPUs like the AMD Instinct. Well, this is actually an older Instinct. This is the MI 250X, which you find in the Louis supercomputer. And also, as you know, the more recent NVIDIA H Hopper GPU. And now NVIDIA has now teamed up with ARM. They actually tried to buy ARM, but weren't allowed to also develop their Grace architecture, and I'll mention a little bit more about that later. So one of my current PhD student did for his master's working on accelerating the pFlowTran code using integrating it with PETSI, integrating with an already parallelized library, and showing how when you integrate good libraries with, you know, complex simulation codes, you can achieve a lot of speed up. And this was just what he did for his master's, and we also presented this work at a local conference. The full waveform inversion, or FWI, is also a technique that's used and very challenging. It has numerical models that needs a lot of compute power. The standard CPU doesn't quite cut it. You need to use some GPUs or other parallelization techniques. And they can be used in several areas, from CO2 sequestration or storage to earthquake time simulations, and et cetera, et cetera. And these are some of the areas we will hope to work on together with our partners here at CGF. Now, as far as parallel computing, I think the most important for those of you who are not directly related to parallel computing is to understand what an impact memory now has. The location of data is actually key for any speed up of code. Now, if you lose the floating point optimization, you can get a factor 2 of in-cache. But if you have to go out beyond the actual local registers and cache, you can hit 10-fold or 100-fold or 1,000-fold or more. And this is like very old numbers that you see from code, from a Cornell slide you can find along. But you can see these numbers are not getting any better as far as how much slower the memory is versus processing speed. So if we want to program for performance, you really need to focus on 3 things. That is to keep your registers busy with caching and reduce memory access. Maybe you even need to use your GPU or any other device to do compression and decompression to keep them busy, right? You also might need to move the compute to the data. So you saw the DAS video and all that data coming in at the interrogator on LAN as you receive it. And you probably should do some compute to prune your data, because otherwise it will just be too much. You just can't handle storing it. And you can certainly not handle transmitting it on slow airwaves. And computer science itself is not dead. You know, your algorithms class is extremely important, and you really need to pick the right algorithm. And picking the right algorithm in parallel computing may not be the same as picking the right algorithm on a serial machine that you were taught in college. Because it turns out that because of the memory access, you need to really pick the right algorithm for that. And that may actually mean doing more compute to avoid sending data back and forth all the time between the processors. And that's why I like to say, optimizing for performance, it's like real estate. It's all about location, location, and location. Come il prezzo degli immobili, as they will say in Italian. That was a very bad pronunciation of Italian. I'm sorry for those who are Italian out there, but you get the idea. You know, you need to, keep the location by getting those registers busy, keep the data in their registers as much as you can. You may have to do some processing, have the right location of your processing, and you need to have algorithms that are location aware. So it's all about location. I wrote a little article, my grad student Hagdal, on some highlights of the new NVIDIA GPU and CPU. And there you see how sometimes not technology is the one that drives what technology we end up using. There was a big lawsuit in 2009 between Intel and NVIDIA that ended up with Intel paying NVIDIA over, I think, about $1 billion. And of course, they used that to build up their company and their ecosystem. But then Intel was able to keep them off, accessing their compute sources directly. So all the NVIDIA devices were, relegated to the PCI Express bus. And that has, of course, slowed CPU, GPU compute. But as you know, they now have developed their own, or, together with ARM, an ARM-based Grace chip that is highly integrated with their GPU, especially since they also bought Mellanox, which was an Israeli company that did very fast Ethernet, or internet networking, I should say. So things are changing, and there's a lot of opportunities there because things are changing so much. And so stay on the lookout for that. And the other things that are changing is in a language from MIT called Julia. And we looked with our students back in 23 how we could improve SPH simulations for snow with using Julia. At the time, Julia was fairly new, and we noticed that you really had to basically know as much CUDA as before to get Julia to do what you want. I mean, it hides some of the details, but unless you know what your system can and cannot do, you're still not going to get the speed up. And that is one of the biggest problems with abstractions in general in parallelism. We will like to make a very high level abstractions, but if we hide especially communication in our libraries and people don't understand where the data is, you're still going to be hurt. It isn't to say that everything we've done in Julia is unsuccessful. I had a student I worked with here on efficient processing of DAS data, We did an anomaly detection using autoencoders, so it's some proxy applications with that. And in this case, the student was very enthusiastic about Julia and did nice work. But like I say, there's still, you need to be clever about it in order to succeed. Here, his main advisor was Ole Jakob Mengsel, who is a professor in artificial intelligence here at NTNU, who used to work in AI for CMU, Silicon Valley, but now has been several years here. We also have an AI conference coming up in Trondheim. So has a lot of major conference coming up here. And so this is, exciting if you want to come here in March. There's lots of interesting sections. And let's see, why is it not moving? There are some late-breaking full short papers that you can actually contribute in a few days if you still have something you want to. If you want to have an excuse to come here and have something you want to publish, this is your chance. I also want to just quickly show this highlight from supercomputing that I just attended last month. You'll see that one of the things they did at Oak Ridge would look at JAC, which is a shared exploiting high bandwidth on-chip GPUs memories. And that sort of refers back to what I was saying about the development happening in the field. So obviously the big labs in the US and others are now looking at this. And you can see they are also looking at the performance portability model of Julia to see if they want to use that. So that's a to-do list for them. And they have a GitHub site and places you can look for interesting projects. HPC, I feel, has enabled AI. Without the AI, without our HPC, there wouldn't be auto model generation like you see in AI today. You'll be more back in the ages when I took AI as an undergraduate. Well, it was a graduate course, but at my days in the mid-'80s at the University of Massachusetts, where we focused on expert systems back then. But you can also see, hopefully from this presentation, that AI can also work for HPC. So there are things that, if you, for instance, back in 2015, we looked at how machine learning can improve auto-tuning of GPU codes and got some nice results. And of course, you could do much better today, but this is like interesting how we even looked at it back in 2015 before the mega hype. And you have several little results you can look at later. We've also looked at the current, get an overview of the use cases, how machine learning can help aid, of course, geophysics. And there's a list of our manuscript under development where we're listing all kinds of different domains within geosciences, which ML techniques are used and which are the applications. And like I say, this is a work in progress, and we hope to get this review paper out in not too long. You can also see how you can combine AI and DAS by finding the peaks and local maxima, hopefully somewhat automatic doing these training. And we also have provided with from my master's students a benchmark suite for auto tuners, because one of the things we do focus on in HPC is tools for HPC, and one of those is how we can make compilers more auto-tune your programs. And then we need to figure out how well do these auto-tuners actually work, and that was not a data set that was available before, so that we've also worked on that, and then have tested various of the major auto tuners out there, like OpenTuner, Kernel Tuner, KTT, and CLTune. And since I'm now getting towards the end, I would like you, if you want to hear more about what my research is and what I'm doing, and because you can come to my keynote in Trondheim, actually Tromsø in May next year. Now, Tromsø is a very exciting place, maybe not this time of year because it's very dark there, unless you really like auroras, then that's great. But in May, it's near our national holiday, the May 17, which has big parades all over Norway. And as you can see, This conference is the 19th to 22 of May. So if you come to Norway, I would strongly encourage you to arrive on the 16th, spend either the 17th in Oslo, which has the biggest parades, here in Trondheim, which have 3 different parades, or go to Tromsø itself, which I'm sure also have parades. It's our National Day is very well celebrated with lots of flags and parades. And not to mention, this is a very cool conference on cluster cloud and internet computing. And most of all, I think it's important to work on something that makes you have fun. You know, be excited about what you do and pick the topics that really excite you and dig deep. And you'll have a lot of fun. And thank you so much for attending my talk.
Thank you very much, Professor Anne, for the very interesting lecture and ideas. First, I would, of course, ask the audience if anybody have questions for Professor Anne. If you have any ideas we would like to discuss or any questions.
Yes, thank you, Professor Anne. Thank you, Dr. Maggie. For myself, I have a very, I don't know if it's question or concern, but how do you see the upcoming years with the high performance computing and its impact on the climate change and sustainability?
So, of course, that's a big concern of a lot of people and have been for several years already. As we scale out HPC to especially handle these large language models, there's no question that, you soon need a nuclear power plant for each of those sites, right? And already big sites, people don't think about every time when you Google something, you're actually using some milliwatts of power, right? I mean, because these big search engines now, if you then try to do it on ChatGPT instead, then that will, 10x or 100x the amount of power to use than rather just Googling it, right? So, of course, this is a concern. And of course, there's a lot of work done in the computing industry to reduce power. I mean, that's why we got GPUs in the first place, because they had these very simple processors that you could replicate that spend a lot less energy than if you put it on a big rack, big old rack computers. We could get, thousands of processors using at least, maybe 1,200 watts on the, they're not talking about several GPU cards, but, on a server, it'll be much worse, right? So there's a lot of work done in that. And of course, I have my concern. And I don't think it's the HPC part itself. It's is the demand for HPC, right? The demand of the large language models. And I think we need some thinking and policies on how many and who should derive these big language models and for what. And that has to be a concern, no question. But we will continue in HPC to try to improve the energy efficiency. And when you improve performance, you generally also improve energy efficiency. And when you improve location, you definitely improve energy efficiency because it's very expensive to move data, right? So that, takes off a lot of energy if you can do things efficiently. I like to give the example of Charles Lysenson in his performance engineering course. Tells you that if you write a Python code, just a double loop to multiply 2 matrices in Python, that most programmers think that, oh, I know how to do that. I'll just write this little loop. Well, that loop can be optimized up to 62,000 times if you convert it to C and use a library or are very good at optimizing yourself using, high-end HPC techniques. And that's on a single processor. You get a speed up of 62,000 from having written that double loop in Python yourself to actually calling a library or optimizing your code itself. So this actually should be a wake-up call for everybody writing Python, unless you are writing, using the NumPy library at minimum, and even the NumPy library is not that great, but at least a whole lot better than just a double loop in Python. This tells you why you should care about HPC and how it will help you. How's that for an answer?
Thank you so much.
Very insightful. Yes. And I totally relate about your discussion on the cloud data centers, the energy efficiency and the location of the data. That has been a very hot topic in research since forever. I've done my PhD on that, so I can really
Yeah,
feel
exactly.
the problem. Yes, it's a long problem since forever. So our next question will be from Dr. Imna. She's asking, what are the main challenges you have faced with AI in your field?
Well, I guess the main challenge is that everything is happening so fast. That's number one. And number two is that more and more AI research, as far as at least this large language models, is now being hidden inside proprietary companies. And if you talk to AI researchers, they themselves don't exactly know what's happening on the cutting edge inside of those companies, or if they even have much cutting edge. I mean, it's very obscure, right? I think those are my two main concerns in AI right now. And as opposed to, well, of course, what it can be used and abused, and the whole idea of, profiling, if you give AI a lot of data that has a lot of bias, like for hiring, and if you always, in the past, all your successful employees were male, because that's the only thing you hired, well, guess what they'll do to women applicants if then they apply, right? Well, in the past, obviously they were young, certain types of males, so we will just throw out all the women, things like that. I'm over, exaggerating a bit, but I think you can see the bias issue with AI. And another thing with AI is that you have to be very careful with outliers, because are there outliers due to just a random mistake that then can really mess up your data and corrupt your data? Was it just a corruption? Data corruption, or was that the really interesting thing, that the case that you hadn't handled before that really needs to be paid attention to, right? Big challenge.
Yes, that's true. I guess this answers Dr. Imna's question. We still have a couple of minutes. If I can bring some very interesting ideas you brought up in your talk, Professor Anne, which is AI powering HPC, or is it the other way around? Is HPC powering AI? That's a very interesting discussion. So I believe they are both growing together. So we need this for that. So this is how both of them are growing. Maybe if we did not have HPC, we wouldn't have AI. And if AI was not advancing so fast, we would not have also so much advancement in HPC. It's a very interesting idea that you brought into the talk. Thank you for this. Also, the comparison or the expression of comparing the programming for performance to real estate. That's very relevant. It's a very easy way to explain it for non-computer scientists.
Thank you. Yeah, that's exactly, those are two of my main points, and like I say, a lot of people, at least in the US, think about location, like it, your price of your house is going to vary a lot with where it is, right? I mean, no matter what the quality, the same goes for compute. I mean, you can have the best quality data, but if it's far away and takes a lot to load, it's going to hurt you, right? So, yeah.
So it's a perfect analogy to explain it to anyone. And finally, the logo looks great. I have to mention that.
Thank you. Thank you. That's thanks to my daughter. And here's the logo, the previous one she did. She did back in 21, which has some more detailed long shift, but I like her new stylized logo.
Yeah. Yes, it's very nice. It's great that's coming from your daughter, so I had to acknowledge that as well.
Yes, and I can actually reveal that my own daughter is now in college. She's a sophomore back at University of Massachusetts Amherst, where I myself got my degree, and she's now part of an exciting program that I hope we can replicate elsewhere called Breakthrough Tech AI, where they gather top minority students. In this case, was initiated by Cornell, and at their now group once a month she takes the bus from UMass into MIT, where she has an MIT mentor, one of the PhD students at MIT, together working with an industrial project. In her case, she and four others are working with MathWorks and company behind MATLAB on an AI related project. So these are things ideas I can mention you can do that I'm not involved in, but at least she is involved in.
Yes, that's very impressive. So we would say like daughter, like mother in this case.
Oh, thank you. Also like father. My father is pretty bright.
Wow. Okay. So you're a really smart family. I would have to acknowledge that.
Thank you.
That's great. Thank you very much, Professor Anne, for your insightful talk and discussion. I'll now hand over again to Professor Islam.
Thank you.
Thank you, Professor Anne, Professor Maggie, for the great presentation and moderation. Thank you so much.
You're welcome.
I think we can move to the next session, which
Absolutely.
should be moderated by Dr. Emna and my colleague Amani.
Let's see if I can
I think
relinquish
we have
myself.
just 5 minutes, so it's
Okay.
good
I need to
also
get out of here.
to play some videos from the Distinguished Visitor Program, so allow me.
Yes. Can you stop my share, or do I need to figure out how to do it?
I think you can stop sharing your screen.
Yeah, I'm trying to get my cursor to do the right thing, and I'm not getting it.
Okay. Or anyway, Professor Islam, you'll be playing some videos?
I will check. I will do them.
Okay. So, okay. Don't worry, Professor. And Professor.
The IEEE Computer Society's Distinguished Visitors Program.
Is it okay?
I think
Is it okay?
Yeah, please stop my share.
It stopped. It's now stopped. Now Professor Islam is sharing videos.
Delivers tools for individuals at all stages of their professional careers through visits to chapters, offering opportunities for individual interaction, and to the membership through webinars by respected professionals. We have distinguished visitors who cover machine learning, cybersecurity, robotics, big data, cloud computing, blockchain, and cryptography, among others. Chapters can request a distinguished visitor on computer.org/distinguished-visitors. The Computer Society pays intercity travel, while chapters are responsible for all costs with regard to the hosting of the distinguished visitor, such as lodging, transportation, and food and incidentals in the city of the presentation. The Distinguished Visitors Program is able to pay up to $1,000 for a visit to a chapter, but by working with other nearby chapters to develop a tour, that amount can be increased. So when your chapter is planning its next event, think of the Distinguished Visitors Program.
Hi, I'm David Allen Greer, the IEEE Computer Society President for 2013. And I'm here to talk about the community of professionals that you join when you become part of the IEEE Computer Society. Usually when we talk about the benefits of joining the society, we talk about those things that you see flashing over my shoulder right now. We talk about the digital library. We talk about standards, periodicals, continuing education materials. Those are all benefits, to be sure, very real benefits. But people will say, I get the digital library at work, so I don't need to be a member. Or I get periodicals in other ways, so I don't need to be a member. I have exactly one standard I ever use. I already own it, so I don't need to be a member. Those arguments have some truth in them, but they miss out the point that you are investing in your professional career by being a member of the Computer Society. You're joining a community of people who, for over 60 years, have worked to advance this wonderful technology that has quite literally changed the world. And when you join them, all you do is need to make one connection a year, and that will be an investment in your career, in how to be a professional, how to see where the community is going, what are the new trends, how you should behave yourself, how you should think as a professional computer scientist, computer engineer, software engineer, or other information professional. These are the benefits. These are the real benefits. You're investing in yourself when you join, because it's through these connections that you really learn to be a professional. Information? You can get that on the internet. Professionalism? You get that from the IEEE Computer Society. We have a web page below that you can click on to renew your membership. Thanks for listening. Take care.
Computing is expansive.
Computing is evolving.
Computing is limitless.
We are the IEEE Computer Society, the professional home for all computing.
We bring together passionate engineers, scientists, academics, and industry to cultivate environments for idea exchange, dialogue, debate, and collaboration.
We set the standard for learning that empowers, with peer-reviewed publications and international conferences, local chapters and meetings, and valued resources.
We support members, we cultivate leaders.
We help computing professionals at every stage of their career.
We are the IEEE Computer Society, your professional home.
So thank you so much for being here today, and it's our pleasure. And now I'm moving to the next session. So I'd like first to welcome Dr. Emna. Dr. Emna is a PhD, is a computer science lecturer and specializing in machine learning with a focus on applications such as environment monitoring and oil slick detection. An active IEEE volunteer, she's an active DVP program and a member of the France Section Computer Society chapter. Additionally, she chairs the Young Professional Affinity Group in France. Dr. Emna is doing great work with us in the Region 8 Committee and the DVP, so I'm glad to welcome you. And also, of course, Amani, so I will leave the floor to you.
Thank you a lot, Dr. Islam. Are you hearing me well?
Yes, yes.
Thank you a lot. Good morning, good afternoon, good evening for all of you. I am Emna Amri, as Professor Islam presented. I am a university lecturer at computer science, and today we are going to have our speaker, Miss Amani Shaban. She's a network and security engineer working in a company entitled One Tech Business Solution. She's an active member at IEEE, particularly in computer science in the Region 8, and she is representing the DVP program, ACA Digital Media Lead. So, Miss Amani, if you are ready, you can share your screen.
Hello everyone, hello Anna. I'm going to share my screen right now.
If you can please talk a little bit loudly, I'm not sure we
Can
are
you
hearing
hear
clearly.
me?
Now it's better, yeah.
Okay.
The floor is yours.
Yeah, thank you, Anna. Can everyone see my screen now?
Yes, we are seeing it.
Okay.
Perfect.
So welcome everyone. Thank you for joining this session about IEEE SYP. Like Emna said, I'm Amani Shaban, a network and security engineer at One Tech Business Solution, and currently serving as the IEEE Sales DVP EXA Internship Portfolio and Managing Media Media Manager. I had the honor of being the chairwoman of the ENIC student branch in 2021. OCA host and organizing the TSYP 2021 and 2018. The activities with IEEE never stops, right? So I'm here to share with you insights into IEEE SYP and its opportunities. Actually, sorry, because I can't open the camera. I'm working in security department, so it's not allowed for us. Hope my voice is clear, at least. Okay. Let me walk you through the agenda for today's presentation. First, we'll discuss what is IEEE SYP. Next, we'll explore IEEE SYP categories and highlights covering regional SYP events. Then I will share the key benefits of being part of IEEE SYP. Following that, I will explain how you can get involved, whether you are a student or young professional, and the steps to maximize your IEEE membership. Finally, we'll have an open Q&A session where you can ask questions and share your thoughts. So let's dive in. IEEE SYP, which stands for Student and Young Professionals, is an initiative designed to connect and support two key groups within the IEEE community for students, or as it stands for students, to provide a platform to access resources, participate in academic and industry-related competitions, and build a foundation for professionals' growth. And YP stands for Young Professionals, those within 15 years of their first degree. It offers opportunities for career advancement, leadership roles, and networking with peers and experts in the field, of course. As purpose or goal, SYP is bridge academia and industry, foster growth, and build global connections. So now that we've covered what IEEE SYP is and the overarching goals of this community, let's dive into the regional SYP events that help bring these goals to life. The events are designed to foster collaborations, provide professional development opportunities, and create a terrifying network of students and young professionals across the world. So starting by the known Region 8 SYP, is the Region 8 Student and Young Professional Congress, the largest event in Region 8, held every 2 years. This Congress brings together both students and young professionals from all sections of the region, of course. The event's primary goal is to enhance engineering skills and capabilities through various technical and cultural activities, while also providing an invaluable opportunity for networking. The main aim of SYP is to bridge the gap between academia and industry, we can say foster career growth, and create a strong global community of engineers. This Congress is a true testament to IEEE's commitment to the professional development of its members across Europe, the Middle East, and Africa. Our next activity or Congress is North Africa SYP, which has now merged into, this is some previous versions of the SYP. And next one is the North Africa SYP, which has now merged into the broader MENA SYP, has always been about empowering professionals in North Africa by focusing on regional challenges. NASYP provided opportunities for young professionals to come together and discuss solutions. Now, under MENA SYP, this collaboration has become even more expansive and impactful. So MENA SYP is the Middle East and North Africa SYP unities, two vital regions creating an event larger platform for young professionals and students to learn from one another. It combines technical discussions, cultural exchanges, and leadership building activities to create a stronger, more integrated, of course, professional community. Actually, the call for proposal is now open. We encourage everyone to submit their ideas, and we are excited to see any student branches for your section hosting this Congress in 2025. And moving to our next Congress, which became my favorite one actually, CSSYP. One notable achievement in the SYP community actually is the first ever Computer Society SYP held in Egypt. The day days before. This thematic event was termed a success, bringing together the best minds in the field of computing. It featured workshops, research presentations, and collaborative discussions on the latest trend in technology. The event emphasized technical excellence, innovation, and the power of collaboration in the computing industry. So as you can see here, these events play a good role in connecting individuals from different regions and providing a global platform for growth, for networking, and of course for learning. Let's talk now. Why should join IEEE SYP? It's not just about attending events. It's about many benefits to accelerate your career and personal growth. So we can mention personal development. So through webinars, workshops, because we have sometimes online sessions or on-site sessions in SYP. So these webinars or workshop and technical training, IEEE SYP helps you enhance your skills. You'll also receive career guidance and leadership training, preparing you for success in the industry. Also, we can mention the networking opportunities. Being part of IEEE SYP means connecting with peers, industry leaders, and mentors from around the world. This is my favorite part, actually. Through congresses and events, you can build strong global professional network, and the mentors are always open to talk with them and exchange knowledge. So resources and tools. I mean by that you'll get access to IEEE publications and standards, often for free or at a discounted rate, along with tools that support your research, education, and career growth. For me, this really helps me in my end of study project. Okay, and for leadership growth, of course, there are countless opportunities to lead initiatives within student branches or young professional groups, helping you develop critical leadership, project management, and teamwork skills. There is always like workshops in group and helps you get more charging in teamwork. So global exposure with events like Region 8 SYP, MENA SYP that we mentioned before, you'll gain exposure to an international community. These events allow you to showcase your work and gain new insights from diverse perspectives. And finally, awards and recognitions. As an IEEE active member, you're eligible for scholarships, travel grants, and project funding. Will also be recognized for your contributing to technical excellence and community service, which can significantly boost your career. Now that we've discussed the numerous benefits of being part of IEEE SYP, let's take a closer look at how you can get involved, whether you are a student or young professional, and start making the most of these opportunities. Here's how student and young professionals can get involved. So students join IEEE as student members. Becoming student member allows you to access a range of resources and participate in IEEE events tailored for students, participate in events, attend technical workshops, seminars, and congress, such as Region 8, SYP, and etc. And for the students can volunteer for leadership roles. They can active role in your student branches SP or IEEE section. You can help organize events, lead initiatives, and grow your leadership skills in your section or even global in your region. About young professionals, You can become a young professional member after graduate, of course. If you are within 15 years of graduation, join as a young professional member, provide access to resources to relate to early career growth, of course. Attend YP-specific programs. You can engage yourself with this, participate in programs focused on career development, technical training, and networking that cater specifically to young professionals. Leverage professional development resources like IEEE tools, including workshops and webinars to advance your career. And sharpen your leadership skills, and of course, build a strong professional network within IEEE Computer Society or in region, global, wherever you want. When there is a call for proposal for IEEE SYP event, you can check the IEEE site for volunteering opportunities. The IEEE platform frequently opens applications for positions in the organizing team for various events, such as congresses and workshops. These positions gives you the chance to contribute to event planning, organizations, and execution, while also gaining valuable experience and building connections in the field, of course. To apply for these volunteering roles, visit the IEEE website and look for the volunteer section, where they list the available positions during event planning cycles. It's an excellent opportunity to become directly involved with IEEE SYP events or any other events, okay? So you can also explore leadership's role in these events, which will help you develop essential skills while contributing to the success of IEEE initiatives. Well, thank you for attending this session. In the end, I would like to share a bit of my own experience with IEEE SYP. I was part of the organizing community for the SYP 2022 in Tunisia, and I was also one of the founding members who attended the first ever CSSYP Congress. Both experiences were unique and valuable, but I learned a lot more during the second one. Traveling for the first time, getting on a plane, and interacting with so many young professionals was an eye-opening experience. As a new YP, also I made it a point to engage with other YPs, share knowledge, and network. The sessions in the Congress was also about cybersecurity, my field of expertise, so made the experience even more enriching. It was a perfect blend of learning and fun, like having fun and learning at the same time. What could be better than that? And I want to thank Mr. Islam for this opportunity. The fund and attend this Congress really was my favorite experience. So I encourage all of you to get involved, whether as a student, YP, or as part of the organizing committee. Take the opportunity to attend or volunteer for the next congresses, and let's meet there. Just go for it. You will gain so much and have an unforgettable experiences. Thank you.
Thank you, Ms. Amani, for this presentation. Let's move to the question. If one of you have a question. Any question from the audience? I can start a small question, Ms. Amani. As you have a lot of experience on like events related to computer society, why do you think the opportunities for diverse people, for example, for students, for YP, what if we are senior member, what if we are like in another level of IEEE? How open are these kind of events such as the SYP you have mentioned it, or the technical SYP, which is the Computer Society SYP? What is the difference between both of them, for example, and what is your recommendation for like guidance if you want to participate? Which one should we choose based on what? I hope the question was clear. Miss Amani, can you hear us?
Hello?
Yes. Did you hear the question or not?
No, please can you repeat your question, sorry?
No problem. So I was asking about what is the difference between the Region 8 SYP and the Computer Society SYP, and how, for example, to a student or to a YP member of IEEE, or maybe a senior member, what is the difference, and what are your recommendations for participating to such events? Based on what should we choose, for example, SYP or Computer Society SYP or others? What are your advices regarding that?
I'm afraid she must have some connection issue or something like that.
Yes.
So.
Yeah.
Can you hear me? I don't know.
Yes, we can hear you now.
Okay. Maybe for the SYP serves a broader audience across multiple engineering field, like it is global. But like CS SYP focus specifically on the computer science and related technology. So if you want to choose, maybe it's depend on your field. Like both offer development opportunities, but maybe like CS SYP is tailored to those in the computing sector.
Okay, that's clear. So it's whether technical or non-technical, like diverse subjects such as the SYP. Thank you for your answer.
Thank you.
I believe in Central European time, it's the lunch break. That's why we are losing. Yeah.
No problem. I think I can utilize the remaining minutes to share some
videos, yes, for the
SYP.
yeah.
Okay,
Absolutely.
so let's share, because for Region 8, as you may know, I'm the regional coordinator. We have conducted many activities and provide several opportunities for the students, especially. So I might just quickly share. I'm not well prepared for this, but I can share maybe my LinkedIn profile and find some to share. For the, as mentioned by Amani, the first CSSYB, it was conducted this year. Also, the Distinguished Visitor Program, by giving their talks, their interaction with them. We have several interaction with the students. Also, we have provided many opportunities to them in participating in our engagement. So, for example, by engaging in the Women in Engineering Summit, there are some competitions for the students. So it's really important to engage the students, and there are some prizes for them according to. So the technical sessions are important because they are reshaping or reforming their. By the way, we have also some recognition for the outstanding chapters who did a lot of activities, and as you can see, Dr. Adel from US is meeting with some students from Brazil. So this is the opportunity to meet and interact shouldn't be done without the support of the IEEE Computer Society. In addition to that, we can share your journey context, which is supported by the Computer Society, and allow invite some of the students and professionals to attend the Region 8 Congress. Also, we have we did several activities with the students. They were supported with their subscription for the time being. This year, they IEEE Computer Society provided fully waived registration for the students for the Computer Society membership. So 100 discount for their membership in the IEEE Day. And we were glad to meet a lot of students and encourage them to participate. So different activities are provided with the students. Those some students, by the way, the Jordan, there are Jordan student was awarded this year the best chapter in Region 8, and this because their outstanding activities with IEEE. As you can see, they did great tasks this year. Also, we include some students and young professionals in our talks, as we can see for the time being. Finally, the Region 8 Congress, the first one, and our maybe colleagues from all Region 8, and especially those who were awarded the Sharing Your Journey context. So there are a lot of opportunities that are provided to the students and young professionals. So also I can share with you some maybe thoughts from one of them. Semenia is a great volunteer for the Computer Society. I think we have just
in meantime, we have a question from Dr. Abdulrahman. He mentioned, how can I register in it? Which event you want? Which event you're meaning? I believe he's interested in the events you have displayed, the variety of the events.
If you are talking about the Region 8 SYB Congress, CS SYB Congress, so I just finished 2 days or 3 days ago. So hopefully next time we can invite you. If you'd like to follow up, you should follow up our LinkedIn and social media pages, so you can be aware of all the opportunities. So I'll make sure to share it with you on the chat. So let's just see this great video.
It all started with a spark of curiosity in 2022 when I came across the IEEE Extreme Programming 16.0 competition. The idea of joining thousands of coding enthusiasts from around the world for the 24-hour coding competition was too thrilling to resist. Little did I know that this event would mark the beginning of a transformative journey, one that would take me across continents, connect me with brilliant minds, and open doors to endless possibilities within the IEEE community. Soon after, I co-led the formation of Ghana's first IEEE Computer Society student chapter, a milestone that came to fruition in December 2022. This wasn't just about establishing a chapter, it was about creating a space where students could explore their potential in tech with the support of a global community. This chapter introduced us to countless opportunities, and I quickly realized that the IEEE wasn't just a platform, it was a family, one that pushed us to aim higher and dream bigger. One of my fondest memories was participating in the IEEE Try Engineering Math during the My Robot Friend workshop at Caris Primary School, where we met and mentored kids who were eager to learn about robotics. Together we built robots that inspired future engineers. From organizing tech workshops to attending international conferences, IEEE provided the perfect avenue to blend my passion for tech with real-world impact. Attending the Region 8 North Africa Student and Young Professional Congress in Cairo was another great opportunity. Meeting tech enthusiasts from across the region wasn't just inspiring. It became the foundation of future collaborations. The friendships and connections I made at this Congress were instrumental when I took on the role of Uganda Section Lead Ambassador for IEEE Extreme 17.0, where I recorded the highest participation in our section's history. This incredible team effort resulted in my nomination as one of the best Extreme section leads for version 17.0, a testament to the strength of our collective ambition and collaboration. IEEE's collaborative spirit greatly enhanced my journey, connecting me with a global network of experts, volunteers, and top leaders, including IEEE presidents and society executives. These interactions provided invaluable knowledge, mentorship, and lasting friendships, which fueled my passion for volunteering. A defining moment in my IEEE CS journey was being awarded the Richard E. Milne Scholarship, becoming the first recipient from Uganda section. This was a dream come true. I have also had the privilege of mentoring other students who have gone on to win the REM Scholarship and witnessed the continued growth of the CS community in Uganda. This year's highlight has been volunteering as the CS SYP TechX lead, where I've worked with a diverse and dedicated team that has expanded IEEE CS career development programs to over 2,000 students and young professionals across the 10 IEEE regions. Through TechX, we've hosted more than 17 events in Tunisia, Kenya, Jordan, Colombia, the US, Brazil, India, and Australia, creating a platform for networking and professional growth. What makes the IEEE Computer Society truly special to me is its emphasis on leadership, volunteering, and technological advancement. The society offers opportunities to make a tangible impact. In reflecting on my IEEE journey, it's clear that each milestone was shaped by the support of others, whether it was forming a student chapter, attending international conferences, or leading major initiatives. None of it would have been possible without the collective efforts of fellow volunteers, mentors, and friends. This journey has taught me the importance of giving back, and I hope to continue inspiring new volunteers to take small steps that lead to meaningful impact.
So thank you so much for being there. And I think it's your time, Dr. Emna, to share your thoughts and ideas about the DVP.
Yes, thank you a lot for these amazing videos. We are seeing like really very active people in IEEE, and how can we go so far with IEEE? Let me just learn how can I share my screen. Can you see my screen?
Yes.
Let me put it on up. Is it all fine for you?
Yes.
I can
Perfect.
see.
Thank you. So I am here today to present to you a particular program of the Computer Society, which is Distinguished Visitors Program. I'm going to give you an overview of what it is, what is the mission, what is the vision, how can we use it, and how really, as a member from IEEE, you can get access to a lot of opportunities. So I'm going to go in a little bit into detail on who I am. So as Dr. Islam mentioned, I am a university lecturer at CSI Engineering School in France. I have a PhD in computer science. I am very interested in working on real-world applications that touch to machine learning and to environment. I have been working on waste management, on pollution detection, plant detection, so various applications. You can check out my Google Scholar here for my research. And I have discovered IEEE like a few years ago. I started being very active. I really fell in love with IEEE when I attended a first SYP event where I just received a full funded participation after just submitting a form. It was like extremely easy. I just submitted the form and then they accept me to go to the event for the whole week to meet people from all over the world, all over the region 8, which means Africa, Middle East, and Europe. And that was like, oh my God, I am missing something here. So since that day, I start being involved in IEEE as a YP member, as a Computer Society member, because that's my really field, technical field. And for today, I am like the Region 8 representative for the Awareness and Customer Advocacy, which is a part of the committee of the DVP. I'm also the chair of the Young Professionals in France section, and I am a member of the Computer Society in France section. So let's start. I want you all, please, to scan this code. Let's start to know each other first. If you can scan this code, I will give you 1 minute to scan it. So we can know a little bit about you before starting. It's going to be a question, where are you joining us from? I hope. Is it all fine for you? Scanning it. We will reuse it also by the end. So please keep the tab open. I'm going just to display the question. After 1 minute, up. Please, to those who are still sleeping, please scan this code so we can know about you before starting. Up. Let's have a quick look to up. I hope you all get the QR code. If not, tell me, I will reshare it again. It's loading a little bit. So the question was, hi, where are you from? So today we can see the majority are from Egypt. Very big hi to Egypt for their exceptional work, which is hosting and organizing the first Computer Society SYP this year, like a few days ago. It was amazing. I were there. It was really like amazing event. We can see people from France, including me, Turkey, Tunisia, still diverse, which is what is exceptional about IEEE, that you find always diversity in everything, in origin, in origin, in field, in everything. We are so diverse. We are like a diverse family. Like Siman just mentioned it in his video just before me. He was mentioned it's not only a community, it's a family, because by time you will be seeing people in each event, which is amazing. So nice to meet you all and welcome. Welcome to this session. So let's go to the purpose of this presentation. So what is this Distinguished Visitor Program? What is it about? So the purpose of this initiative from the Computer Society community, it's first to provide to the Computer Society chapter access to top technology and experts for lecture and technical talks, which mean you are like a small chapter in a section, Tunisian section, French section, or whatever. You want to access to high level people, let's say an engineer from NASA or from Intel, to come and give talks, technical talks, like face-to-face talks or online talks. So this program offers you this opportunity. Second thing, it facilitates knowledge sharing and collaboration. Once you have access to very high level people, it's not only about accessing and seeing them lecturing, like as just seeing YouTube videos. It's also interacting with them. You can have questions, you can have feedbacks, you can have their contacts, like you can have them on social media also. The third thing, which is promoting cutting edge research and innovation. So as IEEE, it's always like up to date with the technology. You will have always speakers. The speakers are really selected like really carefully. You will have speakers from all the field, like you have a diverse field, and you will have speakers that are up to date with the technology. Like we had just saw in the morning, like people from HPC talking about the last technology, like from medicine, from AI, like all the fields in the last updates, which is the real world updates. So let's move to the vision and the core values. So DVP provide all the Computer Society chapter with opportunities to interact with leaders in the computer industry and academia. Here I want to do a small break. Usually, either we are working in academia and we have access to our professor, lecturer, and all of this, like more theory part, or we are in the industry working with companies a little bit disconnected from the academia. So IEEE here in this program give you access to people from diverse background, academia, industry, and even from states, like people from the states. So the main core values are, this is part of them, like the top of them, it's part of them. The excellence of service, we are ensuring the top quality, the relationship, you can even have one of them as a mentor later on, the innovation, the virtue, and the experience. Usually once applying to this program and getting a speaker, it's really like exceptional opportunity. It's not something you have done and then you forget. You will keep it always in mind because it's so special. Just having an example from the last CSSYP a few days ago, I met Professor Mike Henchy, which is like a person working in NASA on very high and up-to-date technology. And we were discussing, which is like, for me, it's not something that we can do every day. So it's really a very excellent service that we are offering. So the key features of this distinguished visitor program. So the first one, expert speaks. So you can have them as like speaker from different fields that are all related to the computer society. So it can be, I don't know, from cybersecurity, from HPC, from medical, like all related to computer society. The second thing, we have the cost support. It's not like we give you the person and we'll leave you. No, you have all support for travel and accommodation. It can be partially or fully supported. It depends. And third point, wide reach. So you have a huge number of speakers. You can just check out the website of DVP speakers, and you can have a huge amount and list of speakers where you can just check them, check their time, and ask and invite them. Let's have a quick look how to do that. Okay, I'm talking theoretically. Yes, we have this. It's a good opportunity. I'm going to present to you quickly how this distinguished visitor program works through the procedure. You will have it also on the website with more details. Sorry. So the first point is to identify the events. Let's see. Tomorrow with my computer chapter in university, we want to have like 2 days, let's say, I don't know, SYP or an event that we call wherever you want, technology way or something, and we want to have someone. It can be either online event or in-person event. For these two ways, you can have distinguished wisdom program. Let's see, for the online event, you can just choose the person online. You have a huge catalog. Contact them directly, confirm their availability, and it's done. In-person event, you choose them on ground, you discuss the event detail, you discuss the venue, and all what is related to the venue, transportation, and all of this, which are recovered by local expensive. And finally, you have, not finally, the fourth point, you have also the travel expenses. So this all, it can be handled. You just need to follow the process to submit all the details about that. It should always be a chapter who welcome this person, because it belongs to the computer society. So it's a computer society chapter who need to invite that. 5 things, the application is analyzed, and then you will have approval and notifications. And as all events, after the event, you need to report to say it was okay, the person was here, all was perfect. And then you will have the travel reimbursement. So this is like the steps. We can see it's quite easy. You have a lot of opportunity. It can be whether online, if you don't have really in-person event, or offline. So here I'm going to show the committee of the Computer Society Distinguished Wisdom Program. We can see like part of the main person. We can see the chair, Professor George. We can see immediately past chair, Professor Osam, chair of the selection, Professor Yazid, Mikhail as a member, Lionel as a member, and Eric as a manager. So we can see if you know them, you will see the diversity of the person, of their background. So it's like a community that it's involved, and like it works really on offering easy thing to the computer society attendees and to the computer society's communities. So let's go a little bit talking about not only DVP, but DVP awareness and customer advocacy, which is, let's say, a subcommittee. And it promotes outreach to make IEEE CS services program and resources, such as DVP, accessible while advocating for members' need and concern. So the main mission is to make members and the community strength with relationship, engage, trust focusing, and help them grow. Sorry for the picture not in the good positions. So the main roles and responsibility of the ACA, it's managing the DVP digital presence, collecting and analyzing customer feedback to improve engagement, which is a very important thing. Usually we go and we do an event and then all is fine. You should always have the feedback to keep always improving in your life. You should always get the negative point, work on them, try to improve. So this part of the role of the ACA. Business development, enhancing customer loyalty and developing solutions to meet members' needs. So it's like taking care of the members, what they need, following them, getting feedback of them. So all of these are the responsibility of the ACA committee. To have a little bit overview about this committee, we can see identify clearly here Dr. Islam with all his effort in this community. We have same a lot of person that I believe we all know. Professor George, here we can see me, we can see Qusay, we can see diversity, a lot of diversity, Amani, the previous speakers, and Tiaz, we can see diversity in all, and we can see also some subjects such as diversity and inclusion. We can have early speaker, career speaker, customer experience, like there's a lot of aspects we are considering in this committee. Let's see some real thing, what have been done with this program. So we have been realized a lot of program, which can be lecturer, online events, physically events, and others. So we had made a lot of collaborations, like with a lot of sections. When we say a lot of sections, it can be like 20 sections within the Region 8. Like targeting and talking about diverse topics such as technical, soft skills, healthcare, energy, education, HPC, and all, and more on. The event format can be like IEEE, it's always very flexible. You just do it however you want. Even in night technical, it's okay. So you have workshops, round tables where we have real interaction, face-to-face, panel discussion where there is an exchange with peoples. It can be also a hybrid sessions. Here we can see a few pictures about realized events. Here we can see also one of the last events we have realized, which is a web binary series of DVP program. We can see you can just scan the code to get more details about the activities. Sorry, here we can just see, for example, this one. It was Professor Wack, which is a lead of laboratory in Switzerland, particularly in Geneva, at the University of Geneva. She have provided with an excellent talk about artificial intelligence navigating our quality of life. So she was really talking about something concrete, real, in the lab where she's leading. We had also another talk from the Professor Ryan, where she talked about what are the ethics, what is the aspect of research ethic in the age of AI, moderator session. So here we can see that we are targeting a lot of very sensitive problem. For example, the ethics of AI ethics, which was mentioned in the morning by one of the speakers. We have also talked about energy by Mr. Pablo, the application of artificial intelligence in the energy sector, and all what it's about and all what it's important about. Another talk, it's from Professor Malak bin Salem, Fortifying Cybersecurity for the Next Computer Resolution. This is part of them. So it's a diverse event. All of them was most online events. And that was really an exceptional opportunity to all the student and young professionals from the Region 8. It's not only one section. It's like Europe, Africa, and Middle East. So just to learn a little bit, like summarizing, let's say, about the activities. So our activities are always collaboration across several regions. It's not only having the vision of only one section. It's like wider and large scale. It's really large scale speakers, large scale events. Partnering with multiple section, having diverse topics, covering several areas such as health, energy, education, and more. Engaging student and young professionals, and even more, because sometimes we have senior members, experts, not only student and young professionals. Everyone is welcome here. Fostering activity and participation through interactive events, promoting inclusion and growth, ensuring a diverse range of voice and perspectives in technology advancement. So all what a person that is related to computer society need. So how to get involved? You just need to read a little bit about what is the Computer Society DVP. You will scan this code, you will have the main page, you will have how to find the speaker, all the steps in details, how to invite a speaker, whether physically or online. You just need, in case you need anything, you can just contact the DVP committee, mainly Professor Islam, for assisting in any planning, event planning. Now it's a session of question and answer. Please don't hesitate to ask anything, whether it's related particularly to the DVP or others. And thank you a lot.
Thank you, Mrs. Amna. Thank you so much for your insightful session and for sharing your expertise on the Region 8 Extension Visitor Program and your guidance, especially those looking to contribute to the IEEE community in meaningful ways. Now I'd like to hear from our audience. If you have questions. Nice. Please don't hesitate to ask your questions.
If not, I'm going to ask you another question.
Before asking us, Dr. Emna, I just need
yeah.
to thank you, by the way, and recognize and truly appreciate all your effort and dedication and service for the computer society. You are providing role model for real volunteer who really have many creative ideas and dedication. So I truly appreciate your support and thank you.
Thank you. It's honestly, we need to thank you because it's having such member as you who offer opportunity to us young professionals and students. This is like the first door we need to grow and to be involved and to organize events and to have more, to upgrade on everything, whether soft skills or technical skills. So this kind of opportunity that you offer us, it's really very valuable for us. And thank you a lot, Dr. Islam, for all your effort too. If I may try to ask you another question, let me check if yeah. Can you please share, give me just one information, whether you already know or not, not this one. Yes.
Ms. Amna?
Yeah. Yes, can you?
I can ask you?
Yes,
may you elaborate more how speakers can join the DVP program and what the process is for becoming a speaker under your guidance?
Okay. I believe all the information are on the website. I can give you some main information that I have. They first need to be an IEEE Computer Society member. They need to be to the level that we accept, like in the community. Most of them are really very experts. You can just go to the website of the Computer Society using the QR code, the DVP program, and check the steps. You just need to do an application, a form application. Then it's going to be studied. It's several cycles. I believe Professor Islam can here give more details. There is cycles where people should apply, and then they will analyze and study their applications, and then they will give them feedbacks. So it's a selective process to keep the quality of the DVP speakers. Maybe Dr. Islam here, if you can add something.
Yes, I do agree with you. It's very prestigious, and we encourage all our experts to apply to nominate themselves or to be nominated. But the good news is that the Computer Society will introduce a new program, maybe for the young or early career. So it will be entitled Early Career Speaker Program. So it will provide also opportunity for the young people to familiarize themselves with this kind of activities and be prepared for the future. So probably you can if you think that you are not fitting all the requirements of the to be distinguished visitor program, so please just search for the early career speaker for the computers.
Okay, nice to know. I didn't knew about it, honestly. So there is an
It's a
early
new
career
initiative,
speaker.
so new initiative, so it will be announced soon.
Oh, so we are a VIP audience here.
It's
Guys, we are having like
exclusive. Yeah.
thank you a lot, Dr. Islam.
Thank you.
So we can see here that we have some people that have never heard about DVP. By the way, this is a program that it's quite famous in IEEE. Here we have it in Computer Society, but I believe it's also in several chapters. And it's really a very good opportunity. Imagine you're just organizing an event. You will have, you can have a speaker, you can have it fully funded, all. And you can have a big amount of support, like partially funded. So it's like a free opportunity. It's like just pushing you to get involved and pushing you to be following the last up to date of the community, accessing to the best speakers you can have worldwide. I hope this session was insightful for you, for those who didn't know about it, and I hope those who already knew about it, maybe having some new informations. And nice to meet you all, and hope to see you in IEEE online or on-site events. Thank you a lot.
Thank you, Dr. Emma, for your
Mr. Emma.
Thank you, Amani.
Thank you, Mr. Islam.
So we have maybe just 3 or 4 minutes for the next session. So I also utilize the opportunity and maybe just we play the video from Giorgio Proler from the opening session today.
Good morning, good afternoon, good evening, and good night. A greeting adapted from the movie The Truman Show, starring Jim Carrey. And it works here since to each of you there is some relevance in that greeting. And hello, Kuala Lumpur, Sapporo, San Francisco, Wilkes-Barre, Thule, Dublin, Bruges, Cairo, and Mumbai. I'm George Proler, Chair of the Computer Society Distinguished Visitor Program, and it is my honor and privilege to welcome you to this, our second annual IEEE CS EXA DVP event, or as we call it, the 24-hour event. Second annual has a nice sound to it. At the beginning of last year, hosting such an event was just a thought. To extend an earlier project to cover an entire day, 24 hours of presentations, reaching and including our diverse membership. And quite frankly, we were unsure if we could put it together. But Professor Hassam Fahmy, my predecessor, and Professor Islam Halim, chair of the Awareness and Customer Advocacy Committee, and his team rose to the challenge. And we did it. And it was successful. The first annual. And now, well, Professor Islam and his team have outdone themselves. Look at the agenda for the next 24 hours. Artificial intelligence, AI security and privacy, and research ethics in the area of AI. Quantum computing and the quantum world, smart and high performance computing, and the list goes on. And we are already working on the planning for the third annual event for next year, taking another step and upping the challenge for Professor Islam and his team, as we are looking to make this a hybrid event with on-ground activities concurrent and shared with the online participants and attendees. This event spans each of IEEE's 10 regions and the world's time zones, hence my adapted greeting, since each of you and the DVs, the presenters, the moderators, you all hail from different and diverse regions. And for some of you, it's 10 a.m., 2 p.m., 8 p.m., and 2 a.m., and all the hours in between. So it is morning, afternoon, evening, and night. Truly an effort of inclusion of our diverse membership base. Today is International Volunteers Day, which is fitting since it has taken, and before this day is through, it will take the efforts of more than 50 Computer Society volunteers coming together from the Geographic Activities Committee, Students and Young Professional Activities Committee, and the Distinguished Visitor Program to bring this event to you. Over the next 24 hours, you will have the opportunity to attend more than 20 technical presentations on topics I've already mentioned, along with informational talks about the Computer Society and its regions, activities, and programs. Each presentation will be introduced by an event moderator who are members of various student chapters, and through participation in this event are gaining experience and opportunity. And then there is the audience. That's you. Many of you are members and affiliates of the Computer Society who volunteer your efforts to make local programs a reality. And all are here allowing us to bring this event to you. So thank you for your time. And now, before I wear out my welcome, I'd like to pass the baton to Professor Irinori Washizaki, the President-elect of the Computer Society. Thank you.
Thank you so much for being here, and it's my pleasure to move to the next session. I'll first introduce my prestigious moderator, and I own him a lot, Professor Ahmed Hassan Youssef, President of Sweden University of Technology. Professor Ahmed is currently the President of the Sweden University of Technology since 2024. He was the Vice President of Egypt University of Informatics for Academic Affairs after serving in Nile University as the Dean of the School of Communication, Engineering and Information Technology, known later as the School of Information Technology and Computer Science. He is a professor in computer engineering in the Faculty of Engineering in Shams University, Cairo, Egypt since 2017. He was the chair of IEEE Egypt section from 2020-2023. He was an awardee of the token appreciation for the exemplary service for hosting IEEE Region 8 meeting, Cairo, October 2022. He is also a member in Region 8 Subcommittee of Section Vitality and Development 2023 and served as member of Region 8 ad hoc. So, Professor Ahmed Hassan, many titles, and you are our hero. So I will leave the floor for you. Thank you, Francesco, to be with us. Thank you so much.
Thank you, Dr. Islam, and I would like to thank Francesco for being our next speaker. Francesco. It seems that my takes a lot of the bandwidth, so I will switch to my photo instead, and I will start from the beginning. Professor Francesco Flamini is a professor at the University of Applied Science and Arts of the Southern Switzerland Dalimoli Institute for Artificial Intelligence. He was graduated in 2003 and got a research doctorate PhD in 2006 in computer engineering from the University of Naples Federico, Italy. He worked for 15 years in private and public companies, including Ansaldo STS, now Hitachi Rail, and the IPZS, Italian Statement and the Polygraphic Institute. He worked on large international projects addressing intelligent transportation, critical infrastructure protection, and cyber security. As a technical leader and unit head. Since 2020, he has been a full professor of computer science with a focus on cyber physical system at Mälardalen University, Sweden. I hope I pronounced it correctly. And he was also the technical manager of the Rails EU-funded research project about artificial intelligence for smart railways. He is currently a professor of trustworthy autonomous systems at the University of Applied Sciences and Southern Switzerland, where he is affiliated to Delhi Molly Institute for Artificial Intelligence, and he is leading the Trustworthy Autonomous Systems Research Group. Previously, he has been a senior lecturer and the chair of the Cyber Physical System Environment at Linköping University in Sweden. He is a senior member of the IEEE and member at large of the IEEE SMC Board of Governors. He has co-authored more than 150 technical publications and has served as a chair, invited speaker, steering program committee member, and editor for several international conferences and journals. Without any further delay, I invite our distinguished speaker to start his important talk.
Okay, thank you very much for this kind introduction, Ahmed, and thank you, Islam, as well. I'm going to share my presentation slide. Okay, I guess that you now see my title slide. In case there are any issues, please feel free to stop me at any time. Okay, so you know, thank you. So you know now the most important things about my career. One last thing that I would like to mention is that I am now full professor of computer science at the University of Florence, Italy. I kept my previous affiliations, but this is the novelty for this year. So I'm also affiliated to the University of Florence. And I'm going to talk to you about digital twins for trustworthy autonomy, which is something that we started a few years ago and we are developing. And it's basically putting together these two important concepts, the concept of digital twins. This raised quite a big success for predictive maintenance in the industry 4.0, and the concept of trustworthy autonomy, which is essential in all cases of self-driving vehicles, which I would say it's the most important application, but not only, because you have autonomy in all sectors of cyber physical systems nowadays, as we will see in this presentation. So let's start from the beginning and okay, so sorry, it went too much. Okay, so the beginning is the concept of smart city. I mean, these concepts of digital twins and trustworthy autonomy, as I said, they apply to all sectors of modern society. So if we take as a reference this paradigm of smart city, in smart cities you have everything that has been transformed or is being transformed from its traditional version to the new digital version. So everything is based on computers, basically on data. And this data is collected from several sources, including the Internet of Things, so connected sensors that produce a lot of data. And this applies also to industry. So smart manufacturing is considered as an element of our smart society. And the amount of connected IoT devices is increasing exponentially. So you see in this slide a prediction. This needs to be updated, but the trend is as it is. I mean, we have an exponential growth of devices producing huge amount of data. This data needs to be analyzed, and this has a cost. So basically what we want to achieve is to get value from data. Otherwise, we will only have costs from installing those sensors, connecting those sensors, storing the data, if we are not able to use this data to actually improve the performance, reliability, and security of systems that are increasingly vital for our lives. So we have quite a lot of so-called grand challenges to tackle. These cyber-physical systems that are around us, based on physical components and cyber components, are becoming ubiquitous and pervasive. So they are everywhere and they are pervading our everyday lives. They are increasingly smart, intelligent, and autonomous. So the use of AI and machine learning is now a standard part of those systems. And we need to have them reliable, safe, and secure, as I said, because otherwise we could not trust those systems. However, in order to ensure that those systems, cyber-physical systems, fulfill those requirements, we need to manage their complexity, heterogeneity, and uncertainties, which is extremely challenging. But let's start from the reference taxonomy. First of all, we should introduce the concept of resilience. Resilience has been introduced quite a lot of time ago. Now, I think it's more than 20 years. And when it was introduced, there was not such development of AI as we have today. But this concept somehow pioneered the challenges that we have today, because it put together the concept of dependability, so having systems that are dependable, that you can trust, and it puts together the concept of dependability with the concept of changes. Now, changes are always important, but nowadays they are even more important because we use systems in environments that are continuously changing and evolving, and the systems themselves are changing. So you have, for instance, over-the-air updates even on self-driving cars. So even the system itself is undergoing changes through upgrades. Therefore, you need a concept that is stronger than the concept of dependability. You need the concept of resilience, which includes the concept of dependability. So for instance, if you see this class diagram in this slide, you have the original concept of dependability that puts together attributes such as maintainability, reliability, safety, availability, integrity, and confidentiality, threats, faults, errors, and failures, and means fault prevention, fault tolerance, fault removal, and fault forecasting. This concept of dependability, as I said, is strengthened with the concept of resilience that also includes all the changes in terms of technologies, in terms of all the other things that can change in your system and in the environment that can have an impact on its dependability. So in this diagram, you have the full picture of the concept of resilience. So we want to make cyber-physical systems that are resilient. Let's start from the concept of risk. That is the basic concept when you address those properties. Well, risk can be defined as a combination of three main factors that we can define as P, V, and D. First factor, P, is the probability of threats that can be expressed as a probability, so a number between 0 and 1, or it can be expressed as a frequency, so how much threat of that particular type, you can expect in the unit of time, in 1 hour, 1 year, it doesn't matter the unit that you're using, but in the end, you have a frequency of an expected frequency of threat. The second factor is the vulnerability of the system against that threat, which is a conditional probability. So it's a number between 0 and 1, and measures what is the probability that the threat is successful given that it's stroke. So even if you have a threat, you could have protection mechanisms that are effective against that threat, but they will never be 100% effective. So you will have a number here between 0 and 1. As I said, it's a conditional probability. Last factor is the damage, D, which measures the expected consequences of the threat. And it can be measured in several ways, but to make things simple, we can use, for instance, the dollars, euros, because every damage can be measured by the kind of effort and financial investment that you will need to restore the system to its initial operating state. So this kind of general concept is rather abstract, and then it is instantiated into specific metrics depending on what you want to consider as a risk. For instance, if the risk is the reliability risk, then you have some metrics such as the mean time between failure, or if it is a safety risk, then you have other metrics such as the mean time between hazardous failures or the total hazard rate, which measures the frequency of hazards. Now, the challenge is how you measure those risks, because you want to minimize the risks under a certain threshold. But in order to do that, you need some quantitative or formal means to do that. Engineers use models in order to represent the reality at a certain level of abstraction and make analysis on the reality, considering the most important things that needs to be taken into account. This kind of discipline, more in general, is named model-based engineering, so MBA, which is the most external part of this diagram. Then you can have some more specific approach, which is known as model-driven engineering, in which you use some subset of modeling languages, such as the unified modeling language. And you use also meta modeling in order to define domain-specific modeling languages to make modeling more customized on the specific systems that you're considering on the specific domain, and to make it more user-friendly for the end users. And then you have more specific approaches, even more specific approaches, that is model-driven design and model-driven architecture, which is the final stage in which you want to use to make a simulation of the real system. If you need to do that, for instance, if you want to use software engineering to develop a digital twin, as we will see in this presentation, then you need to go through all the steps of model-based engineering. Then what you can have, it's not mandatory to have such kind of modeling, but if you put together all the tools that you have in modern modeling paradigms, then you can use the so-called multi-paradigm modeling. Multi-paradigm modeling basically puts together the concepts of abstraction, meta modeling, and multi-formalist modeling, which means that depending on the properties and the aspects of the system that you want to model, you will choose a different modeling formalism, a different levels of abstraction. And in the end, you put together all these models that become sub-models into a holistic model of the system. In this slide, you have, for instance, an example in the railway domain, in which you have onboard systems, trackside systems, and line-side systems. All these systems are connected in reality, and also the models are connected with each other. And within the submodels, you can use for trees, continuous time Markov chains, Bayesian networks, battery nets, and so on and so forth. So the kind of formats that is more suitable to model that aspect and then property that you need to model. When you use an approach like this, even for complex systems, you can get evidence of safety, evidence of fulfilling international standards, and you can get your system approved for operation in reality. And this is what happens for all critical systems, transport systems, and infrastructure. So it's quite difficult and challenging, but in the end, you can get to results that the system is approved. You demonstrate, for instance, that the system is safe enough to be operated in real world. However, the situation can be worse than that. Why? What we have today, even if it is still ongoing, is the transition from traditional systems to intelligent systems. So this transition is a reality in many sectors, but still is a big challenge in critical sectors. So for instance, for self-driving cars, self-driving trains, self-driving airplanes, so in the transportation domain, which is one of the most important critical domains, but even in other sectors of smart cities in which you have safety as the main concern, in smart factories, for instance, when you have cobots, you need to use novel approaches, something that is not within the things that we have already addressed so far. For instance, in self-driving cars that are probably the most important example of autonomous systems, you have the so-called ADAS levels, driving assistance, that can be up to level 5, in which you have fully autonomous vehicles. This means that you don't need any driver, you don't need any steering wheel, and you need to trust 100% the system that drives the car. But this applies to, as I said, to a large number of domains, not only self-driving cars. So using traditional approaches, even if they are very powerful, such as multi-parameter modeling, it is extremely challenging to prove that self-driving cars are safe. Why? Because they are based on machine learning, deep learning, and those models are considered as opaque, black box, not transparent. So they are not predictable, and this is the main challenge that many researchers are addressing today. Furthermore, you have this problem of adversarial attacks. So you have new threats. So not only the traditional cybersecurity threats that you need to consider, but new attacks that can make the intelligent system believe things that are different from the reality. For instance, this overlap of some noise to real images make artificial vision system think that there is a different animal. With our eyes as humans, we don't see any differences. So for us, the animal remains a panda, clearly. But for machines, it becomes a gibbon, a different animal that is quite different from a panda. So these are these new properties of neural networks of deep learning that can be applied to transportation systems, for instance, to change the shape of a signal. So as humans, we continue to see a stop signal, but the artificial vision system on the cars can think that is a different signal, for instance, no speed limit. And this, of course, can cause accidents. So basically what we need is the concept of trustworthy artificial intelligence that has been pioneered, I would say, by an expert group in Europe. They have started to formalize the concept of trustworthy AI, putting together the three main aspects that are robustness, so technical robustness, how the system remains accurate against changes and perturbations, but also other two aspects are very important. So the legal framework, so the in case of accidents, who is liable, for instance, and the ethical implications of technology. So human-centered AI, which is another way to tell these kind of things, has become of paramount importance nowadays, not only Europe, but in all continents. But this, especially this reference that I put in on this slide was this kind of taxonomy was first delivered by this high-level expert group of the European community. So you have these three main aspects that can be specialized into sub-aspects. For instance, within robustness, you have many aspects that we have already seen in the context of resilience. So reliability, security, safety, accuracy, usability, interpretability. In terms of legal requirements, you have accountability, privacy, explainability, and then you have, in terms of ethical requirements, fairness, respect for freedom, for instance, and transparency. And these requirements, properties that you have in the bottom, interpretability, explainability, and transparency, it's quite intuitive that they are very much related to each other, even though they can be associated to different aspects, to the technical robustness, interpretability, to the legal certification, the explainability, and then for the ethical aspects, transparency, because the system must be transparent to end users. But these three concepts are very much related to each other. In particular, this concept of explainable artificial intelligence, to have an artificial intelligence that not only is very powerful, as we know, it's very useful today and it's very powerful, but this is not enough. It must also be explainable in order to be used in critical domains. Otherwise, you can use AI in domains that are not critical. You can use it for video games or for such kind of home entertainment. But I would say that nowadays, most of the applications of the AI, even if they are not super critical, I mean, if they fail, maybe no one would die, but still they can have an impact on the privacy of individuals. So still you have a criticality in terms of privacy. So this was first introduced by this DARPA research group in United States, but now there is a quite large research community that is addressing explainable AI in its several forms and implications, because this explainable AI you can address from several perspectives. There is no single way to address this challenge. But the important thing is that people have started to actively doing research on XI in the last few years. So you have a huge increase in the number of publications by the scientific community addressing explainable AI. Now, one way that we can use to address explainable AI is to frame artificial intelligence into something that is to some extent explainable. For instance, the use of the so-called MAPK autonomic controller put AI in a sort of controlled environment. So you have these main stages. MAPK stands for monitor, analyze, plan, and execute over shared knowledge. So monitor is getting data from the system, so understanding what is happening in the real system. Then you go through the step of analyze this data. After analyzing the data, you need to make a plan, and then you implement the plan. So overall, it's a very simple approach. It's a sort of closed loop control system, but it is more an architectural view from the software engineering perspective. So this starts to be something that you can put on top of an existing system. So you don't change the system to make it intelligent at all costs, but you can put this autonomic controller on top of existing systems. We started to investigate the opportunity and the potential of these technologies in 2018. And as you can see from this graph from Gartner, there was a general interest from research community and industry in these technologies such as digital twins and self-healing systems and explainable AI. So these were among the research priorities, even in industry. And now after a few years, we have developed this research, and I will show you which are the results that we have achieved so far. Let's start from a definition of digital twins. Most of us now are quite familiar with the concept of digital twin, but nevertheless, I will say a few words in order to introduce this concept that has been used since many years ago by General Electric, NASA. I mean, all these big organizations, they have started using these digital models of the real systems at runtime, because this is the novelty. Normally you use models at design time, but then you stop using the models and you use the real system, and you use other kind of diagnostic approaches on the real systems. But if you keep the models alive during the system operational phase, and you make these models very much detailed, sometimes super detailed, you can have a digital replica of the real system in which you can make some accelerated simulations and what-if analysis, apply predictive analytics in order to anticipate failures, disruptions by early recognition of faults and other anomalies. So this is the general concept of a digital twin, which is not a new thing in industry, because as I said, it has been developed several decades ago. But digital twins have evolved in the last few years. And in this diagram, still a class diagram, you can see in the center of the diagram, you have the concept of cyber-physical systems, which, as I said, is a combination of cyber part and the physical part. In turn, the physical part is made by sensors and actuators, while the cyber part is distributed over the edge computing, fog computing, and cloud computing levels, as we will see better in one of the next slides. Now, the Internet of Things IoT devices are enablers for cyber-physical systems, because those are the devices that actually the technologies that actually you can use to connect sensors and the actuators in order to provide data. And you can keep the digital twin, because in turn, cyber-physical systems as a paradigm enables the concept of digital twin. Data in the digital twin must be updated. Otherwise, you will have a twin which is not a twin of the real system. So this data coming from the real system is collected by sensors and go through the IoT infrastructure in order to update the parameters on the digital twin. And then you have further specialization of digital twin. For instance, digital twins enriched with AI and machine learning that are sometimes defined as cognitive digital twins. They are enabled by AI and machine learning because without AI and machine learning, you could not have these cognitive digital twins. And in turn, AI and machine learning are enablers for autonomous cyber-physical systems. Cyber-physical systems are not necessarily autonomous. If you add AI and machine learning, you can make them autonomous, self-adaptive, and having these learning capabilities that they normally they don't have. Okay, let's see through these behavioral diagrams how the concept can be used. The concept of digital twins as runtime predictive models can be used in order to detect faults and anomalies in cyber physical systems. So on the left part of this slide, you see a flowchart, very simple flowchart that starts by building a reference digital twin model, instantiating the digital twin with initial configuration data, and then the digital twin is used at runtime to estimate the system dependability. If the dependability target is achieved, then you can execute the system plan and configuration and continuously updating the digital twin with field data, and continue to do that as long as you don't have any faults and anomalies. Otherwise, you need to compute plans or reconfiguration options because the dependability target is not achieved. If there are acceptable options, then you need to reconfigure your system and update the digital twin with the new planner and configuration. Otherwise, if there are no acceptable options, no options that are safe enough, for instance, then you need to switch over to manual control or fallback procedure or activate some kind of redundancy. So the same thing you can represent with an abstract state chart in which you move from a nominal state S1 to the graded states in which you have minor faults, possibly multiple faults and anomalies until you reach a compromised state S4 in which you have critical faults, and as before you need to, in this case, if you cannot recover from critical faults, you need to shut down or switch over. So these are two different abstract views of how you can use digital twins as runtime predictive models. But let's see more practically how you can implement a system like that. So in this slide, you have a general architecture of digital twins embedded within the concept of autonomic computing, or vice versa, autonomic computing used to shape our view of digital twins. So at the edge level, you have these digital twins that are very close to the real machines, and you can get data more quickly and have a feedback loop which is more timely. Also, data is not shared with on the internet, for instance, so it's more confidential, and you have more autonomy because if you don't have connection to the internet, the system can continue working. So this is what happens at the edge computing level, the bottom level. And as you move up to the fog computing level and the cloud computing level, when you have, for instance, remote data centers, you have, of course, much more computing power. So you have more knowledge that is collected from multiple instantiations of your system all around the world, potentially. And it's an approach that is more cost effective because running or renting part of data center is more effective than using thousands of digital twins distributed at the edge level. So there are a lot of advantages, but there are also disadvantages. So you have more latency and less confidentiality. So you need to find in the end a balance between what you can do at the edge and what you can do or should do at the cloud level. So this is the overall picture. But let's make a real-world example in order to demonstrate how our approach can be used in practical applications. So one of the simplest applications that we have addressed, it is not the only one that we have addressed, because in the last few years we have addressed additional ones. But this one is very simple to understand. It's a system for vehicle detection that can be used, for instance, in mixed traffic intersections in which you have cars and tramways, for instance. And it is important in these situations to detect if there is a car at the intersection, because in that case you need to act on the signaling system in order to shape the signal accordingly. So to put, for instance, a stop signal for the tram. But detecting a vehicle is also useful, for instance, at railway level crossing, if there is a vehicle stuck between the barriers, for instance. So the application is simple but important, and we can use a lot of different sensors in order to detect vehicles. And on the right part of this slide, you can see that, for instance, you can have infrared, microwave, ultrasonic video image processing, acoustic sensors, inductive loop, magnetic loop sensors, pneumatic road tube. So this is a very important opportunity, because I can anticipate that the approach that we believe and we demonstrated to be successful in practice is to use multiple technologies, because there is no technology that works well in all situations, and it is trustworthy in all situations. To demonstrate that, we have instantiated the models that I have shown before in the specific case. Now, I will not go through all the steps because it will be too boring for the listeners. But just to let you know that those general models have been instantiated into the specific situation in which you need to evaluate the probability of hazardous failure, so that you don't detect a vehicle when the vehicle is there. And the combination of sensors has been made using a K out of M approach, so majority voting over multiple redundant and diverse detectors. All this has been framed into the paradigm that I've introduced before. So this paradigm of MAPK. So you have the event sensing from the physical world, and then you go through the monitor, analyze, plan, and execute. And execution in this case means reconfiguration of the system if needed, in order to have a new configuration that fulfills the safety requirements. The important thing is that the shared knowledge that you have in the middle, in this case, has been represented by dynamic Bayesian networks, which is a formalism that is used for AI, probabilistic approach, causal approaches to AI, and it is by design supporting explainable AI differently from other kind of information fusion approaches based on neural networks. In this case, everything is transparent. So you don't have a black box, but you have a transparent box. The results that we have achieved in the end of this experimentation show that you can reconfigure the system in case of failures from some kind of detectors in order to reach predefined safety integrity levels. And depending on the fact that the safety is enough or not, you can continue using your system, maybe with a lower performance or with some partially manual operation or partial supervision. But everything is fully predictable. So if you start from 4 out of 5 involving some technologies, then you can move to 4 out of 4, 3 out of 4 using other technologies. And all these transitions are made in a way that at runtime, you know the safety integrity level that you have reached after this reconfiguration. One important thing is that not necessarily detectors fail completely. So there is not necessarily hardware fault, but it could be that in some specific environmental conditions, some sensors are not performing well, because artificial vision, for instance, is not performing well when you have heavy rain, seeing that it's too dark, or fog. So in those cases, it's temporary reduction of the reputation of that detector that can be raised again at the nominal level when the environmental conditions change to good weather, for instance. One more thing about this approach is that not only you can make this reputation-based reconfiguration of the sensing subsystem, as we have seen before, but you can use models of the real system at runtime within the paradigm of digital twins also to detect functional anomalies. And this you can do, for instance, by analyzing event logs of the system that is operating. This approach is known as process mining. It's based on three sub-disciplines. One is process discovery, the other one is conformance checking, and the last one is process enhancement. So for instance, for conformance checking, you have a model, functional model, behavioral model of the system. You detect what is happening on the real system through the analysis of log files. So through log file analytics, you compare the two processes, and if there are deviations from the nominal behavior, then you detect an anomaly, classify the anomaly, and depending on the cases, you can reconfigure the system or stop system operation to put it in a safe mode. For instance, with a safe shutdown that you can do in some kind of systems, such as railway systems, which you stop, for instance, the train or all the trains on the track. In order to implement digital twins, you need a reference architecture. So we did some research also in terms of designing a reference architecture to implement digital twins, fulfilling the requirements that we have seen before. And you see, for instance, in this slide, multi-layer implementation of the managing subsystem, implementing a digital twin through the use of several layers, so physical space layer, data layer, virtual space layer, and service layer. And with these circles with P, A, E, M, and K, we indicate that those boxes, those parts of the architecture, are functional to the implementation of the corresponding phases of the MAPE-K loop. So, for instance, the data elaboration is part of the monitoring part. Data reasoning is part of the analyze phase. And data persistence is part of the knowledge, because you need to keep data stored in the shared knowledge. One of the last things that I would like to present today is the use of digital twins in the loop for mixed reality testing of machine learning systems. This we did in a research project about intelligent railways. As you can see from this slide, there is clearly a reference to the railway domain with the track and the trains. And this was very important for us since we needed to test an approach for obstacle detection based on artificial vision. So in order to do that, you can implement the whole system in a virtual environment. As you see here in the bottom right square, you have a virtual train in a virtual environment, so everything is simulated. But then you have a real train in a virtual environment, a virtual train in a real environment, and then the last kind of testing that you do is to use the real train in the real environment, but it's something that you do in the end when you have extensively tested your system in order to demonstrate that it's safe for the intended use, that is to safely detect obstacles on the track. Okay, that was all for my presentation. Thank you very much for your kind attention. I would be glad to answer any questions.
Thank you, Francesco, for the very interesting presentation. And let us get any question from the audience. Any comment, any question? So, because we don't have any question from the audience, I would like to ask you, how can we, in Egypt, for example, or in any country from Africa, how can we use the deliverables of such an interesting project? I think you mentioned a lot of development, and I think for anyone, in order to apply this, he will take a lot of time that you already, as a project with many, many members, have achieved over years. So how can we apply this? How can we connect to the owner of this intellectual property? What can you advise us about this?
Okay, thank you for this question. This question was actually interesting, is actually interesting, and I was involved for many years, as you mentioned in your introduction, in certification of industrial systems. Most of my career has been in industry, so I know the challenges of using these approaches in the real world in industry, and of course it would be an overhead to build a digital twin of the real system if you don't think about some approaches to reuse what you have already done. So for me, the challenge here is to keep alive the models that you have already used to make verification and validation of your system. So in industrial practice, you need quite a lot of modeling that is needed to support the certification of your systems. Otherwise, you could not provide enough evidence that your system is safe, for instance. But this is also valid for the security, for the reliability, all the other important attributes of critical systems. So normally, these models you build, you evaluate, and then you forget until you need to make a variation and another installation of your system. So you start again. And when the system is operational, those models are not used anymore. And it's a pity because actually by reusing those models and by keeping those models alive at runtime, you can make analysis of what's happening in the real system, which is something that in some domains, as I said, people do for predictive maintenance, but for other domains, it is not considered important, or it has not been considered important for many years because you didn't have these changes. So for instance, in the railway domain, it is a very conservative domain. For many years, nothing changed. So you don't expect any changes in the environment. You make some assumptions that nothing will change. So you don't have to make a monitoring of your system if nothing changes. But with modern technologies, the use of machine learning, the use of self-adaptation, frequent changes in the systems and in the environment. So the new reality that we have today and we will have, especially in the future, we need to start thinking about approaches in which those models you keep alive and you can use them in a digital twin in order to detect anomalies. So, as I said, you have normal operation of your system, which follows some models that you needed to develop your system. For instance, you used UML activity diagrams, sequence diagrams, and you translated those models into Petri nets. to represent your functional process. You can use them to monitor what's happening in the reality and anticipating some deviations from the nominal operation before it becomes an accident. Because this is unfortunately what already happened in the past, and it's likely to happen again in the future, that you reduce your software in different contexts because you don't want to develop a new train control system from scratch, new railway control system from scratch, and this is also valid in all the other domains. Space shuttles, for instance, you perhaps know what happened with the Ariane 5 satellite launcher, that they used the previous version of the software on a different hardware, and that caused the accident. Now, in an ideal world, everything is perfect, so we don't need to make any real-time monitoring. But in practice, the world is not perfect, so this software is reused, and it's not fully validated with formal methods. So you do a lot of testing, but still there is a little risk that you didn't test some edge cases. And when you have those edge cases, you have two options. Either you have an accident, or you have a monitoring system like this that detects the anomaly and tell someone or the system itself that it needs to stop, or it needs to slow down, or it needs to switch to backup operating mode. But the important thing is the fault or anomaly is detected and notified to some entity. Otherwise, the accident, even if it is very rare condition, it will be impossible to avoid.
Thank you, Francesco, for the answer. We have received an the idols often large the best practice for improving data privacy while maintaining the accuracy and efficiency of AI systems. This is from
I'd like to thank Professor Ahmed, Professor Francesco for the great presentation and moderation. Thank you so much.
Thank you.
We have thank you. We have a few minutes so we can also share some morning welcome speech. So I'd like to share this one with you.
Welcome, everybody. I am Professor Hossam Fahmy, Professor of Computer Engineering, Faculty of Engineering and Shams University, Cairo, Egypt. I am the immediate past chair of the IEEE Distinguished Visitors Program. Good morning, or good afternoon, or good evening. It is 3 a.m. Cairo time. Welcome to this year's IEEE Global event. It is both an honor and a privilege to participate in the opening ceremony as we embark on this remarkable journey of innovation and collaboration. We gather not just to celebrate the advancement in technology, but to recognize the collective spirit of curiosity, ingenuity, and perseverance that unite us as a global community. IEEE has always been at the forefront of shaping the technology landscape, and this event exemplifies our shared commitment to advancing technology for humanity. Over the next 24 hours, we will witness remarkable talks and engage in thought-provoking discussions. This year's theme, International Volunteers Day, serves as a powerful reminder of our responsibility as innovators and leaders. Whether we are addressing pressing challenges such as sustainability, connectivity, or ethical AI, we stand united in our mission to create a future that benefits all. I want to take a moment to express my gratitude to the organizers, volunteers, and sponsors who have worked tirelessly to make this event possible. Your dedication and passion are the foundation upon which this event stands. Our participants, researchers, industry leaders, and students, you are the heartbeat of this gathering. Your ideas and contributions make this event truly global and impactful. Islam Sarwat, go ahead as usual. George Froller, David Bandurant are usually at the core of success. Hironori Washizaki, all the best in your coming moves. As we open this global event, let us embrace the opportunity to learn, innovate, and inspire one another. Let the exchange of knowledge and ideas begin just after this opening. Thank you, and may this global event be a resounding success.
Well, I think we are waiting for to start the next session, which should be moderated by Dr. Zorika and presented by Dr. Adil, but I couldn't see Dr. Adil there. Hi, Zor. Glad to see you.
Hello, glad to see you too. I hope you hear me.
Yes, I can hear you very well.
That is great. Then
I'm
I
afraid
just
that
will.
Adil is not there. I don't know.
Does he have the link for the meeting?
Yes, I will send the reminder to him, maybe some emergency. I'll double check him. Can wait for him. It seems that Dr. Adil has some issues to join us online now, but he told me that I can use his record, so we can start from here. So just introduce him, and I'll try to start his record from my side.
Okay, then let's officially start with this session. It is my great honor today to be able to moderate this session and to introduce Professor Adel El-Maghrabi. Professor Adel is the University of Louisville Director of Research and Innovation for the Digital Transformation Center. And he is also the Director of Industrial Research and Innovation and Vinaya Professor of Computer Science and Engineering at the Speed School of Engineering, University of Louisville. He received his Master of Science and his PhD degrees from the University of Wisconsin-Madison in the United States, and he received his Bachelor of Science degree from Alexandria University in Egypt. He has also held appointments at the Software Engineering Institute and Carnegie Mellon University, the American University in Cairo, and as a Fulbright scholar at Qatar University. He advised over 60 master's graduates and 36 doctoral graduates. His research and consulting spans the areas of intelligent multimedia systems, artificial intelligence, high-performance computing, cybersecurity, visualizations, and simulation. His research applications include smart cities, data analytics, medical imaging, bioinformatics, and computer-aided diagnostics. He is a well-published author, a public speaker, a member of editorial boards, and a technical reviewer. He was recognized for his achievements by several professional organizations, including a Gold Accord Charter membership by the IEEE Computer Society at the 50th anniversary celebration. Professor El-Maghrabi continued collaborations, mentoring, and scientific contributions have resulted in research funding, international collaborations, and published articles in many prestigious journals, such as IEEE TMI, Medical Physics, Journal of Neuroscience Methods, Protein Engineering. He is a life senior member of IEEE, the former president, and a lifetime member of the Association of Egyptian American Scholars. Today, he's going to talk about artificial intelligence and digital transformation and the role of industry-driven partnerships. So let's hear his lecture.
Talk about AI and digital transformation. I was going to give a brief introduction about myself, so you already did it. I did my undergraduate in Alexandria, graduate diplomas in Cairo and the Institute for National Planning, then graduate work in Wisconsin. In Louisville, I have 3 bosses, that's what it is. One at my department, and one at the School of Engineering, and one at the university at large. So that's why these too many titles. So I have 3 different bosses. Okay, let's go to the topic of why I chose this topic of AI and digital transformation, because I've been working a lot in AI, and I worked a lot with industry, and my belief is the word digital transformation is what we have been wanting to do for a long time, and using what we learned and what we teach, but now the environment is ripe for it. I will use this, I think now archaic, the word Industry 4.0, because I believe this word never picked up in some countries, but just to tell you, that's what industry really wants. They want cybersecurity, Internet of Things, augmented reality, autonomous systems, system integration, simulation, big data, and you will see different versions of this. But most industry cannot bring together all these things internally. So that's why the industry academia partnership becomes very valuable to help them move to the next step wherever they are. Obviously, different industry are at different stages of this. So let's be honest, we will have to approach each industry based on its need and its stage of where it is right now. This is a model that was published somewhere about levels of engagements between industry and academia. And it's very interesting to see because there is from awareness to being strategic partners, there are many stages of what we will call from traditional engagement to holistic engagement. Many people stop short of benefiting. And I will tell you, I work in academia, I partnered in small businesses, but I never worked 100% in industry. And I would look at it that the fault is on both sides. First of all, industry has no patience. They want to get everything immediately, although many times they cannot even if they put all their money in it. And academia has bureaucratic aspects, and we work on a semester mentality or an academic year mentality, and that doesn't always fit with academia, with industry. So these levels of engagement, if we are aware of trying to push them further, it helps us understand and move further faster. Okay. Why digital transformation? Digital transformation obviously is an area now that people are talking about it. And we look at it that there is a big market that's projected, depends on which projection, 1.8 billion, whatever. But it really depends on, from my perspective, three things: data, the use of AI, appropriate use of AI, let's be very, and talent, and a lot of little other areas that are this. With the data explosion, AI can be, and it's becoming the tool of choice to transform them into knowledge and actionable investments. So if we have the data and we have the money and we want to transform, that's really where AI can help us very much. I'll go through some definitions and just some thoughts here about how this is. And what really I want to focus in this slide and is that we want to leverage the technology, we want to leverage the data, we want to leverage all of this, but we have to understand what we want. And COVID challenges, to me, accelerated the digital transformation because people got used to working remotely, and a lot of things really, mentality shifted a little bit that made digital transformation more ripe to move. However, post-COVID, there is what I call strategic ambiguity and partnerships that are not very clear, and we have the ability to take advantage of all the, both physical and online and teams. So doing this, I really think we are in the right moment now to move forward with better digital transformation. Okay, let's look at what really we should think of digital transformation. Is the process have traditionally been lengthy and designed for humans to handle? Most processes were done manually or semi-manually. With digitalization, new needs have evolved. And what is digital tools are needed to help redesign the process exist and can be leveraged with appropriate AI. What I am really focusing here is we are relying so much on digital data. You talk to someone, it tells you that's what the computer told me. People are now leaving their mental way of thinking about the process, leaving it to the digital world that sometimes is not built in an appropriate way. So, however, we have now created security and privacy, and we have now to accelerate the needs for training in policies and legislations that are appropriate. This depends on where you are, depends on your institution. There are more international standards that are evolving, but privacy and security are becoming more meaningful. And believe it or not, we do occasionally do some check on security and privacy, and we see a lot of failures sometimes. I will tell you this, I just jokingly here put my name with Bill Gates. The first rule of any technology used in a business is that automation applied to an efficient operation will magnify the efficiency. The second is that automation applied to an inefficient operation will magnify the inefficiency. That's something that Bill Gates was quoted to say. Whether you like him or not, whether you believe in what he does or not, doesn't matter. It's a good way of getting us thinking about how digitization it is. And what I say to simplify it, you cannot simply automate a manual process. You need to create a new architecture for process flow. And we deal with this in many, many systems. The process is digitized with the mentality of how it used to work, rather than changing the whole process, even changing the type of people who handle it at different stages, authorization of things, manual renewal, automatic renewal of licenses, automation in a company, ordering processes, all these need to be re-architected and redesigned. And by the way, I speak fast, so anyone can slow me down if you want. So what needs to change? We have really three things: the tools, which we said AI is one of them, IoT and automation. We hear about process automation and robot process automation sometimes is the word, but with IoT, it's very important to realize is IoT is becoming part of the deal. And the tools, we need to look at them that deal with all of these things, because they will be the driving forces. The processes themselves it's two pieces. Sometimes it's the actual process, the steps of how you deal with it, and sometimes the hindrance is in the policies. I was working with some industries, and they are looking at the efficiency of how they hire people. And I discovered that at one situation, they hire temps because the process of hiring a temp is faster, where the process of hiring someone on a full-time and permanent is slower. So the process didn't change, and they can do this faster, automated. The other one will require a lot of steps of people interfering. So they end up losing money, and they recognize it, but they were not capable of changing the policies. So deployment is really all about people. So if people are not believers in the automation and in the digital transformation, then things will not work. So we have to remember that you cannot deploy without training people and getting them ready for the deployment. By the way, I can have questions anytime. I'm not. AI can help digital transformation. This is something I picked up from internet, and these are some of the things that they believe that AI. But from my perspective, that's what we should be focusing on. We should focus on personalized customer service and better scalability and more secure IT infrastructure and data security, and then real-time decision making. This is one issue that I really am very passionate about. Is many people now tell me we have tools that we don't need computer people. We have tools that can create software. And then I tell them, okay, what if you succeed? What you created very fast, is it scalable? Most of the time it isn't. That's where many software, young companies and quick development fail. Is it secure? That's the other part. So these are two things that I believe that scalability and security are very important in creating these systems. Obviously, if they do not make the customer happy, and if they do not allow the management to do real-time decision making, then they are really way backwards in. Let's go back to AI. Obviously, all of us here heard about AI and how 1956 it was coined. And believe me, there was a lot of argument about the word AI because they wanted to avoid something called cybernetics. When I was actually an undergraduate, I was reading books about cybernetics, and it was an intriguing subject. It has a lot of shared things with AI, but the AI community in 1956 wanted to avoid this ambiguity of being called cybernetics. And I really like the idea that the feature of intelligence can be so precisely described that the machine can be made to simulate it. So anyway, so that's how AI, the word at least, started. And then I'll simplify AI. AI really, what we focus on is about machines. I really would just, you can argue with me or disagree. There are many ways of how machines learn. And I will simply say, at its more simplest way, they learn from algorithms. And these algorithms require us to envision all the possible combinations. And obviously, that's not a good way. Then we have knowledge-based systems that evolve from what knowledge people have. And these really, they had the numerical Bayesian approaches, symbolic, expert systems. So, and some of these are still beneficial, by the way, and you will find them hidden in some of the systems that you will not see them, but they are built in part of the system. Then there was the logic programming, which was a fine area. Then now we are in the era of learning from data. I will claim that learning from data is not new. Many of us tried it. Many of us were keen on using it. The problem at the time is we didn't have the capabilities to do it. So I'll claim here that you need the data, you need the computation, and that's what we didn't have. Now we have them. But we need the acceptance of the AI. And we are going through a period of challenges where acceptance, so if you have all three and you can handle all three by maybe You have the talent to compute, you have the ability to collect the data, but if you cannot tell the story and explain the decisions that your AI is doing, then you will not be successful in deploying AI for digital transformation. Okay, so that's here to me is very key to our success in deploying AI and applying it for digital. I go back to, I said AI needs computer. Believe it, that was me here at the University of Wisconsin with a hybrid analog and digital computer. We're trying to push the limits of computation with a combination of analog and digital. And we did even have companies that work on designing helicopters come to this particular computer and test their intelligent control systems. And then we moved to more better computers. Then we went back now, people started to look at the personal computers. Then there were the Lisp machines that really, wow, if you have a Lisp machine, now you are in AI. And then now we have the NVIDIA type people. And obviously I have a few NVIDIA machines that are really very high powered. They do a great job. But if you want scalability, you go to the cloud. And now you have systems that already collected data for you. And the future is quantum. And we have experimented with applying some of the deep learning approaches using quantum techniques. So the future is so wide open. I don't think quantum will be everyone's machine immediately, but we have to be aware of these type of things because I believe in what I call arrive early. If you wait till everyone is there, you will always be behind. This is some information about digitization of the world and how many zettabytes we will have. And it's obviously data is becoming there. The question when I talk about data is, do we really need all this data? Can we use all this data? Is it the fact that we have the data, is it sometimes hindering or is it beneficial? Because that's a tricky question, because many times the data has not been collected with the purpose you want to use it. You see? So in machine learning, deep learning, the data may be there, but it's data that was collected for many purposes. I worked with several organizations, some particularly in healthcare, and they collect the data for different reasons that they want to use it now for. And that gives you a little bit of, you have to think about proxy measurements and does this represent something else? And you have to be a little bit more thoughtful about what type of data you need. Then we had some work about data and learning saturation. Once you have more data, I think there is a logarithmic learning curve. You don't learn as much just by adding more data. You reach a level of saturation in learning, and otherwise you're just crunching more computation without much benefit. Okay. AI needs acceptability, because that's the third thing. We said you need the data, you need the computation, and you need acceptability. This is an article I found from last year. People trust AI to make big decisions as long as humans check them. Okay, from my own experience, we developed things for medical applications, and the only way they were used is we give them an explanation. Every time we give them a score or give them a recommendation, we give them an explanation of why we reached that conclusion. And obviously, with what is traditional deep learning and things like that, there is no exact way to develop an explanation. That's why way back, the ideas of expert systems were rule-based. You can say this rule did this rule did this. So we worked a lot on explanation-based systems, and we have many approaches that we use, and we can talk about them in appropriate things, and some of them are published. Okay, let's move about the University of Louisville, how we approach, and I am involved in this innovation and partnership, particularly because I said AI and digital transformation are key to partnership with industry for university. So we are a research-oriented university. We're R1. We're not, I can assure you, we're not the top one of the R1s, but we are in the R1. So we are a research-oriented university, but we also are very active in community engagement, and there is a classification for the universities that are high in community engagement. So that gives us a little bit of a state of mind of how we operate as a university. We're not only focusing only on research. We do have a lot of people working with the community, a lot of people interested in engaging the community. We also, from another distinction, we have a Center of Academic Excellence in Cybersecurity Education, and we are one of these odd universities. We have it at the undergraduate level in the business school and the graduate level in the engineering school where I teach. And we work together very good. So we seamlessly integrate our talent from the students and the faculty on both schools. So many times, a lot of collaboration works in the cybersecurity, but also in the AI. Because remember, the more AI you have, the more cybersecurity you will need. Believe it or not, they go work together. I had a talk about, are they friends or adversaries, AI and cybersecurity? I believe that they could be friends or they could be adversaries depending on who's using them. So we decided at the University of Louisville, and I wouldn't take credit for that, is 3 presidents ago, created what we call a Digital Transformation Center at the university level. And the idea is to create new pathways and possibility ideas and create more imagination at the level of the employees, the staff, the faculty, the students, and the community. So the focus for us is how do we create this mental state of mind to transform things for all of these levels. So we took a lot of initiatives, and I work with that institute, as I mentioned, partly part of my time as the director for research and innovation for that institute. So let's look at how partnership with technology vendors, we interact with the university population. Last count, we had at least over 500 people, and we interact with at least every year, at least 6 training events. We have LinkedIn Learning as part of what we push for. 2,300 actually people used it. Adobe, we have a partnership with Adobe, with Microsoft and IBM, and there are others. I just highlighted these because these are names you would probably everybody would recognize. And we created our own, by the way, we created our own cybersecurity workforce training, and we are deploying this as part of grants from the National Security Agency, and we are giving them to the community, underserved community. Initially, we started by focus on the veterans and people from transferring from military to civilian jobs. As a director of the research there, I convinced the team to adopt 3 focus areas: cybersecurity, smart communities, health and wellness. And then we focus on what I call foundational areas that are like interactive media, VR, software, data architectures, and analytics, because they will serve all the top 3. And we are also pushing the university for digitization of the research infrastructure at the university. And obviously, you may be aware that most universities, IT and academic departments are not necessarily working together all the time. So we establish better relation with them, and we're pushing them toward digitization of the infrastructure for the whole university. Let's go back to partnership here, because that's what we started. I think that industry and government partners are interested in context and application. They have data sets. They have focused very much on outcomes. Academic, we have the technical expertise. We look at emerging technologies faster than most industry. And we have rigorous applications of methods because we go through peer-reviewed things and things. So that intersection is where I believe the innovation can happen when we work together. And AI is particularly used to identify any process that we perceive as intelligent. This may not be a scientific definition, but it holds in many cases. So much of the innovation is not in creating new science, is in using the existing science and applying to improve the process or the production or the productivity of our partners. Okay. Just to give you a little bit of what I do, I have my lab. Long ago, I called it Innovative and Emerging Technologies Lab because I hate to get stuck in one thing. It gives me the freedom of doing what I want to do. So we did a lot of research teams and things like that. We just recently published a paper in drones about recognition of people and re-identifying them. And we did a lot of work on things related to mammography. And actually, we got some good recognition. This, we could identify breast cancer masses a year before the doctors in about 30% of the cases, which was shocking because this came from, the data came from a relatively very good hospital. We helped a company that handled packages in improving their recognition. The packages, if you see how they are handled, they are like a load of packages that are messed up, and they handle them with robots. So we helped them. They had a very good algorithm, but they knew that it could be better. We helped them with that. We work on pressure injury, which is very, very kind of important for me because I have family members who, before they passed, they had pressure injuries, the bed sores. We got a lot of funding in cybersecurity. I call us Triple Crown winner because we got money from DOD, NSA, and DHS almost at the same time. And now we got another one from NSF, which is another called Scholarship for Service. So we got a lot of money in the last few years, but that forced us to think and to integrate. We work across the curriculum and across, we have people from criminal justice, public health, business, education, and a lot others that we integrated together to create our training material that goes to industry. And we have multiple feedback from industry to do that. And we still didn't give up on. We work with our gas and electric smart street lights. We did an interesting study on gas street lights and wind analysis in our region because wind has not been. Actually, we did some work with the Louisville Airport and with the Cincinnati Airport. Okay, now how do I do this into actually an innovation center? Many years ago, I started talking to a company in 2014, a healthcare company. It was a very large one. And 2016, we started the full collaboration and opened that space that appears to the right. We call it Hive. We opened it. It was a big ceremony. You see the cutting of the ribbon. And we had the mayor, we had all the dignitaries. It was a big event. And then in 2023, before the end of 2022, we realized that the company got bought and really their needs to manage the space were less. So I told them, I'll take it over. So now as a faculty in the university, I kept the name Hive, but I changed it to this logo there, AI Innovation Studio. Now instead of working with one company, I'm working with multiple companies, using the space as a gathering space for students and industry to come and work in innovative ideas. And actually, we're even expanding the space and getting more space availability to increase. Instead of working only with one healthcare company, now we have multiple businesses and multiple events that we can host there. Because when you work with one healthcare company, access to the building becomes limited. And really, they don't mind if they were running it, but now that we are running it, we're still working with them under HIPAA requirements, and we only use their equipment for their projects. Then, as I said earlier, I also got interested in creating virtual reality because it serves a lot of these areas. So I'm in the process of finalizing. I ordered a lot of the equipment. They arrived. I'm waiting only on actually this screen. To the left is 13 foot by 7.25 foot. This will be an interactive screen, almost like a cave. And we bought also a 12 camera motion capture system to create animation virtual reality. So that's another area. And I have collaborators from criminal justice, from materials, from business school. So we're looking to deploy this in different areas of research. My earlier work with the industry was in creating physical therapy animations, so that actually if you go to a physical therapy, you can get an animation to see what the physical therapy you have, rather than get a printed sheet or a video, because when it's created like an animation, you can rotate it and see it from different angles, and you would understand it better. The future of AI, I think I'm getting close to finishing, maybe too early, but obviously OpenAI CEO Sam Altman says AI will reshape society, acknowledges the risks. He's a little bit scared of this, that's what he says. Apple co-founder warns AI will make it harder for you to spot scams. That's Steve Wozniak. Is one of my favorite people. I really like him. Very nice guy. But I have a colleague here, Roman Yampolsky, who has been actually in writing about this for a while. AI, intelligence, safety, and security, artificial superintelligence. And he has a lot of followers. He got invited many countries to talk about that. Am I okay? Hello? Okay. So Roman gets invited to talk about this. He's been writing about this topic for a while before people were so scared of it. I like a book that's very easy to read by Stuart Russell. He talks about human compatible. So if we want AI to keep moving forward, we want to make sure that it's human compatible. Okay. My lessons learned that I'll share with you is a bad workman blames his tools. And so what I like here is I have a hammer, then everything is a nail, you know? So we many times are stuck to our techniques and methods rather than learn from the needs of industry to adapt and create new methodologies. And through what I would important say, create multidisciplinary teams, listen to the industry needs rather than go tell them what we know. I think that's a mismatch in culture. And I always tell my students, you have to solve the right problem than to solve any problem right. Because you may know how to solve some problem, but it's not the relevant one. And we have to use the right tools and methodology, and we have to explain and learn how to tell the story, because if you don't tell the story, it will not be adopted and will not be useful to the rest of the world. And I think I finished too fast, and I'm unfortunately ready for question. I can expand on anything that I said.
Okay. We have heard the lecture. I think that Professor Adele is still not available for the discussion. Am I right?
Yes, unfortunately, he will not be able to join now. So
Oh, that's too bad, but it doesn't stop us from discussing these topics, since the lecture was very interesting and it provided us with a lot of things to think about. So I would like to hear from our listeners. Does anyone have any comments or experience that they can share, or maybe questions that we can all try to answer together? And yes, I agree with Donna. It was really an excellent lecture. Do we have any comments? Does anyone have any experience with AI, especially in the context of digital transformation? I guess we have no questions or discussions. So Islam, should we take a break or what is the
Thank you for
plan?
support. And we according to the program, we have small break after this session because we are moving to region 9. So this was the last session in region 8, and maybe we will start after 45 minutes with region 9 with Roberto and his colleagues and insights, sharing their great presentations and discussions. So I'd like to thank you for supporting us today, and I truly appreciate your support.
And I would like to thank you for organizing this event. It was really, really interesting, and I think it was it had a lot of excellent presentations.
I'll utilize the time maybe to share with the audience some of the talks and videos for the DVP and the opening session. So we
That
can
would be
utilize
great,
the
yeah.
time. I will start with sharing the talk of Giorgio Proler at the opening of this day.
Good morning, good afternoon, good evening, and good night. A greeting adapted from the movie The Truman Show, starring Jim Carrey. And it works here since to each of you there is some relevance in that greeting. And hello, Kuala Lumpur, Sapporo, San Francisco, Wilkes-Barre, Thule, Dublin, Bruges, Cairo, and Mumbai. I'm George Proler, Chair of the Computer Society Distinguished Visitor Program, and it is my honor and privilege to welcome you to this, our second annual IEEE CS EXA DVP event, or as we call it, the 24-hour event. Second annual has a nice sound to it. At the beginning of last year, hosting such an event was just a thought. To extend an earlier project to cover an entire day, 24 hours of presentations, reaching and including our diverse membership. And quite frankly, we were unsure if we could put it together. But Professor Hussam Fahmy, my predecessor, and Professor Islam Halim, Chair of the Awareness and Customer Advocacy Committee, and his team rose to the challenge. And we did it. And it was successful. The first annual. And now, well, Professor Islam and his team have outdone themselves. Look at the agenda for the next 24 hours. Artificial intelligence, AI security and privacy, and research ethics in the area of AI. Quantum computing and the quantum world, smart and high-performance computing, and the list goes on. And we are already working on the planning for the third annual event for next year, taking another step and upping the challenge for Professor Islam and his team, as we are looking to make this a hybrid event with on-ground activities concurrent and shared with the online participants and attendees. This event spans each of IEEE's 10 regions and the world's time zones, hence my adapted greeting, since each of you and the DVs, the presenters, the moderators, you all hail from different and diverse regions, and for some of you, it's 10 a.m., 2 p.m., 8 p.m., and 2 a.m., and all the hours in between. So it is morning, afternoon, evening, and night. Truly an effort of inclusion of our diverse membership base. Today is International Volunteers Day, which is fitting since it has taken, and before this day is through, it will take the efforts of more than 50 Computer Society volunteers coming together from the Geographic Activities Committee, Students and Young Professional Activities Committee, and the Distinguished Visitor Program to bring this event to you. Over the next 24 hours, you will have the opportunity to attend more than 20 technical presentations on topics I've already mentioned. along with informational talks about the Computer Society and its regions, activities, and programs. Each presentation will be introduced by an event moderator who are members of various student chapters, and through participation in this event are gaining experience and opportunity. And then there is the audience. That's you. Many of you are members and affiliates of the Computer Society who volunteer your efforts to make local programs a reality. And all are here allowing us to bring this event to you. So thank you for your time. And now, before I wear out my welcome, I'd like to pass the baton to Professor Hironori Washizaki, the President-elect of the Computer Society.
Hi, I'm David Allen Greer, the IEEE Computer Society President for 2013. And I'm here to talk about the community of professionals that you join when you become part of the IEEE Computer Society. Usually when we talk about the benefits of joining the society, we talk about those things that you see flashing over my shoulder right now. We talk about the digital library. We talk about standards, periodicals, continuing education materials. Those are all benefits, to be sure, very real benefits. But people will say, I get the digital library at work, so I don't need to be a member. Or I get periodicals in other ways, so I don't need to be a member. I have exactly one standard I ever use. I already own it, so I don't need to be a member. Those arguments have some truth in them, but they miss out the point that you are investing in your professional career by being a member of the Computer Society. You're joining a community of people who, for over 60 years, have worked to advance this wonderful technology that has quite literally changed the world. And when you join them, all you do is need to make one connection a year, and that will be an investment in your career, in how to be a professional, how to see where the community is going, what are the new trends, how you should behave yourself, how you should think as a professional computer scientist, computer engineer, software engineer, or other information professional. These are the benefits. These are the real benefits. You're investing in yourself when you join, because it's through these connections that you really learn to be a professional. Information, you can get that on the internet. Professionalism, you get that from the IEEE Computer Society. We have a web page below that you can click on to renew your membership. Thanks for listening. Take care.
It all started with a spark of curiosity in 2022 when I came across the IEEE Extreme Programming 16.0 competition. The idea of joining thousands of coding enthusiasts from around the world for the 24-hour coding competition was too thrilling to resist. Little did I know that this event would mark the beginning of a transformative journey, one that would take me across continents, connect me with brilliant minds, and open doors to endless possibilities within the IEEE community. Soon after, I co-led the formation of Ghana's first IEEE Computer Society student chapter, a milestone that came to fruition in December 2022. This wasn't just about establishing a chapter, it was about creating a space where students could explore their potential in tech with the support of a global community. This chapter introduced us to countless opportunities, and I quickly realized that the IEEE wasn't just a platform, it was a family, one that pushed us to aim higher and dream bigger. One of my fondest memories was participating in IEEE EXA engineering math during the My Robot Friend workshop at Caris Primary School, where we met and mentored kids who were eager to learn about robotics. Together we built robots and inspired future engineers. From organizing tech workshops to attending international conferences, IEEE provided the perfect avenue to blend my passion for tech with real-world impact. Attending the Region 8 North Africa Student and Young Professional Congress in Cairo was another great opportunity. Meeting tech enthusiasts from across the region wasn't just inspiring. It became the foundation of future collaborations. The friendships and connections I made at this Congress were instrumental when I took on the role of Uganda Section Lead Ambassador for IEEE Extreme 17.0. where we recorded the highest participation in our section's history. This incredible team effort resulted in my nomination as one of the best extreme section leads for version 17.0, a testament to the strength of our collective ambition and collaboration. IEEE's collaborative spirit greatly enhanced my journey, connecting me with a global network of experts, volunteers, and top leaders, including IEEE presidents and society executives. These interactions provided invaluable knowledge, mentorship, and lasting friendships, which fueled my passion for volunteering. A defining moment in my IEEE CS journey was being awarded the Richard E. Milwen Scholarship, becoming the first recipient from Uganda section. This was a dream come true. I have also had the privilege of mentoring other students who have gone on to win the REM Scholarship and witnessed the continued growth of the CS community in Uganda. This year's highlight has been volunteering as the CS SYP TechX lead, where I've worked with a diverse and dedicated team that has expanded IEEE CS career development programs to over 2,000 students and young professionals across the 10 IEEE regions. Through TechX, we've hosted more than 17 events in Tunisia, Kenya, Jordan, Colombia, the US, Brazil, India, and Australia, creating a platform for networking and professional growth. What makes the IEEE Computer Society truly special to me is its emphasis on leadership, volunteering, and technological advancement. The society offers opportunities to make a tangible impact. In reflecting on my IEEE journey, it's clear that each milestone was shaped by the support of others, whether it was forming a student chapter, attending international conferences, or leading major initiatives. None of it would have been possible without the collective efforts of fellow volunteers, mentors, and friends. This journey has taught me the importance of giving back, and I hope to continue inspiring new volunteers to take small steps that lead to meaningful impact.
When I joined the IEEE Computer Society, I was able to lead efforts to make our communities more diverse and inclusive.
When I joined the IEEE Computer Society as an undergraduate in the early 1980s, it greatly expanded my research network and increased my access to the top conferences and journals in my community.
Joining the IEEE Computer Society helped me keep up with the latest innovation and technology trends so that I could excel in my day-to-day job.
Join the IEEE Computer Society today.
The IEEE Computer Society's Distinguished Visitors Program delivers tools for individuals at all stages of their professional careers through visits to chapters, offering opportunities for individual interaction, and to the membership through webinars by respected professionals. We have distinguished visitors who cover machine learning, cybersecurity, robotics, big data, cloud computing, blockchain, and cryptography, among others. Chapters can request a distinguished visitor on computer.org/distinguished-visitors. The Computer Society pays intercity travel, while chapters are responsible for all costs with regard to the hosting of the distinguished visitor, such as lodging, transportation, and food and incidentals in the city of the presentation. The Distinguished Visitors Program is able to pay up to $1,000 for a visit to a chapter, but by working with other nearby chapters to develop a tour, that amount can be increased. So when your
From expanding my knowledge to forging lasting connections, my journey with the IEEE Computer Society has been nothing short of transformative.
It all began back in 2022 when I first joined IEEE as a highly active member, attending every workshop, event, conference, anything I could. My passion for learning and connecting has been at the core of my IEEE experience. I've always been curious and eager to expand my knowledge. Being a part of IEEE Computer Society has given me access to incredible resources and a network of inspiring individuals. It has been a journey of a personal and professional growth, pushing me to explore new horizons. My first and official role at the IEEE Computer Society was being selected as IEEE Extreme 18.0 Ambassador, and it had an everlasting impact on me. Through this experience, I developed essential networking skills, connected with incredible people from across Tunisia and beyond. It wasn't just about organizing a global competition. It was about stepping into a leadership role, managing challenges, and supporting others in their technical journeys. I also had the honor to serve as CSTEM 1.0 Ambassador, the biggest computer society conference in the Tunisia section. It was challenging, but a highly rewarding experience. These roles gave me the confidence to lead, but also showed me the value of collaboration. I learned to communicate effectively with diverse groups and to adapt in different situations.
Aside from leadership roles, I've also had the opportunity to participate in various competitions. These experiences not only tested my technical skills, but also reinforced the value of teamwork and perseverance. Each role and competition has shaped my journey with IEEE Computer Society. It has allowed me to grow not only as a leader, but also as a learner. The experiences, friendships, and knowledge I've gained will continue to guide me in my future endeavors. IEEE has provided me with a platform to learn, lead, and compete on a global stage. I encourage everyone to get involved, take advantage of the opportunities, and start their own transformative journey with IEEE.
Computing is expansive.
Computing is evolving.
Computing is limitless.
We are the IEEE Computer Society, the professional home for all computing.
We bring together passionate engineers, scientists, academics, and industry to cultivate environments for idea exchange, dialogue, debate, and collaboration.
We set the standard for learning that empowers, with peer-reviewed publications and international conferences, local chapters and meetings, and valued resources.
We support members, we cultivate leaders.
We help computing professionals at every stage of their career.
We are the IEEE Computer Society, your professional home.
Hello everyone, I'm Shema. I'm an ambitious computer science engineering student and a proud member of IEEE Computer Society. I think that the journey with IEEE Computer Society has grown me many benefits, countless benefits, personally and professionally. This is why I believe that it is important to share with others so they too can experience the same. As newcomer to computer science and engineering. When I was a first year engineering student, I felt completely overwhelmed and didn't know where to begin. There were countless tutorials on YouTube and the volume of information that people use. I didn't know which courses or fields to focus on. I realized when I discovered the IEEE Computer Society, everything has changed. Now, I'd like to offer a brief glimpse in the IEEE Computer Society chapter wall, focusing on the key elements that have influenced my journey. Really, I feel easily privileged that my journey as a student has been treated by the IEEE Computer Society. It has opened doors to opportunities that most students have with mine, but also through my personal journey. I can't overstate this transformative experience has been. I strongly encourage all of you to seize the amazing opportunities that this community offers. So don't miss out.
It all started with a spark of curiosity in 2022 when I came across the IEEE Extreme Programming 16.0 competition. The age of joining thousands of coding enthusiasts from around the world for the 24-hour coding competition was too thrilling to resist. Little did I know that this event would mark the beginning of a transformative journey, one that would take me across continents, connect me with brilliant minds, and open doors to endless possibilities within the IEEE community. Soon after, I co-led the formation of Ghana's first IEEE Computer Society student chapter, a milestone that came to fruition in December 2022. This wasn't just about establishing a chapter, it was about creating a space where students could explore their potential in tech with the support of a global community. This chapter introduced us to countless opportunities, and I quickly realized that the IEEE wasn't just a platform, it was a family, one that pushed us to aim higher and dream bigger. One of my fondest memories was participating in IEEE Try Engineering Math during the My Robot Friend workshop at Caris Primary School, where we met and mentored kids who were eager to learn about robotics. Together we built robots and inspired future engineers. From organizing tech workshops to attending international conferences, IEEE provided the perfect avenue to blend my passion for tech with real-world impact. Attending the Region 8 North Africa Student and Young Professional Congress in Cairo was another great opportunity. Meeting tech enthusiasts from across the region wasn't just inspiring. It became the foundation of future collaborations. The friendships and connections I made at this Congress were instrumental when I took on the role of Uganda Section Lead Ambassador for IEEE Extreme 17.0, where I recorded the highest participation in our section's history. This incredible team effort resulted in my nomination as one of the best Extreme Section Leads for version 17.0, a testament to the strength of our collective ambition and collaboration. IEEE's collaborative spirit greatly enhanced my journey, connecting me with a global network of experts, volunteers, and top leaders, including IEEE presidents and society executives. These interactions provided invaluable knowledge, mentorship, and lasting friendships, which fueled my passion for volunteering. A defining moment in my IEEE CS journey was being awarded the Richard E. Milwen Scholarship, becoming the first recipient from Uganda section. This was a dream come true. I have also had the privilege of mentoring other students who have gone on to win the REM Scholarship and witnessed the continued growth of the CS community in Uganda. This year's highlight has been volunteering as the CS SYP TechX lead, where I've worked with a diverse and dedicated team that has expanded IEEE CS career development programs to over 2,000 students and young professionals across the 10 IEEE regions. Through TechX, we've hosted more than 17 events in Tunisia, Kenya, Jordan, Colombia, the US, Brazil, India, and Australia, creating a platform for networking and professional growth. What makes the IEEE Computer Society truly special to me is its emphasis on leadership, volunteering, and technological advancement. The society offers opportunities to make a tangible impact. In reflecting on my IEEE journey, it's clear that each milestone was shaped by the support of others, whether it was forming a student chapter, attending international conferences, or leading major initiatives. None of it would have been possible without the collective efforts of fellow volunteers, mentors, and friends. This journey has taught me the importance of giving back, and I hope to continue inspiring new volunteers to take small steps that lead to meaningful impact.
Good morning, good afternoon, good evening, and good night. A greeting adapted from the movie The Truman Show, starring Jim Carrey. And it works here since to each of you there is some relevance in that greeting. And hello, Kuala Lumpur, Sapporo, San Francisco, Wilkes-Barre, Thule, Dublin, Bruges, Cairo, and Mumbai. I'm George Proler, Chair of the Computer Society Distinguished Visitor Program, and it is my honor and privilege to welcome you to this, our second annual IEEE CS EXA DVP event, or as we call it, the 24-hour event. Second annual has a nice sound to it. At the beginning of last year, hosting such an event was just a thought. To extend an earlier project to cover an entire day, 24 hours of presentations, reaching and including our diverse membership. And quite frankly, we weren't sure if we could put it together. But Professor Hussam Fahmy, my predecessor, and Professor Islam Halim, chair of the Awareness and Customer Advocacy Committee, and his team rose to the challenge. And we did it. And it was successful. The first annual. And now, well, Professor Islam and his team have outdone themselves. Look at the agenda for the next 24 hours. Artificial intelligence, AI security and privacy, and research ethics in the area of AI. Quantum computing and the quantum world, smart and high-performance computing, and the list goes on. And we are already working on the planning for the third annual event for next year, taking another step and upping the challenge for Professor Islam and his team, as we are looking to make this a hybrid event with on-ground activities concurrent and shared with the online participants and attendees. This event spans each of IEEE's 10 regions and the world's time zones, hence my adapted greeting, since each of you and the DVs, the presenters, the moderators, you all hail from different and diverse regions. And for some of you, it's 10 a.m., 2 p.m., 8 p.m., and 2 a.m., and all the hours in between. So it is morning, afternoon, evening, and night. Truly an effort of inclusion of our diverse membership base. Today is International Volunteers Day, which is fitting, since it has taken, and before this day is through, it will take the efforts of more than 50 Computer Society volunteers coming together from the Geographic Activities Committee, Students and Young Professional Activities Committee, and the Distinguished Visitor Program to bring this event to you. Over the next 24 hours, you will have the opportunity to attend more than 20 technical presentations on topics I've already mentioned, along with informational talks about the Computer Society and its regions, activities, and programs. Each presentation will be introduced by an event moderator who are members of various student chapters, and through participation in this event are gaining experience and opportunity. And then there is the audience. That's you. Many of you are members and affiliates of the Computer Society who volunteer your efforts to make local programs a reality. And all are here allowing us to bring this event to you. So thank you for your time. And now, before I wear out my welcome, I'd like to pass the baton to Professor Irinori Washizaki, the President-elect of the Computer Society.
Before starting our next session, I'll just need to answer the question that I have received about those videos were played for those great young people who shares their journey and experience. with the computer society. You can find those videos on the social media pages of Region 8 Computer Society. So this kind of effort have been done with the support of Muhammad and Lina, the digital presence lead for Region 8 Computer Society. So it was part of the context which we asked all the young student and young professional to share their journey, and they were recognized by supporting them with fully funded registration to attend the first ever Computer Society SYB Region 8 Congress. So this photo from the opening ceremony where they get their recognition. And this, the group photo for the Congress was just conducted maybe 2 or 3 days ago. It was held in Egypt. So according to the program, I think we should start in just 5 minutes with the opening session for Region 9. I think Roberto, you are here. Hello. Hi. Andona, how are you?
Oh, very, very proud of what you're doing right now. It was hectic. I couldn't stay in the morning, but at first time in the morning, I was here listening to the speaks. Very, very interesting and a lot of knowledge. I've been posting to my colleagues so they could to to know what's happening in the world and that we are part of it.
Thank you so much. It's a pleasure. And I'd like to leave the floor for Region 9. Please, it's your time, and I'm glad to allow you to moderate the session and introduce your activities. Thank you so much.
You're welcome. Roberto, ¿tú crees que puedes probar a ver si sale bien la presentación?
Of course, Donna. What a moment, please. Okay. It's working.
Perfect, perfect, perfect. Good afternoon, good day, good night to everyone that are here. These hours trying to interchange information and to give the most of knowledge that each of our countries have been doing in these years. All the speaks were very enlightening and very interesting. I would like to thank another again Islam and all the team that have been doing all this organizing this event that united us all as one unity, that is computer society. All the regions. I was connected last night. Well, it was last night for me. About 8:30, I was connected. Oh, and I reached until 12 o'clock, and it was very interesting. So, um, welcome to you all to this session. We will start with Roberto. Well, first I will introduce myself. Oh, my name is my name is Donna, Donna Roper. I work at the University of Panama. I have more than 30 years of working at the university as professor and researcher. I've occupied several roles as head of faculty, head of the faculty, no, of the schools, different schools, of the Department of Computer and Informatics. And well, it's been a journey. I became part of computer and of IEEE. Not so young as most of you, but I found it very enlightening to have my students in informatics area to computer science to know that IEEE also could give them knowledge and they could participate in the whole society and the whole community of IEEE. So after that, I started with Computer Society through one of my students that was very interested in applying for Merwin scholarship. So I was part of the team, so I acceded and I said, okay, I'll be part of computer, and that was at least 10 years ago. So I welcomed you all. Well, let's start. I will do part of this in English, but as IEEE sponsor and fosters diversity and inclusion, having this interchange in different languages is part of the inclusion we want to have as one of the goals of IEEE. So Roberto is going to speak about reflections on diversity and inclusion in everyday life, reflexiones acerca de diversidad e inclusión en la vida cotidiana. And Roberto is going to speak in Spanish, and we will have this as a diverse presentation. Voy a presentar a Roberto. Roberto es un profesional altamente calificado en el ámbito de la ingeniería informática y desarrollo de software, con más de 10 años de experiencia en roles técnicos y de liderazgo, graduado de Ingeniería en Computación e Informática en la Universidad Andrés Bello. Actualmente cursa la maestría en Ciencias de Computación en la misma institución. Ha ocupado posiciones clave como jefe técnico de ingeniería de la agencia SUR, SPA, y Chief Technology Officer en Censo Labs, donde ha liderado equipos multidisciplinarios en proyectos de transformación tecnológica. Sus competencias abarcan áreas como DevOps, desarrollo de aplicaciones móviles, metodologías ágiles y administración de base de datos SQL. Además, cuenta con certificaciones técnicas como GitHub Foundations y complementan su sólida formación académica y profesional. Además, Roberto es Graduate Student Member of IEEE con una larga trayectoria como voluntario, siendo reconocido como egresado del IEEE Vault Program en el 2022. Actualmente Roberto es el Coordinator of IEEE Computer Society. Sin más preámbulo, procedemos a recibir a Roberto. Thank you, Roberto. You can, this is for you. You can talk.
Thank you, Donna. Ok, como lo habíamos dicho anteriormente, la presentación la vamos a hacer en español, pero si quieren hacer consultas, no hay problema en hacerla en inglés. Del mismo modo, el material que se va a mostrar está hecho en inglés para facilitar la comprensión de contenido. Antes de la presentación, vamos a ir a una pequeña introducción rápida de lo que es la región 9 en cuanto a Computer Society. Computer Society, a diferencia de IEEE, se divide en 7 regiones, como se puede ver en la presentación. A partir de ello, a nivel jerárquico, nosotros estamos comunicados a través del Comité de Membresía y Actividades Geográficas, el Subcomité de Actividades Geográficas y están nuestros equipos regionales. De esa forma, nosotros tenemos igual una llegada directa a lo que es la presidencia y el panel y el Board of Governors, que es el equipo son a nivel de la sociedad, a nivel de la sociedad. En cuanto a cómo funciona el GAC, pueden ver en esta presentación que tenemos equipos transversales y equipos localizados. Vamos a saltar. Y nuestro equipo regional está enfocado en esta estructura. Tenemos los equipos territoriales, que son las distintas áreas, los estudiantes que representan en ella, y los equipos transversales, que es comunicación y conferencia, diversidad e inclusión, industria y academia. Con ella podemos empezar a atacar los distintos focos y equipos. El equipo de este año lo presentamos aquí, que son todos los voluntarios que están detrás de todas estas actividades, y hay muchos más que no han sido incluidos, para darle un pequeño reconocimiento del día a día que están apoyando. A nivel de estadísticas, la región cuenta actualmente con 3.340 miembros, de los cuales el 60% son estudiantes y el restante 40% son profesionales, ya sea formales o integrados por medio de un programa de afiliado o de asociado. ¿Eso qué quiere decir? Que en otras palabras, 3 de cada 5 miembros de nuestra región son estudiantes. Por eso que hay un enfoque en particular en formar los talentos ahí. En cuanto a equidad de género, hemos podido subir estadísticas de años anteriores, que teníamos un 10% de representatividad, a un 25-28%, en el mejor de los casos, de estudiantes. Eso quiere decir que nuestras carreras, en cuanto al desarrollo del STEM, se están desarrollando de mejor forma y hay mejor llegada. En ese sentido, 3 de 4 mujeres son estudiantes. Eso nos da un elemento importante a considerar. En cuanto a los capítulos profesionales, de las 36 secciones que tiene la región, tenemos una presencia en 26 regiones, siendo los últimos creados Colombia-Caribe a Monterrey. Y en un futuro es empezar a crear capítulos en las secciones que faltan, las que destacamos Río de Janeiro, Puerto Rico Este o Paraguay, que tiene una cantidad suficiente de miembros y sin embargo no hemos creado un capítulo. Esa misma, en realidad, de estudiantes, tenemos el caso del mismo lado donde tenemos potenciado Perú y Colombia, pero aparecen las potencialidades de los lugares que ya hemos mencionado anteriormente para hacer crecer la sociedad. En los puntos destacados tenemos los fondos de diversidad e inclusión que se participó en 2023, la formación de 12 capítulos estudiantiles y la creación del CLAPSI. Y si lo comparamos con este año, mantenemos más o menos la tendencia de creación de capítulos estudiantiles, pero hemos podido crear un capítulo profesional por segundo año consecutivo. También hemos trabajado en el CLAPSI este año en El Salvador, junto con el SAP Global Congress. Después Cristian va a profundizar el tema. Y hemos participado del Computer Society Global Congress con el top 3 de los capítulos profesionales. Preliminarmente, algunas metas del plan de acción que se está elaborando consiste básicamente en fortalecer el llamado voluntario, promover el CLAPSI, creando un TAG técnico, porque tenemos demasiadas capacidades en cuanto a esos capítulos, o sea, comunidades técnicas que no hemos sacado provecho en la región. Promover el IEEE Computer Society Day, que es en septiembre del próximo año, y empezar a crear mecanismos de inclusión real, más que forzar una inclusión o que sea una inclusión de palabra, y no sea de hecho. Mejorar la eficiencia de los canales de comunicación, que es uno de los debilidades que nos han reportado muchas personas, y para fortalecer todo esto, y por en el enfoque de potenciar a los estudiantes y jóvenes profesionales y el plan estratégico, el próximo año el encargado de SIP va a ser el vice-chair de GAG. De esa forma de generar una sinergia más integral. Terminado el tema desde el punto de vista de región 9, como equipo presentamos un poco la charla. En virtud del tiempo es sumamente breve, pero yo creo que son puntos que tenemos que destacar. Voy a partir un poco del concepto de qué considero un poco la neurodivergencia, que es un poco la diversidad que yo veo en el día a día. Dentro del paradigma de la optimización, existe una frase que tiene que ver con el teorema del no free lunch. Y la frase que está citada está en inglés: There's eins not such thing as a free lunch. Básicamente, no podemos tener un almuerzo gratis o no podemos tener una herramienta que nos sirva a todos los casos. Entonces yo lo veo, la neurodiversidad, como simplemente una aplicación del no free lunch, que quiere decir que son personas que tienen competencias que son más resaltadas, por lo tanto, en compensación para otras áreas, tienen competencia un poquito que necesita más refuerzo y mayor debilidad. Así que, ¿qué es lo que he aprendido y qué es lo que quiero resaltar en base a esto? Es, primero, que todas las personas que tenemos este tipo de características tenemos que reforzar y estudiar nuestras debilidades, fortalezas, oportunidades y amenazas. A partir de ella, trabajar en ella, dividir y conquistar. Sabemos que nos cuesta ver por el tema de hiperfoco y de concentración, nos cuesta ver la situación con tareas grandes, entonces tenemos que aprender a dividir las distintas tareas, trabajar con espacio de tiempo. De esa forma podemos ir rotando y ir trabajando con ventanas. Eso se conoce como la técnica Pomodoro. Empezar a ver cuáles son los detonantes de estrés y cómo encararlo para poder subsanarlo. Y determinar cuáles son las banderas verde y bandera roja que nosotros tenemos que tener precaución. Ahora, ¿qué es lo que nosotros tenemos que ver si tenemos a un colega o un compañero que esté con el soporte de neurodivergencia? Hacer escucha activa. ¿Eso qué quiere decir? Estar atento a lo que dice, ver las acciones, los gestos, que es importante desarrollar. Hacer que el equipo que está sea un equipo y no un grupo, ver en conjunto cómo podemos potenciar nuestras debilidades y fortalezas, por eso conviene hacer un análisis en FODA, y estar atento de qué necesidades tiene cada uno de los miembros de tu equipo. Para finalizar, quisiera recordarle que pueden contactarnos en inglés, en español, en portugués, a los siguientes correos: r9gac@computer.org o r9sip.computer.org. Nuestras redes sociales están en nuestro Linktree y invitarlos a participar de ser voluntarios este 2025. Tenemos nuestros comités principales, como hemos presentado velozmente, y el código de la convocatoria está en el QR. Así que dejamos el espacio para dudas o consultas. En este momento, mientras esperamos un poco, quisiera comentar un poco el tema de convocar voluntarios. Ahí me acaba de llegar una pregunta. Gracias, Eric. Aquí la pregunta es: ¿por qué eres voluntario? Es decir, ¿qué te mueve el tiempo y esfuerzo a la sociedad? Básicamente, yo creo en el principio de retribución. Ese principio quiere decir que cuando uno hace una acción, hay que intentar apoyar y entregar el conocimiento. Me gusta un poco IEEE porque combinan los dos temas. Desarrollamos e integramos la barrera tecnológica, que es una de las metas que tengo: generar mecanismos, más que solo llegar con internet, solo llegar a un celular. Cómo la tecnología se adapta en el día a día. Eso hizo que quisiera participar como voluntario, en particular en la sociedad de computación, en Computer Society. Independiente de las debilidades, independiente de las inquietudes que uno tenga, el objetivo aquí es integrar, es aportar y conectar. For example, in my case, it's very, very difficult speaking in English, but it's necessary working in your weekends. Como mencioné anteriormente en inglés, es una de mis debilidades que tengo. Sin embargo, la sigo trabajando, porque eso genera una sinergia para poder ir mejorando. La idea in the society es construct, build a new initiative, and close the gaps, because it's necessary. Integrate your students in local environment and your professional in global scenario. And later, integrate your experience, your global into your local space. La idea básicamente en eso es empezar a integrar el conocimiento de la gente local, de los estudiantes, con la comunidad local, y traer de vuelta ese conocimiento adquirido en el mundo global. ¿Alguna otra pregunta? ¿Otra question? No hay de qué, Eric. You're welcome. Yo creo que en virtud del tiempo, ya viendo que llegó el siguiente expositor, vamos a dejar hasta aquí las consultas. Simplemente decir muchas gracias por haber escuchado y estar atento a sus distintos aportes.
Muchas gracias, Eric, por la pregunta y Roberto por tu intervención. Mi pregunta es, ¿cómo pueden las personas formar parte de esta organización que en sesiones anteriores se pudo escuchar que hay personas que eh, utilizan los recursos que ofrece la sociedad de computación, pero no son miembros? ¿Qué hay que hacer o cómo hay que hacer para poder eh, sumarse a la comunidad de Computer Society?
Pueden hacerse miembros dentro del sitio web de Computer, computer.org, como también pueden empezar a participar en actividades. La idea es dar el salto de la participación a ser miembro y de ser miembro a ser voluntario, ya que mucha gente participa como voluntario pero no participa como miembro. Simplemente con la inscripción se puede hacer y de ahí aprovechar las oportunidades. Como mismo mencionaste en la pregunta, Donna, el tema de los fondos que existen es una buena iniciativa para ir conociendo a la sociedad. Entonces, las distintas actividades y tipo de iniciativas. Y aprovechar de generar redes de contacto, networking de la experiencia.
Viendo este aspecto, Roberto, de diversidad e inclusión que tú hablas, eh, ¿cuáles son las lecciones aprendidas que has llevado en el tiempo que has pertenecido a Computer, a IEEE y has liderado la región en Computer Society?
Básicamente, lo que se ha aprendido es la necesidad de conectarnos y el trabajo que hay que hacer para poder difundirnos y concretar iniciativas. Ese es un tema que nos falta trabajar. El mensaje en sí cuesta que llegue a las localidades y un poco lo presentado en las mismas estadísticas. Tenemos lugares que tenemos miembros, pero no tenemos voluntarios. Cierto que tenemos potencial para poder hacer cosas en distintos territorios. Básicamente esa es la lección aprendida y un poco la misión a futuro a concretar.
Eh, otra consulta, ¿cómo tú has visto, Roberto, no sé si en las estadísticas aparecen, la participación de la mujer en el área de computación como voluntaria per se?
Sí, en general, si revisamos las estadísticas que tenemos acá, es posible ver que la integración, los capítulos estudiantiles han ayudado a una mejor integración con las mujeres. Por eso, en este momento, la brecha de mujeres y miembros profesionales, de miembros estudiantiles versus las mujeres profesionales con los miembros profesionales se ha estrechado. Revisando estadísticas anteriores del 2023-2022, este porcentaje de estudiantes era un 10%, un 11%, y el de profesional era un 8%. Poder duplicar ya un 50% sembrar el doble para profesionales y casi el triple para estudiantes, demuestra un poco que las actividades locales y que han hecho los distintos capítulos estudiantiles han logrado mantener eso. Ahora la misión es pasar esa tarea de los capítulos estudiantiles a los capítulos profesionales para dar una continuidad.
Sí, tengo una última pregunta que te estoy agotando. Yo creo que el tiempo, nos quedan como 4 minutos, ¿verdad?
Nos quedan 4
Sí,
minutos.
sí. Ok, mi otra consulta, proyecciones. ¿Qué proyecciones tienes tú para la región desde la perspectiva de computación para incrementar el nivel de desarrollo de conocimiento y compartir entre la región y regiones diferentes actividades?
Yo creo que yo voy a destacar dos de las que tenemos aquí. Primero, con el clase 2025, empezar a hacer sinergia con el Technical Committee, que es un tema que nos falta mucho. Hay muchas comunidades técnicas como Quantum Computing, hay otras técnicas como ciberseguridad, privacidad, que no se conocen mucho en la región. Por lo tanto, hay que darla a conocer y con eso compartir con actividades mayores. Y empezó a trabajar en el aniversario de nuestra sociedad, que nosotros no celebramos nuestro propio aniversario, cumpleaños, que es lo que hace gente que lo hace, por ejemplo, WIE, lo hace Signal Process, lo hace PES, que tienen una celebración. Nos falta reconocernos nuestro trabajo y colaborar. Esas son como las misiones que yo veo que destaca esa pregunta.
Una consulta, Roberto, ¿inteligencia artificial está dentro del marco de computer? Ese sería
¿Correcto?
también otra sociedad, otro capítulo que hay como que ir moviendo también a nivel de la región.
Eso es correcto y eso hay que empezar a trabajarlo dentro de nuestra planificación para al siguiente año. Yo
Bueno,
creo que
yo creo,
para dar espacio a prepararse
sí,
bien
yo
el
creo que
equipo,
estamos bien. Sí,
sí,
estamos bien. Ok.
porque nos han dicho que los latinos somos súper buenos para pasarnos el tiempo, así que
No, no, yo
eh,
estoy viendo el reloj. Yo estoy viendo el reloj, yo estoy clarita, aquí estamos claros. Así que voy a agradecer tu tiempo, Roberto, y todo lo que has compartido con nosotros y le damos el paso a la siguiente sesión.
ok, muchas gracias.
¿Alguien va a introducir el tema o me arranco?
A ver, de momento parece que hubo un problema con
Sí,
el moderador. ¿Me
Roberto, si
apoyas?
quieres,
Ya,
déjame
perfecto.
buscar. ¿Ya llegó?
No, no llegó, así que
Ok.
en virtud del tiempo voy a apoyar yo en esto. Vamos a presentar a Pablo. Voy a pedir disculpas que siempre me cuesta el apellido.
Sí,
Ibargüen Coetía, que es CEO
correcto.
de Nakai Solution y es profesional investigador del Instituto Nacional de Electricidad y Energía Limpia de México. Él nos va, él nos va a presentar en este momento la experiencia de las conferencias de inteligencia artificial aplicada a la energía en América Latina, que es realmente un enfoque sumamente interesante en cuanto a lo que es el desarrollo de la inteligencia artificial. Muchas veces estamos acostumbrados a ver ChatGPT, OpenAI en el mercado, pero no, pero ver la aplicación en otros ámbitos que no son tan visibles como la generación eléctrica es un elemento importante a considerar. Especialmente por Pablo, que tiene experiencia harto tiempo en el Centro Nacional de Electricidad y Energías Limpias. Ya lleva 20 años en ello. En el, no, lo de vuelta son 35 años y 20 años en el ISTEM, Campus Cuernavaca, con el tema de sistemas, siendo profesor de la cátedra de sistemas inteligentes. Ha sido también director de tesis de los distintos programas de pregrado y posgrado, incluso de doctorado. Es senior member de IEEE y también es miembro de la Sociedad Mexicana de Inteligencia Artificial y de la Academia Mexicana de Ciencias de las Computación, de Ciencias de la Computación y la Academia de Ciencias del Estado de Morelos, México. Así sin más preámbulos, doy el pase al doctor Pablo para su presentación. Muchas gracias por su presencia acá.
Pues muchas gracias, Roberto. Muchas gracias, Donna, por la oportunidad. Es la segunda vez que me dan la oportunidad de compartir las experiencias que he tenido en el desarrollo de mi función como Distinguished Visitor. Voy a tratar de compartir mi pantalla. A ver, permítanme un momento, no soy muy hábil con esto. ¿Se ve la pantalla?
Sí, sí se ve.
Bueno, ¿cuánto tiempo dispongo? ¿Unos 50 minutos será?
Así es.
Bueno, vamos a comenzar. Como decía, muchas gracias por la oportunidad de compartir mis experiencias con las conferencias de inteligencia artificial aplicadas a energía que tuve oportunidad de dar en América Latina con mi nombramiento de Distinguished Visitor, sobre todo en el país de Ecuador, que también me han tratado y también me han consentido. Pude dar 2 años de seguidos conferencias en ese país. El contenido de la sesión de hoy es el siguiente. Vamos a ver el resumen de las conferencias que he dado en este periodo del 2022 a 2024. Termina mi nombramiento en este 2024 y pues di varias conferencias. En el año pasado participé con las conferencias que di al principio del nombramiento. Me voy a pasar más rapidito esos proyectos. Hablamos de diagnóstico de turbinas eólicas, hablamos también del sensor virtual de viscosidad de combustible para control de la combustión, hablamos de diagnóstico de transformadores eléctricos utilizando señales de vibración, pronóstico de potencia eólica, y el tema nuevo que no he compartido en estas sesiones es la gestión de presas del río Grijalva, y sobre un tema muy importante que debería ser muy observado en América Latina y en el mundo es la creación de microredes eléctricas inteligentes. ¿Por qué se llaman inteligentes? Y un tema de gestión de activos que también es muy importante en la operación de las industrias, de las empresas eléctricas. Bueno, comencemos con el diagnóstico de turbinas eólicas. En este proyecto, lo que nos interesaba mucho es poder hacer modelos del comportamiento. Entonces, teníamos que empezar definiendo qué es el comportamiento. El comportamiento es una combinación de valores, de variables de algún proceso. Es decir, ciertos rangos de valores de algunas variables son válidas en combinación con otras variables en algún proceso y eso formaría parte del comportamiento. Pero el comportamiento también se divide en diferentes contextos donde el comportamiento es diferente. Cierta combinación de valores es muy válida, muy recomendable en un contexto, pero no es muy buena en otro contexto. Entonces, lo que tratamos de hacer es generar un modelo del comportamiento para poder detectar desviaciones a ese comportamiento. Para tener un poco más claro, el comportamiento humano podemos tener los diferentes contextos, una fiesta familiar, un seminario académico como este, servicio religioso, un evento deportivo, y las variables que caracterizan el comportamiento, el tono de voz, contenido de la charla, vestido o atención. En una fiesta familiar, el tono de voz es escandaloso, el contenido de la charla puede ser chistes, anécdotas, vestido es informal y la atención dispersa. En un evento religioso, por ejemplo, el tono de voz es muy baja o permanecer callados. Contenido de la charla son rezos, el vestido es formal y la atención al oficiante. En un evento deportivo, el tono de voz es muy alta, animación al equipo, vestido deportivo y atención al cuerpo. Entonces, aquí lo que quiero decir es que las diferentes variables que me definen un comportamiento pueden ser diferentes en un contexto o en otro. En el caso de una turbina eólica, encontramos un comportamiento raro por una falla que se refería a fuga de aceite en rodamientos. El solo hecho de la fuga de aceite en rodamientos nos genera una medición de temperaturas anormal, que ya no es lo normal en el comportamiento, en el contexto que teníamos, probablemente unas señales de vibración también muy diferentes y unos señales de flujo de corriente o voltaje o alguna otra variable también de una manera muy anormal, muy inapropiada para ese contexto. Entonces, en el caso de las turbinas eólicas, lo que hicimos nosotros es proponer un modelo probabilista para la representación del comportamiento de los aerogeneradores. Y para eso utilizamos el razonamiento probabilista, usamos la técnica de las redes bayesianas para representar ese comportamiento. Y el comportamiento también, en este caso de las turbinas eólicas, se divide en contextos. Utilizamos los datos históricos del sistema escala del aerogenerador. En el instituto donde yo trabajé, teníamos un parquecito eólico en la zona de más viento de la República Mexicana, que es el Istmo de Tehuantepec, en los alrededores de la ciudad de Juchitán. Y tenemos una turbina eólica marca Comay de 300 kilowatts. Entonces obtuvimos datos de la escala del aerogenerador, de todas las variables que controla el aerogenerador, y creamos modelos probabilistas para cada contexto. ¿Cuáles son esos contextos? Para encontrar esos contextos tomamos dos variables, la velocidad del viento y la potencia generada. Lo metimos a un algoritmo de clustering, de agrupamiento de machine learning, y el sistema nos identificó estos 4 contextos en el comportamiento de la turbina. El primero es estos puntitos rojos, nos representa el rompimiento de la inercia. Empieza a acelerarse poco a poco. Luego el comienzo de una aceleración más o menos estable. El verde de otra aceleración más aplicada. Y estos puntitos representan el comportamiento de llegada a la potencia nominal y el codito que nos representaría la llegada a la potencia nominal. Entonces tomamos las redes bayesianas y aprendimos un modelo automático, un modelo de red bayesiana utilizando todas las variables y la red bayesiana, su característica es que nos da las relaciones probabilistas entre las diferentes variables. Y la definición de comportamiento también es la relación de valores de las diferentes variables. Por eso decidimos que las redes bayesianas era el método ideal para hacer modelos de comportamiento. Podemos aquí identificar algunas variables, la velocidad del rotor, la velocidad del generador, la señal de vibración 1, una señal de vibración 2, la dirección del viento y por aquí, ay, ya se me perdió. La potencia activa que estamos generando. Bueno, con este modelo aprendido de redes bayesianas, creamos un sistema computacional llamado el sistema de diagnóstico, que si lo alimentamos con un modelo de red bayesiana del contexto y del comportamiento de la turbina, y con otro modelo que es fuera de la atención de esta charla, si quieren les doy más información más adelante, creamos el sistema de diagnóstico que recibe información en tiempo real y nos presenta la probabilidad de comportamiento anormal de algunas de las variables. En este diagramita tenemos una variable que presenta una mitad de comportamiento anormal, otra variable que presenta un comportamiento ciertamente anormal, un 1% de probabilidad de falla, y las demás, de todas las que vimos en la red bayesiana, están en 0. Entonces se podía considerar como glitchitos anormales y el sistema está comportándose correctamente. Este fue un sistema novedoso para el diagnóstico de turbinas eólicas que no requiere datos de fallas, es decir, podemos identificar el modelo de la turbina trabajando correctamente y detectar desviaciones a ese comportamiento. No necesitamos un modelo de la turbina en presencia de fallas. Y replicar este proyecto es sencillo porque se puede obtener el modelo de otras turbinas con datos históricos. Presentamos los resultados en esta publicación que se ve aquí hacia abajo. Bueno, rápidamente el sensor virtual de viscosidad. Resulta que hay 3 formas de medir la viscosidad de combustible en centrales termoeléctricas. El primero es un método manual a través de muestras tomadas y analizadas en laboratorio en equipos como este, que me dice cuál es la viscosidad que tiene el tanque del día. Hay otra forma y es la utilización de viscosímetros. Este es un aparato, un instrumento viscosímetro físico en línea, pero resulta que estos viscosímetros son muy caros, muy difíciles de calibrar y se descomponen muy rápido. Entonces, casi ninguna planta, al menos de las que yo pregunté en México, tenía viscosímetros físicos en línea y lo hacen de alguna otra manera. Entonces, para eso propusimos un sensor virtual de viscosidad. ¿Qué es un sensor virtual? Bueno, es un sistema que si sacamos el modelo de las variables que se relacionan en la combustión de combustible, podemos aprender ese modelo e inferir la medición de la viscosidad del combustible en tiempo real. Pero ¿cuál es el problema en las centrales? Las calderas de las centrales queman el combustóleo en unos aditamentos que tienen las calderas que se llaman los quemadores. El combustible se atomiza al entrar a los quemadores, en los quemadores. Estos quemadores utilizan una viscosidad oficial, es decir, el fabricante nos debe de decir qué viscosidad debe de tener el combustible para ser atomizado correctamente en el quemador de la caldera. Pero si resulta que si la gota es grande, no se atomiza correctamente y la gota es grande, no se quema toda y se generan residuos contaminantes. Si la gota es pequeña, tampoco se aprovecha el poder calorífico y también se genera contaminación. Entonces, una atomización adecuada genera una combustión adecuada con una mínima contaminación. La viscosidad del combustible depende de sus características químicas. Entonces, en el instituto donde yo trabajé, tomábamos muestras de todas las combinaciones de combustibles que compraba la Comisión Federal de Electricidad y graficaron estas curvas que relacionan la temperatura con la viscosidad. A la operación normal del sensor virtual de viscosidad, tomábamos con el viscosímetro en línea, tomábamos a cuál de esas líneas, entre cuál de esas líneas estaba la línea del combustible actual. Si lo graficamos en papel logarítmico, nos resultan unas curvas, unas rectas, donde podemos identificar cuál es la temperatura actual y entonces podemos identificar cuál es la viscosidad actual, pero también sabemos cuál es la viscosidad meta, entonces sabríamos cuál es la temperatura meta, y entonces movemos la temperatura en el calentador del combustible para llevar a esta temperatura, que sería llevar la viscosidad ideal para la combustión. Entonces, tomando señales del sensor físico y otros procesos y otras variables del proceso, creamos una base de datos con aprendizaje, un programa de aprendizaje automático de esos datos, creamos un modelo probabilista, que este es el modelo probabilista. Pueden ver aquí la variable viscosidad, la temperatura del boiler, la relación aire-combustible, el flujo de combustible, etcétera. Fueron las variables que nuestros expertos en combustión nos dijeron que eran las apropiadas para poder hacer una inferencia de la viscosidad, dadas todas las demás variables en algún momento. Entonces, creamos un programa computacional que llamamos sensor virtual de viscosidad, que alimentado con el modelo que recién aprendimos, alimentado con datos en tiempo real de esas variables que participan en la combustión, nos saca una estimación de la viscosidad en línea. Aquí les presento una gráfica con los resultados. Es la gráfica, tengo que confesar, de las más bonitas que salieron. La gráfica roja nos presenta la viscosidad estimada con el sensor virtual de viscosidad. La verdecita es la leída en el viscosímetro. Y la gráfica azul es el error. Como ven, son errores menos del 5%, salvo ciertos piquitos que hay. Bueno, el prototipo de sensor virtual de viscosidad se instaló en la unidad 2 de la Central Termoeléctrica de Comisión Federal de Electricidad en la ciudad de Tuxpan, Veracruz. Hicimos un par de artículos muy interesantes en revistas de altísimo nivel. Bueno, tercer proyecto, que también me voy rápido para poder ver los proyectos nuevos que no han sido comentados, es el pronóstico de potencia eólica. Para pronóstico de viento, contamos con datos históricos de años de la velocidad del viento y de la dirección del viento, junto con otras variables meteorológicas. Estas variables estaban en una estación meteorológica ahí mismo en nuestro parquecito eólico del estado de Oaxaca. Además de la dirección del viento y la velocidad del viento, tomamos muchas mediciones de 3, 4 años de la temperatura ambiente, de la presión atmosférica, de la humedad relativa y de la radiación solar. Con estas 6 variables hicimos el pronóstico del viento, de la velocidad del viento. Pero ¿para qué me sirve la velocidad del viento? Pronosticar la velocidad del viento, porque con la curva de potencia que es una curva que relaciona la velocidad del viento con la potencia generada. Esta es una curva de potencia que debe proporcionar el fabricante de la turbina eólica. Entonces, este es un ejemplo de una curva de potencia que si pronosticamos la velocidad del viento, podemos pronosticar la potencia generada. Entonces, dada la curva de potencia, dado el pronóstico de velocidad del viento, podemos pronosticar directamente lo que es la potencia. Bueno, el pronóstico, el poder inferir una variable dentro de unos instantes de tiempo adelante, significa que el tiempo tiene que estar participando en nuestros modelos probabilistas. Y entonces, para poder incluir al tiempo, estudiamos la forma de creación redes bayesianas dinámicas. Las redes bayesianas dinámicas nos relacionan 2 periodos de tiempo, el periodo 0 y el periodo 1, y lo metemos a un programa de aprendizaje de modelos para que nos genere esto que se llama el modelo de transición, que nos relaciona un instante de tiempo con el siguiente. Por supuesto que hacemos la suposición de que el sistema es markoviano, es decir, el pronóstico de viento o de todas estas variables depende del instante anterior, nada más. Hacemos esa suposición para que no se complique mucho la computación y que sea muy tratable el proyecto. Entonces, identificando el modelo de transición, nos damos cuenta, por ejemplo, presión atmosférica depende de la presión atmosférica anterior, por supuesto, y de la radiación solar anterior. La radiación solar actual depende de la potencia de la presión atmosférica anterior y de la radiación solar actual, y también tiene inferencia con la humedad relativa en el mismo momento. Entonces, aprendimos este modelo de transición que nos representa, como ya les comentaba, 2 instantes de tiempo, y lo que tenemos que hacer para trabajar con más instantes de tiempo hacia adelante es desdoblar el modelo de transición, desdoblarlo tantas etapas como fuera necesario. Entonces, para hacer un pronóstico de 5 horas adelante, hicimos este desdoblamiento de la red bayesiana dinámica para 5 horas adelante, de manera que en cierto momento tomamos la medición de las variables meteorológicas en el tiempo 0 y podemos identificar o inferir el valor de las variables meteorológicas 5 horas adelante. Por supuesto, el lapso de tiempo, el espacio de tiempo es de 1 hora. Entonces, hicimos este pronóstico de potencia a 5 horas adelante y sacamos estos resultados, la velocidad del viento y en el tiempo, y vemos que la gráfica roja es la velocidad del viento medida en la estación meteorológica y la gráfica azul es la medida de lo que nosotros pronosticamos. Como ven, hay un acercamiento bastante apropiado. Pero resulta, nuestros clientes nos dijeron que no les interesa tanto saber exactamente cuál es el pronóstico de potencia, sino más bien que les podamos asegurar con un 80% de probabilidad cuál es el rango de potencia que vamos a poder disponer. Así, nuestros clientes son los generadores de energía y que tienen que estar seguros de cuánta energía pueden ofrecer a sus clientes. Entonces, en este caso, el 80% de probabilidades de que la energía puede estar entre estos dos puntos. Y ya con eso las compañías pueden tener una idea. Aquí está mucho más cerrado el pronóstico con las ideas. Realizamos pruebas en el CERTE, en nuestro campo eólico del instituto, y tuvimos la oportunidad de hacer unas pruebas en las Islas Galápagos, en el Ecuador. Era un proyecto trabajando con una organización ecuatoriana y tuvimos la oportunidad de viajar a las Islas Galápagos para probarlo en una turbina eólica que tienen allá. Y estamos trabajando en un modelo de 24 a 36 horas basado en incorporar de otras zonas geográficas y extendemos nuestra técnica ya teniendo un sistema de pronóstico utilizando técnicas de inteligencia artificial. Bien podemos extender esas técnicas de pronóstico a otros temas como energía fotovoltaica, pronóstico de lluvias, consumo eléctrico, etcétera. Estas técnicas de pronóstico utilizando técnicas de inteligencia artificial. Siguiente proyecto es diagnóstico de transformadores. Como ven, son transformadores grandes y se propuso obtener modelos de vibración del transformador operando correctamente. Aquí también empezamos otra vez a trabajar con el concepto del comportamiento normal. Entonces, nos dieron la oportunidad de irnos a una fábrica de transformadores en la ciudad de Monterrey, Nuevo León. Es la compañía Prolec General Electric. Dicen ellos que es la fábrica de transformadores más grande de toda América continente. Entonces están constantemente sacando transformadores en la línea de producción. Entonces nos dieron la oportunidad de ir a probar, de ir a checar las señales de vibración del transformador operando correctamente. Aquí se pueden ver estos puntitos negros, son los sensores de vibración. Estos cables blancos son las señales donde íbamos al sistema de adquisición de sensores. Utilizamos 8 sensores de vibración por cada uno de estos. De los transformadores, medimos 5 transformadores similares y pusimos el transformador a operar con diferentes condiciones de operación. Aquí tenemos un ejemplo. Cada experimento tomábamos 10 mediciones. Este es un transformador caliente a diferentes corrientes, excitado nada más con corriente, y era un cierto porcentaje, creo que son, no me acuerdo bien la cantidad, disculpen ustedes, 30%, 60, 90 y 100% de la corriente nominal, y veíamos con perdón, eso no lo comenté, pero las señales de vibración las transformábamos con la transformada discreta de Fourier. Y entonces lo que estamos haciendo es trabajar con las amplitudes de los componentes de las diferentes frecuencias que tiene la señal de vibración. Y obviamente se imaginarán que si la estamos excitando con una señal a 60 Hz, como es como opera la energía en casi toda América Latina, si no es que en toda América, entonces las señales, los componentes de otras señales son múltiplos de 60 Hz. Y en realidad lo que vimos fue que son múltiplos dobles de 60 Hz las señales que más están participando en la variación o en la generación del comportamiento. Aquí vemos la señal de 120 Hz, la azul, y la señal de 240 Hz, en el sensor 2. Me voy a saltar esto por tiempo. Así encontramos diferentes condiciones de operación, diferentes experimentos, excitado con corriente, excitado con voltaje. Hicimos unos pequeños modelos básicos por sensor. Utilizábamos el sensor, la medición de 60 Hz, de 120, 180, etcétera, a diferentes condiciones de operación, del sensor 1, del sensor 2, lo mismo, modelos por frecuencia, del sensor 1, del sensor 2, del sensor 3, etcétera, a 120 Hz y a 240 Hz. Con estas señales, con estos modelitos, logramos hacer la inferencia de leer la vibración del transformador en tiempo real, y hicimos un sistema de fusión de información que nos indica cuáles de esos sensores, de esas frecuencias se está trabajando correctamente, y da una idea de que el transformador está operando correctamente. Descubrimos que el comportamiento se podía, como les comenté hace un momento, caracterizar simplemente con 120 y 240 Hz, lo cual nos facilitó un poco el trabajo. También tuvimos aquí la publicación que hicimos en la reunión de transmisión y distribución de la Sociedad de Potencia. Bien, esos fueron los primeros 4 proyectos que tuvimos la oportunidad de compartir, y los que siguen son los proyectos que tuvimos la oportunidad de compartir en la segunda fase de mi nombramiento como DV. El primero es el sistema de gestión del río Grijalva. El río Grijalva, como pueden ver aquí, es un río que está cerca de la frontera con Guatemala, en la parte sur del país. Y lo interesante de este río Grijalva es que se tienen 4 presas: la presa de Angostura, la presa de Chicoacén, la presa del Malpaso y en realidad la presa de Peñitas. Este es otra que medio la consideran presa, pero no hay nada de instrumentación. Entonces consideramos la presa de Peñitas, están a estas distancias. Y lo interesante de esto es que se tiene que hacer un control de las aguas que vienen desde aguas arriba, desde la presa de Angostura hasta hacia abajo, porque aquí se desenfoga al Golfo de México, pero antes está la ciudad de Villahermosa en el estado de Tabasco. Entonces, cualquier problema que pueda haber con un mal control de aguas, podemos tener problemas en la ciudad de Villahermosa, como podemos comentar dentro de un momento. Entonces, ¿cuál es el problema? Si tuviéramos un embalse que se utiliza únicamente para la producción de energía eléctrica o nada más para el suministro de agua, es mejor mantenerlo lleno. Siempre tenerlo lo más lleno posible, considerando las lluvias que puedan llegar, de manera que podemos hacer la generación sin ningún problema o propiciar la alimentación de aguas abajo. Si el embalse únicamente se utiliza para el control de aguas abajo, es mejor mantenerlo relativamente vacío para no tener problemas de perder el control de aguas abajo. Pero si los embalses se utilizan para ambos fines, genera conflicto sobre la cantidad de agua que se debe almacenar y su operación. Entonces, el problema es que se requiere asegurar la generación eléctrica esperada, pues es una fuente de energía limpia, gratuita. Bueno, ya que se hizo la inversión, es una energía gratuita. Y en época de secas bajan los niveles de las presas y requerimos conservar cierto nivel de agua para privilegiar la generación. Precisamente cabe el comentario aquí sobre lo que están sufriendo ahorita nuestros hermanos del Ecuador, que la mayoría de su generación es hidroeléctrica y han tenido una sequía de años, entonces sus presas están muy bajas y han tenido que hacer esos cortes de alimentación tan fuertes que tienen actualmente. 10 horas de corte de energía en 2 periodos de 5 horas. Eso es terrible. Pero bueno, eso es cuestión de las lluvias. Pero donde sí llueve o en época de lluvias, debemos sospechar o estimar cuánta agua caerá en cada presa para lograr proyectar el nivel óptimo para generar y desfogar lo sobrante. Si nosotros antes de lluvias mantenemos el nivel un poco alto porque sospechamos que va a llover mucho y no llueve lo suficiente, entonces se quedan los niveles con no tan altos y entonces no vamos a tener en época de secas la generación eléctrica esperada. Pero si tenemos un nivel estimado y llueve más, entonces la generación se genera, logramos la generación, pero también tenemos que desfogar para no elevar los niveles de presas. Resulta que en el año 2010 se decidió inundar la ciudad de Villahermosa, Tabasco, como la opción menos catastrófica. Imagínense cuál sería la situación, que se sospechaba que no iba a llover, que dejaron los niveles altos, que llovió más de lo esperado y entonces tenían problemas de sobrecupo de agua en las presas y todas las presas, desde la presa de Angostura, tenía que desaguar, generando electricidad ciertamente, pero desaguar lo sobrante a la de abajo y así sucesivamente, y se decidió inundar la ciudad de Villahermosa como la opción menos catastrófica. Imagínense cuál pudo haber sido las otras opciones catastróficas. Entonces, lo que se utiliza es una técnica de inteligencia artificial para tomar decisiones que se llama los procesos de decisión de Markov. Para utilizar estos procesos de decisión de Markov, necesitamos que nuestro sistema, nuestro problema, nuestro proceso se pueda representar mediante esta tupla de 4 diferentes conjuntos. Un conjunto S, que sería un conjunto de estados, que podamos representar el problema o la situación del proceso en estados bien identificados y bien definidos. Si podemos identificar ese conjunto de estados, luego identificar un conjunto A de acciones que se pueden realizar en esos estados. Entonces, en cada estado podemos realizar una acción y el siguiente conjunto que necesitamos es una función de transición de estados T. Es decir, la probabilidad de llegar a un estado S', dado que estamos en el estado S y se realiza o se solicita la acción A. Entonces, tenemos que identificar estas probabilidades de estando en un estado S, realizando las diferentes acciones, qué probabilidad hay que alcancemos a los diferentes estados circunvecinos. Y última parte de la tupla es una función de recompensa que asignamos al alcanzar cierto estado. Y entonces lo que vamos a calcular con este tema de los procesos de decisión de Markov es una política específica que es las acciones que se deben de realizar en cada estado después de haber hecho el procesamiento atrás, fuera de línea. Entonces, déjenme explicar rápidamente qué es un modelo de decisión de Markov. Si deseamos, podemos identificar nuestro proceso como un conjunto de estados finitos. Aquí lo vemos como estos cuadritos. Tenemos unos estados imposibles que no pueden estar, como este morado. Tenemos estados que sí podríamos llegar, pero altamente indeseables, que lo marcamos con esta forma. Y estados meta o estados goal, estados que sí debemos de llegar o sí debemos de alcanzar. Entonces, estas son un esquema de juguete, digamos, de laboratorio, de académico, para explicar los procesos de decisión de Markov, el diagrama de estados, y las acciones que puede hacer es subir, bajar el robot a la derecha o a la izquierda. Y el modelo de transición es este. Si yo le pido sube arriba, subir para arriba, valga la redundancia, al robot, hay un 80% de probabilidades de que el robot va a acabar en este otro estado. Hay un 10% de probabilidades que por alguna falla, algún problema en la transmisión del robot va a acabar en este, y un 10% que va a acabar en el mismo lugar. Entonces tenemos que conseguir esa matriz de probabilidades condicionales de qué probabilidad hay para acabar en los estados vecinos, dada la acción que nos está pidiendo el robot. La función de recompensa son la recompensa que podemos tener al llegar a cada uno de los estados. Como vemos, aquí hay una recompensa fuertemente -1, una recompensa altamente deseada de +1, y los demás estados tenemos una pequeña recompensa de -1, un 25avo. Entonces, esas son las funciones de recompensa, la matriz de transición, y lo que generamos es una política. Lo que nos dice este diagrama es, estando en cuál estado, qué acción debemos realizar desde un estado de inicio. Si estuviéramos en este estado de inicio, lo que nos dice es toma hacia la izquierda, hacia la izquierda, hacia la izquierda, sube, 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 y derecha, 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 ahí hasta llegar a este estado ideal. Yo no sé por qué en este ejemplo no tomó este atajo, por alguna razón, debe de haber alguna razón, pero eso es lo que se genera una política. Son las acciones que le debemos de pedir al sistema en cada uno de los estados. Bueno, entendiendo lo que son estos procesos de decisión de Markov, volvamos a nuestro ejemplo de las presas. Lo podemos representar con esta forma a una sola presa, un repositorio donde tenemos discretizado los diferentes niveles, el nivel rojo, naranja, verde o azul, el nivel. Simulamos una válvula de entrada, una válvula 0, simulamos una entrada de agua con lluvia en la presa, y modelamos dos válvulas de salida, una válvula B1 que va a las turbinas de generación de potencia y una válvula B2 que va al desfogue de agua para lanzar aguas abajo. Entonces, esto es el sistema de una sola presa. La lluvia la identificamos, la discretizamos en 3 niveles: no hay lluvia, o hay lluvia moderada, o hay una lluvia fuerte. El nivel depende de la unidad de flujo de lluvia en metros cúbicos por segundo, la superficie del depósito en metros cuadrados y el periodo de tiempo. Eso nos da el nivel. En realidad, esto es el modelo de una sola presa. El primer resultado que tuvimos fue para una sola presa, modelar el sistema de decisión de Markov para una sola presa, y el reto sigue siendo modelar para las 4 presas que tenemos en el río Grijalva. El problema es cómo construir una política de operación óptima de cada presa, pero que me genere los beneficios del sistema completo del río Grijalva. Entonces, falta decir cuáles son los estados. Los estados los codificamos de esta manera. Los diferentes niveles, veíamos el nivel rojo, naranja, verde y azul, lo separamos en 2 niveles, y entonces tenemos 8 diferentes niveles que puede tener nuestra presa, y 3 diferentes caracterizaciones de la lluvia que puede estar cayendo en ese momento. Entonces, el estado 1 es no lluvia y el nivel más bajo. El estado 12 es lluvia moderada, con el nivel de la presa en la región verde, la parte de arriba, y el estado 24 es lluvia intensa y estamos con el nivel lo más alto posible. Entonces, teniendo estos espacios identificados, cuáles son los espacios que mi sistema puede tener, cuáles son las acciones que puede realizar, y aquí codificamos 8 diferentes acciones. La acción 1 es cerrar válvula B0, cerrar válvula B1 y cerrar válvula B2. Todo cerrado, no se mueve nada. El nivel A5, por ejemplo, la acción A5 es abrir válvula 0, cerrar válvula 1 y cerrar válvula 2. Entonces, con estas acciones, metimos este sistema al procesamiento del proceso de decisión de Markov y nos generó estos resultados experimentales. Esto es el proceso, la función de recompensa que tenemos en cada uno de los estados y las acciones que se debe realizar en cada uno de los estados. Como pueden ver, el estado meta es este, y aquí es el que tiene el mayor valor de recompensa, 771 punto y cacho, el mayor valor de recompensa, y se debe realizar la acción 1. La acción 1 es, no te muevas, todos estamos contentos, permanece en este estado. Pero si tenemos, por ejemplo, estas son la política en flechitas, si tenemos, por ejemplo, este estado, lo que nos dice es baja lo más rápido posible, baja, y eventualmente llegamos al estado meta. Son resultados experimentales, es difícil notar aquí los valores de la política, pero estamos bueno, se quedaron mis compañeros haciendo el proceso para identificar un proceso de decisión de Markov en las cuatro presas del río Grijalva. Es un problema muy interesante y es muy complejo de revisar. Para empezar, estamos discretizando la variable lluvia en solo 3 estados y a lo mejor se necesitan muchos más. Bueno, entonces ese proyecto sigue en pie, muy interesante, de la gestión del río Grijalva. Siguiente proyecto, la operación de microredes eléctricas inteligentes, llamados microgrid, y son inteligentes por lo que vamos a ver adelantito. ¿Cuál es el problema o cuál es el asunto con estas microredes eléctricas inteligentes? El problema o la idea es que el esquema normal que ha tenido el mundo para su generación de electricidad es tener gigantescas plantas de generación masiva de energía en enormes estaciones y solo transmitir la energía hacia los centros de consumo. Esto puede ser a veces costoso, por ejemplo, recordar el mapa de la República Mexicana, la gran energía que genera el río Grijalva, llevarla a otras partes del país, pues es muy complicado. Y eso ha sido un esquema mundial que ha sido grandes centrales generadoras, grandes líneas de transmisión que mueven la energía y llevarlas a los grandes centros de consumo que pueden estar a muchos kilómetros de distancia. Entonces, una alternativa que se proponen es la creación de microredes eléctricas inteligentes. Las microredes eléctricas inteligentes tienen básicamente estos componentes. En primer lugar, se precisa que tengan generación renovable, necesariamente generación renovable como paneles solares, como turbinas eólicas. Entonces, como sabemos que las fuentes renovables son intermitentes, necesitamos también dispositivos de almacenamiento que puedan almacenar grandes cantidades de energía. Y tenemos los centros de consumo que puedan tener también su generación, pero en general son diferentes prioridades a los centros de consumo. Y en algunos casos se puede tener sistemas de conexión a la red eléctrica nacional. En otros casos, no hay opción de tener conexión a la red y tendríamos que tener aquí alguna forma de tener energía controlable de alguna manera. Este es un esquema eléctrico donde podemos ver microcontroladores controlando cada una de las centralitas generadoras, de las centrales generadoras, y aquí el control para la toma de energía de la red. Entonces, los elementos, como ya comentamos, deben de ser paneles solares, turbinas eólicas, fuentes controlables que bien podrían ser máquinas diésel que trabajaran de una forma cuando no hay más remedio si no hay energía, y baterías, Ah, y por supuesto, las cargas eléctricas. Entonces, ¿cuál es la tarea de la inteligencia artificial en este caso? Bueno, cada generador tiene su controlador que actúa independiente. El controlador para las centrales fotovoltaicas, el generador para las turbinas eólicas, y además existe un controlador central que ajusta o que actúa con los controladores de los generadores para asegurar voltaje y frecuencia específico en las cargas eléctricas y garantizar la optimización de la energía en la microred eléctrica inteligente.
Esto nos queda unos
Un
minutos,
módulo de
claro.
gestión de energía que asegura potencia a las cargas, proporciona puntos de referencia a los microcontroladores, y aquí lo importante es esta política de que si no tenemos energía suficiente, ¿quién debe recibir esa energía? Por supuesto, hospitales y centros indispensables de consumo que deban de estar trabajando. Podríamos hacer pequeños cortes a otros consumidores que no requieran con urgencia la energía, y también decidir cuándo almacenar energía. Entonces, se trata de priorizar energía limpia a su máximo desempeño. Si nos está sobrando energía, mandarla a las baterías. Si nos está faltando energía y tenemos en las baterías, podemos tomar un poco de las baterías para priorizar. Si no tenemos nada de energía renovable ni baterías, entonces sí tendríamos que hacer uso de la máquina de diésel o la conexión a la energía de fuera, a la acción con la red local. Hay un módulo de coordinación. Hay un módulo de coordinación de protección que usa las estrategias de interrupción de carga y planeación de carga mediante la gestión de demanda, combinando con dispositivos de almacenamiento y para mantener la potencia y el voltaje. La realización de control de potencia y activa de los generadores y permitir el cambio a modo de energía controlable. Las técnicas de inteligencia artificial que usamos para las tareas que se realizan en una microred eléctrica inteligente es para pronóstico, las redes neuronales o las redes bayesianas. Para las funciones de optimización son los algoritmos genéticos o las redes neuronales o los algoritmos de búsqueda. Para los sistemas de control podemos tener redes neurodifusos, y para la toma de decisiones los podemos usar modelos de decisión de Markov o redes bayesianas y diagramas de influencia. Entonces, son estas técnicas, diferentes técnicas de inteligencia artificial que se pueden realizar para las acciones de control óptimo de la microred eléctrica inteligente y poder utilizar estas pequeñas células que pueden ser fraccionamientos, pueden ser colonias, pueden ser comunidades alejadas a las redes, pueden ser diferentes esquemas que utilicen estas microredes eléctricas inteligentes. Quiero comentar que en la Universidad de Cuenca, donde estuvimos en octubre pasado, tienen un magnífico laboratorio de microredes eléctricas inteligentes. Me atrevo a ofrecerlo si me está oyendo alguien de hermanos ecuatorianos de la Universidad de Cuenca, y ustedes me dirán si es apropiado, pero yo los invito a que consulten esa microred para los que quieran hacer algún experimento o alguna técnica, algún uso de ese magnífico laboratorio de microredes eléctricas inteligentes. Me decían, ¿qué nos recomiendas? Les decía yo, pues todos los doctorados, o bueno, no todos, pero muchos de los doctorados en ciencias de la computación en inteligencia artificial que quieran hacer tesis, deberían venirse a hacer aquí con ustedes para planear cuáles son esas técnicas, esas políticas adecuadas para el buen funcionamiento de la red eléctrica inteligente. Gestión de activos.
Doctor, estamos en la hora.
¿Perdón?
Estamos ya en el tiempo, nos queda 3 minutos.
3 minutos. Entonces me brinco la gestión de activos, que es una forma un poco más administrativa, y las técnicas de inteligencia artificial, problemas de resolver con inteligencia artificial, son otros problemas que se están identificando, otros retos, y permítanme pasar, no puse filmina de conclusiones, pero las conclusiones son estas. El sector eléctrico está lleno de aplicaciones posibles de la inteligencia artificial. Hay muchas cosas que se pueden hacer. El moderador hablaba, Roberto hablaba al principio de la sesión de ChatGPT y esas nuevas técnicas de inteligencia artificial. Esas son las nuevas para otro tipo de actividades. Las que tenemos, las técnicas tradicionales de inteligencia artificial, son buenas candidatas para arreglar muchos de los problemas que se presentan en la industria eléctrica. La industria eléctrica también tiene una muy buena adquisición de datos. Casi todos los procesos de la industria eléctrica están adquiriendo datos, y con todos esos datos que podemos encontrar, podemos hacer modelos para extraer conocimiento, para extraer modelos y poder tener sistemas inteligentes que resuelvan algún problema. Entonces, la recomendación es juntar datos de algún proceso, de alguna aplicación, como teníamos los datos de la turbina eólica, y hacer modelos que nos resuelvan algún problema. Y pues entonces con eso termino, y estaré feliz de responder algunas preguntas si existen. Muchas gracias.
Muchas gracias, doctor Pablo. ¿Alguna consulta del público? Mientras la esperamos, me gustaría hacer una consulta, ya que como comentó al comienzo, ¿qué es lo que usted rescata a título personal de su experiencia como Distinguished Visitor todos estos años?
Para mí ha sido una de las experiencias más agradables que he tenido en mi vida, sobre todo porque se coincidió con mi jubilación del Instituto de Investigaciones Eléctricas. Entonces, mantenerme ocupado y poder transmitir mis conocimientos a mucha gente de toda nuestra América Latina ha sido una de las satisfacciones más grandes. He tenido muchas conferencias, muchas han sido en línea, que me ha dado mucho gusto transmitir mis conocimientos en línea, aquí muy sentado muy cómodamente en mi casa, como en esta ocasión, pero he tenido oportunidad de viajar y ha sido experiencias importantísimas de platicar cara a cara con estudiantes, con profesionistas, con gente que tiene diferentes intereses. Algunos coinciden con los temas que yo estoy proporcionando, y tenemos unas charlas, sobre todo a la hora del café, muy interesantes. Ha sido para mí, como decía, una de las experiencias más agradables en mi vida profesional, poder haber podido tener esta oportunidad de viajar a América Latina y poder dar conferencias sobre pues mis proyectos. Los primeros proyectos fui yo directamente el jefe de esos proyectos. Los siguientes yo participé de alguna forma en esos proyectos, y pues reconozco la importancia del uso de inteligencia artificial en el sector de energía.
Genial. Y llega una pregunta de Eric Castellano. En ese contexto, ¿es seguro que la inteligencia artificial tomará decisiones automáticamente en el caso de inundación, por ejemplo?
Bueno, lo que hace es sistema de recomendaciones. Hace un sistema de recomendaciones para que los humanos sean los que tomen la decisión final y la actúen. En este caso, yo pienso que con todos los datos, los cálculos, el estudio de probabilidades y todo eso, los humanos deben de tomar Muy en consideración las recomendaciones que le haga este sistema de procesos de decisión de Markov para que puedan ellos tomar la decisión final. En algunos otros procesos sí el sistema inteligente puede tomar la decisión final y actuar en consecuencia para realizar todas las acciones.
Ok, muchísimas gracias, doctor. Ha
A ver,
sido un placer poder compartir esta experiencia y estar aquí con ustedes en la presentación. Así que le damos
sí,
la... ¿Mm?
voy
¿Diga?
a tratar permítanme,
A ver. ¿Esto?
ay,
Ahí sí.
qué bueno, no lograba yo
No,
quitarme eso.
no se preocupe, para eso estamos.
Muchas
Muchísimas gracias
gracias.
por todo. Así que un gusto. Ahora, siguiendo la presentación, voy a dar el paso a la siguiente moderadora, que es Vanessa Castillo. Ella es estudiante de Ingeniería Civil en Ciencia de la Computación, también el actual chair de la rama estudiantil de la Universidad de Tarapacá en Chile y ganadora del premio de la beca de escolaridad internacional de Santander, además del premio Woman Society University, estando a la par con el título del mejor tutor del 2023. Así que le doy un pase a Vanessa para que presente el siguiente expositor.
Gracias, Roberto. ¿Se me escucha bien?
Sí.
Sí, sí. Genial. Hola a todos los presentes, espero que estén disfrutando este grandioso evento. A continuación, les voy a presentar al coordinador general del Congreso Latinoamericano de Estudiantes y Jóvenes Profesionales de Computer Sociality. También es el vicepresidente de Computer Sociality del Instituto Tecnológico de Morelia y también es el representante estudiantil de México. Bueno, a continuación les dejo con Cristian Rojas.
¿Qué tal? ¿Se me escucha bien? Hello, everybody. Can you hear me? Yes. Vanessa, could you
Sí,
show the presentation, please?
yes.
So we are going to have a small break, guys, from the technical talks. We're going to have a small chat presented by IEEE Computer Society, students and young professionals from our region, that is Region 9. This presentation was made by our team. Vani, please, next slide, please. So who are we? We are Region 9. We are Latin America. So it covers all of the countries in Latin America. That means from Chile through Mexico, including all of the islands of the Caribbean. And we are an estimated 2,937 members, which 1,123 are professional members and 1,814 are students. So as we can see, most of us are students. Next slide, please. As our continent is really big, as you guys may know, we are actually divided into three small countries like South America, North America, and Central America. We internally are divided, well, I mean internally in computer society, of course, we are divided in four main areas. This because we want to have better organization and we have to complete some goals through the year. So for this year, we have an amazing team that is composed by these people on this slide. And well, we are, as you can see, we are 2 people for each area. One is a professional, and the second one is a student. So we complement each other in order to achieve our goals. And that's exactly what I'm going to present right now. Please, next slide, Vani. So in area 1, we have Mexico. So that's why we are going to start with that. What did we do in Latin America? As in many regions, we do almost the same, but with slight modifications. For example, in Mexico, we promote the national programming competitions and the social activities. Next slide, please. We promote sports, such as swimming competitions and camping. Next slide, please. Area 2, we got a small example with Panama, because Area 2 is integrated by Capana. That means Central America and the islands, of course. So here we can see something interesting. Here we can see that we approach activities with the professionals, right? As I said at the beginning, we are connected with them because students are the future of computer society. That's the reason why the professionals are our leaders and our main connection. Next slide, please. We have area 3 that its members are from Cono Sur and the south of South America. We have here an example with Argentina. As everybody does, we also celebrate IEEE Day, but we also have our IEEE Computer Society Day, that it is not official date, but we kind of celebrate it in September. Please, Bunny, next slide. We have the 4th area that it's, oh no, excuse me, this is also part of area 3, if I'm not mistaken. We have another country that it's Peru. So we have some contests that the students do in order to improve their skills, such as design web page contests, social meetings, as we can see, and of course some courses, right? Because if we don't have courses, we are not able to improve our skills, of course. So we promote the courses, we promote social meetings, we promote competitions, right, as everybody else. But what is the main difference? We're going to see it. Please, the next slide. The next area is Brazil. So in each area, we have a small team. In this slide, we can see the team, the Brazil team for this year. Our goal in each area is it's not only to have more members, but to promote leaders for the next generation, right? Leaders that can innovate the technology, that can innovate the way that things are doing, and to innovate our region, therefore the world. Next slide, please. In Brazil, they have, as we do, of course, in Mexico, technical talks. And well, these are more small examples. In the left, we can see a technical talk that was promoted by students. And on the right, technical talk promoted by professionals. Next slide, please. So now we are going to cover the main difference of our region. That means that we do international collaborations. We promote them, we try to do them, and we do them, not just trying, right? So, for example, here we have a flyer of a international collaboration made at the beginning of this year. That was a virtual one, but we can see that we have different countries over there. Next slide, please. In Computer Society Region 9, we also have Computer Society Diversity and Inclusion, in which we also promote international collaborations, as we can see in this slide. We don't need to be in one place, physical. That's why we do it virtually. In each session, we have more than 500 attendees, and that's a major advance, right? So next slide, please. So we do also some important activities that can reach, I better say, reach other countries, such as Cloud Bootcamp Colombia. Well, this project was developed within the Colombian section with the support from Computer Society, students and young professionals, TechX. Bootcamp Colombia, what is that? This event aimed to develop the region's cloud computing skills, and AI, right? Such as Microsoft Azure, Power Platforms, and other technologies. So they went from city to city, in which they promoted the skills necessary to have a better future in these fields. Next slide, please. And we can see here the number of attendees. Next slide, please. We have, yes, thanks. The TechX Latam project, also it was made in Colombia, but also reached all of our region, or I mean all of Latin America. This project represented a highly relevant initiative in the academic of competitive programming in Latin America. So that means that we have here some teachers, we can say some teachers that lead us or pass their experience to us, so we can have a improvement in our programming skills for future competitions, right? As we all know, there is a main competition, IEEE Extreme, that it is all of the years, in which we all participate. This initiative was first developed because we have few participants and we wanted to improve, of course. So please, next slide. We wanted to improve, not only in the number of our teams, as we can see in this slide. In the IEEE Extreme 16, we had 150 and 85 teams. In the next one, 270, and in the next one, almost 500. But the difference was that we got a third place the last year, actually. So we achieved that because of this kind of initiatives. We had some teachers, we have some training, so we could manage to do that. Next slide, please. Computer society also is a relevant key sponsor in the student branch regional meetings. This year was held in El Salvador. The last year was held in Cartagena. Computer Society has some workshops over there in which promote, of course, the chapter, promote to start new chapters in different universities, and of course, promote to enhance new leaders, right? Next slide, please. And our main congress is the CLASIPS. That stands for Congress of Latin America Students and Young Professionals of Computer Society. The 2023 version, that was the first one, was held in Cartagena. In these versions, we were trained as a leaders for the first time by some exceptional leaders such as Roberto Moreno or Eric Berskonsky, main leader of Computer Society. And we have different activities over there, of course, to promote our chapters, to improve our student chapters. Next slide, please. Whereas this year was held our main congress in El Salvador, we changed the name. The name was Computer Society Students and Young Professional Global Congress. So we had some kind of different activities here. We had the opportunity to get to know the data center of El Salvador, which has TIER 3, level 3, that it's a certificate, a worldwide known certificate, and this is one of the most important data trust data sites in the world. We have a conference with George Proller, and well, different congresses, right? Different conferences, so we could improve our leaderships, of course. And well, next and last slide, it's an invitation for all of you guys that want to join us in our next Congress, that it is going to be held in Uruguay. Next slide, please. It is going to be held in Uruguay in October. We have yet to release the dates. And we would like to invite all of the people, all of the world, to have a different kind of Congress where we can unite all of us, and where we want to do some special activities, and of course, some surprises. So I guess that's all of the presentation. Vane?
Ok. ¿Alguna pregunta? ¿Alguna consulta? Bueno, mientras esperamos que respondan alguna pregunta, Cristian, ¿nos quieres contar cómo tu experiencia a lo largo de toda esta trayectoria que has tenido? ¿Cómo te sientes tú? ¿Cómo te has desarrollado? ¿Cómo sientes que te has desarrollado como persona?
Ok. Bueno, pues ser parte de Computer Society no solo me ha ayudado a ampliar mi red de contactos, ya que, bueno, eso yo creo que ha sido el principal factor por lo que hemos estado aquí. He podido ampliar mi red de contactos, he conocido a muchas buenas amistades, he tenido la oportunidad de trabajar con muchísimas personas Y lo mejor de todo, yo creo que ha sido que he podido aportar un poco a mi país, a que quede un poco menos rezagado, diríamos, y poder tener la oportunidad de poner mi granito de arena, vaya, para futuras generaciones. Entonces, no es un camino fácil, ya que tienes que eh, tener mucho tiempo, bueno, dedicar mucho tiempo, ¿no? Dedicar mucho tiempo, pero al final del día esto es un voluntariado y pues hay que sacar adelante, ¿no? Hay que sacar adelante el capítulo, el país, la región y al mundo.
Gracias, Cristian. ¿Alguna consulta, alguna pregunta para Cristian? Ahí tenemos una pregunta. Dice, ¿qué deberías lograr SIEP para este 2025?
Bueno, en Students and Young Professionals, 2025, tenemos un plan de integrar a más voluntarios de toda Latinoamérica, ya que hemos detectado que hay muchísimo talento. Sin embargo, este talento es desperdiciado, ya que no se acercan mucho los voluntarios o no se toman en cuenta, vaya. Entonces, con este equipo que tenemos, liderado por Roberto, hemos estado, hemos estado implementando un plan en el que integremos más a voluntarios y, por supuesto, que llevemos a Computer Society a regiones dentro del mapa que, que no se encuentran, ¿sí? Reactivar Computer Societies que han estado cerrados, fomentar a nuevos estudiantes a abrir sus propios computers y lo más importante es fortalecer los Computer Societies que ya están, ¿no? Este año s- hubo premios por primera vez a nivel Latinoamérica, en donde pues pudimos reconocer a los estudiantes por su gran esfuerzo. Y pues eso es algo que es muy motivador, es lo que yo pienso. Y pues que con ello más estudiantes van a querer seguir mejorando.
Gracias, Cristian.
Sí.
Cristian, ¿qué te pareció la experiencia de Computer Society SEP Global Congress 2024? ¿Qué expectativas tienes para el año que viene?
Bueno, cada año es especial, ¿no? Cada congreso es especial y único, que siempre queda en nuestros corazones, en nuestras memorias y pues que nunca lo vas a cambiar, ¿no? O sea, nunca vas a decir ese no, ese acá y ese de más, ¿no? La experiencia es una experiencia, ¿no? De por vida. Lo que me pareció fue que fue un congreso inolvidable. Tuvimos muchas bonitas experiencias, como mencioné en la presentación. Tuvimos la oportunidad de ir a un data center de Tier 3. Tuvimos la oportunidad de presentar qué es lo que hacemos en nuestros capítulos. Tuvimos la oportunidad de hacer networking y de promover colaboraciones internacionales, que ya por ciento se están preparando algunas para este año que viene. Y para el siguiente, para la siguiente edición, pues se va a intentar hacerlo igualmente inolvidable. Para la siguiente edición estamos invitando a gente de todo el mundo. Y también le vamos a agregar un toque especial. Estamos viendo la posibilidad de que podamos tener papers, aceptar papers y ser publicados. Pero eso es una iniciativa que aún no está, ¿cómo se dice? Bueno, que aún no es un hecho, vaya, ¿no?
Aprobado. Todavía no está aprobado.
Muy cierto, gracias. Aún no está aprobado. It's in progress, yes, as a matter of fact. We are going to have papers, may have papers, I meant, in the next CLASSIPS or Global Congress 2025. So we invite everybody again to come. It's going to be an unforgettable Congress at the end of October 2025.
Vale. ¿Alguna otra pregunta? ¿Consulta? Muchas gracias, Cristian.
De nada,
Ahora,
es un placer y un honor representar a Latinoamérica.
por supuesto. No sé quién le tocaba a Karen, si no me equivoco.
¿Cierto?
Sí, aquí estoy. Hola.
Ok.
Le damos el pase a Cristian a la moderación. Muchas gracias, Vanessa.
Gracias, Vanessa. Bueno, buenas tardes. Good afternoon, everybody, again. Karen, ¿tu presentación es en español? ¿Es en inglés?
En inglés.
Okay. Just a second. Can we take 2 minutes break? No?
Computing is expansive.
Computing is evolving.
Computing is limitless.
We are the IEEE Computer Society, the professional home for all computing.
We bring together passionate engineers, scientists, academics, and industry to cultivate environments for idea exchange, dialogue, debate, and collaboration.
We set the standard for learning that empowers, with peer-reviewed publications and international conferences, local chapters and meetings, and valued resources.
We support members, we cultivate leaders.
We help computing professionals at every stage of their career.
We are the IEEE Computer Society, your professional home.
Computing is expansive.
Computing is evolving.
Computing is limitless.
We are the IEEE Computer Society, the professional home for all computing.
We bring together passionate engineers, scientists, academics, and industry to cultivate environments for idea exchange, dialogue, debate, and collaboration.
We set the standard for learning that empowers, with peer-reviewed publications and international conferences, local chapters and meetings, and valued resources.
We support members, we cultivate leaders.
We help computing professionals at every stage of their career.
We are the IEEE Computer Society, your professional home.
Okay, guys. So, good afternoon, everyone. Thank you for joining us for this event again. So, it's a pleasure to introduce our esteemed speaker, Karen Tovar. I'm going to read briefly. Karen is a AI and machine learning at the data side with a background in engineering from the University of Costa Rica. Over her 4-year research career, Karen has focused on application of AI and machine learning in medicine, biomedical engineering, and materials science, resulting in publication in prestigious national and international journals. Karen also holds certification in quantum computer from QISKET and the Quantum World, showcasing her interest and knowledge in this area. Her innovative work has been showcased at renowned conferences, including the annual international conference of the IEEE Engineering in Medicine and Biology Society in Sydney, Australia. As a member of Women in Engineering and the Computer Society, Karen has led initiatives to encourage young women to pursue STEM careers, demonstrating her commitment to diversity and inclusion in technology. First of all, I want to apologize. The letter is really small. So Karen is going to talk about exploring the quantum world, how qubits, if I'm spelling it correct, qubits are changing computing. So in this talk, we will take the audience on a fascinating journey on the heart of quantum computing, exploring how qubits are radically transforming our view of technology, from the classical logic of bits to the concept of superposition and entanglement. We will explain in simple terms how qubits work and why we are fundamental to the future of computing. So please, Karen, tell us more about this.
Thank you, Christian. I think I can share my screen.
You cannot, or you are?
Yeah, can you see my screen? Yes.
Yes, we can.
Okay, great. Thank you. So hi, thank you for having me today. I'll talk a little bit about quantum computing, just like the basics, how everything is working with the qubits versus the bits, and just like for you to